Hi, everyone, and welcome to Data Science Global Summit 2022 from Geekle. And we're excited to welcome you. I have Nick here. I have Lilia with us. So Nick is the technical director, and Lilia, she's the community manager of this event. And yeah, we're excited to welcome everyone. And we have more than 3,000 registrations for this event, and we've been preparing it for the last 4 or even 5 months, regardless of the war that's happening in our country in Ukraine. We were able to actually gather awesome speakers, and Nick will tell us a little bit more about the format, and Lilia will tell us more about the topics that we have. And yeah, we're excited to welcome everyone. Nick?
Thank you. So, yeah, we have 3 days of topics ahead of us. We have way more than 24 hours of content, and it will be divided into blocks. So today we'll have the beginner track, free for everyone. Feel free to share. And today we'll talk a little bit about getting into data science and first junior level topics. But tomorrow we'll have a pro track. We'll have around 12 hours of topics with the latest, the most relevant topics. We'll also have a boot camp on Thursday. So this is kind of an experiment we decided to do here at Geekle. We usually have separate workshop, but this time we decided to include some workshop content in this boot camp day.
Yeah.
Well, this is still an experiment, but yeah, hope you will enjoy. We have some more talks for you on Thursday. We'll have some workshop content for like an hour or hour and a half of just speaking, sharing the code. So yeah, that'll be fun, and definitely you will get lots of insights. So Lilia, can you tell us more a little bit about your speakers?
So hi everyone, I want to say a big thank you to all speakers and program committee who join us and help to organize this summit. It was very exciting to start a new direction, and 30 speakers will perform for our participants for these 3 days. You will be able to hear a lot of useful information that our speakers will share with you. Our event will include 4 main topics. It will be data science kickstart, MLOps and data engineering, machine and deep learning, and NLP. So our speakers will share with you experience and some use cases. As Nick mentioned, we will have 2 tracks, one for beginner, for people who have less than 1 year experience, and pro track for people with deep tech knowledge. I hope you will enjoy this event, and I hope that we will meet soon in November, because we planned one more data science event, and we will reconnect with user.
Yeah, more information about this event will be in the chat.
Yeah, and also we have a special giveaway for our beginners, for our junior day. We have 10 free tickets for our pro and our bootcamp days. We have a raffle, so please be active in the chat. So the requirements in order to win this ticket, please ask questions. So we will have different talks today, and you can find the full agenda and the names of the topics and abstracts on our website. So basically, you can read them and you can ask questions during the Q&A session, and then our speakers, our program community, they will basically choose the most interesting questions, and you have the chance to win yourself a ticket to the pro day and to the bootcamp day. So yeah, please be active. We really appreciate your questions. And I'm going to be the first moderator for this event. So I'm staying here. And thank you, Nick. Thank you, Lilia. And yeah, let's start this event. Okay, so let's start with the first with our first speaker, and the first speaker will be Serg Masis from Syngenta, And the talk that he will be presenting is the roadmap for your data science journey, myths and tips. And this third block of talks will be a data science kickstart. So if you're just starting, this will be a great introduction for you to learn a little bit more about data science and about the concepts. And as I mentioned, Serg, he is the climate and agronomic data scientist. So he will present quite interesting approach to how to start actually your way in data science, and he will share the roadmap for those who just start their career. And yeah, without any further ado, let's check out the presentation from Serg.
Welcome to this session on roadmap for the data science journey, myths and tips. The talk is broken down into 2 parts, each one into 3 sections. The first part is really short. It's just simply about myself, since I'll be speaking about the journey. I'm using my journey as a little bit of an example in some parts, so it is helpful to mention that. Then the advice for your journey, first the training part, how do you learn what you need to learn? Then how do you get your first job? In other words, how do you get your foot in the door? And then making your mark. How do you continue to establish yourself in the field? So first, a little bit about myself. I'm a data scientist with an extensive background in entrepreneurship and data-driven web app development. What led me to data science was an interest in decision making, not only through algorithms, but also the human aspects via cognitive science and behavioral economics. Hence, I'm passionate about providing the missing link between data and decision making. And machine learning interpretation and causal inference helps bridge this gap more robustly. This led me to become the author of a best-selling book called Interpretable Machine Learning with Python. Now on to the second edition, which will be out at the end of the year. Okay, as for my journey, it's been a fairly long journey. I was a geeky teenager, so I was very interested in databases, in data in general. I learned some very old school databases while I was in high school, spreadsheets as well. Before they had the graphical user interfaces they have today, or even any kind of internet connection, connectivity or cloud interface like they have today. Then I got involved in websites. By the middle of the 90s, I was making websites already, very static ones. And then my first data-driven websites were actually towards the end of the 90s with my first full-time role while I was in college. Um, and so I worked with databases like Oracle, MySQL, Postgres, and many others. There were a lot of limitations back then. Um, and then as data became bigger, I became more involved in big data and then analytics of the data coming in. So, crystal reports, a bunch of things like that, ETL, um, analyzing data through, very crude BI tools that existed back then. And then also A/B testing to optimize websites. It was also in 2006 where I first had a leadership role. And yeah, that was also very formative for me. Later than that, I got involved in big data and machine learning, but that was until the mid 2010s, 2014, 15, and so on, when I founded a search engine startup. So for the first time, I had to learn how to do ETL on a larger scale, SQL databases and machine learning methods. Um, Around that time, my startup was incubated at Harvard Innovation Labs, was a finalist to something called the President's Innovation Challenge at Harvard, which is very prestigious. And then I went through getting a master's in data science. So I went back to school. Uh, I learned more about computer vision, more about big data technologies, and got a better understanding on statistics. I took a greater interest in interpretable and machine learning, which is something I had encountered a little bit while I was in my startup. And then I wrote a book after I graduated, of course, a couple of years after. I wrote a book on interpretable machine learning. This was during the pandemic. I also had I got the job I have right now, which is on agronomic and climate data. And then that's that's about it. That's my story so far. Okay, so my vision has been to lead organizations at improving decision making by leveraging descriptive, predictive, and prescriptive analytics, but more importantly, enabling with the interpretation and optimization of outcomes, models, and processes involved. So to the right, you see something I did for a prior employer called Formlabs, which is like a visualization of all their KPIs and where they're located within all their processes. So I do a whole bunch of stuff. This is just one of the things I can do. So my purpose, I have found, is at the middle of all these things. So I don't know if you've heard of this Japanese concept of ikigai, but it's precisely kind of encompasses of sense of fulfillment. And I found that the sweet spot is in the middle of what I love and what I'm good at. And fortunately, I get paid for it. And it's also something that is good for the world, which is great. It's also one of my constraints because maybe the world needs something that is not good for it, right? So I want to be good. I want to do something that provides, that aligns with my values. Whatever it is I define as good. So environmental sustainability is one of those things, and I'm glad to report that what I do is good for environmental sustainability. I also can do it while having a good work balance, so I'm well, and I also feel free to do other things as well. So that also complies with my third constraint. So I also had an advantage, which was I had many years of experience before I decided to focus on data. That provided ample opportunity for self-discovery and skill development. I learned that I had passion for data and that it was reasonably good at data-related tasks. If you're a newcomer in the field and aren't sure what you love and what you're good at, I suggest you start with the self-discovery process. I'm getting ahead of myself, but I think there's many paths you can take. There's not one path to become a data scientist or work with data. So here comes my advice for your journey. So going through unicorn training, orgs, a lot of them seem to want the proverbial unicorns. That is full stack, jack of all trade, perfect at everything generalist data scientist. But reality is you can be very successful without trying to become a mythical creature. Besides, it's mythical, so it's impossible. Um, First of all, data science is a vast body of knowledge. Don't believe the hype. It's impossible to know everything because data science is too big of a field with so many areas that have yet to be explored. Since so many fields overlap in data science, it's not without loaded terms and controversial topics. So it's important to not see it as textbook learning, but something that will evolve. There are fundamentals that you should, that where you should be strongest, I believe. Then explore everything else to figure out your niche. That being said, be careful. This vast body of knowledge has monsters where you least expect it. So the way I think about this body of knowledge is that it's like a vast ocean with many areas yet to be explored, and others were sea monsters. And this part is the one that many newcomers associate to the field. But I mean, by this part, I mean this part of the map. Um, even if they're aware of other areas, it seems to be the, the deep end of the pool, where all the cool kids hang out. As you see, there's machine learning here, there's data engineering, there's deep learning, there's Kaggle, MLOps. However, this is the wrong way of looking at it. This portion includes many ways a newly discovered and exploited area of the ocean, but it's not always the most valuable. Most importantly, it can be dangerous for initiated seafarers to venture off into the many rough waters located in many of the parts here, and it's not where experienced sailors can best learn the ropes anyway. So this is what I mean about, the truly deep end of things. These are like pretty much the power tools you can use in many data science applications, and they don't apply to everything. So you got to be careful and know when to use them and when not to. There's also safer and more grounded side of the North Ocean, north of Treasure Island. It comes with all the classics that are fundamental to scientific inquiry, such as probability and statistics, hypothesis testing, experimentation, statistical learning, and so on. I suggest you start in the lowest common denominator because every single area of data science requires descriptive statistics. And more often than not, other even more advanced forms of statistics and mathematics. You've probably heard of how you'll need linear algebra and calculus and so on. But there's other areas like information theory, game theory, graph theory, and so on. To the east, there's business applications such as business intelligence, operations research, financial quantitative analysis, which is one of the granddaddies of machine learning and big data. They've been leveraging these tools for, longer than many of us have been born. So to the west, you find the exciting field of biostatistics and other granddaddies of data science, such as actuarial science, econometrics, and geographic information systems. Again, a lot of these fields have existed for much longer than a lot of us have been born. Many fields like this aren't often even seen as part of data science, but they're popularized many methods and technologies used today for more general purpose applications. They're worthwhile exploring because perhaps your favorite kind of data is financial, biological, actuarial, logistic, geographic. Or so why bother with going for what's most popular, if what you can zero in exactly what is useful for what you want to do. Okay, another aspect that is important to understand, it's easy to confuse the tools for the job. When you're a data scientist, you're not just a Python programmer, Tableau whiz, or PyTorch expert. There are many tools, but reading an instruction manual will not prepare you for the job. You have to know why and when to use it. Data science is also less about the tool and more about the material, which is data. You have to be well versed in the material you're working with. It's like being a carpenter. When you're a carpenter, the material is wood. So you have to know which pieces of wood can become good furniture and which ones are destined to become firewood. You have to know the difference. You have to understand all the nuances that come with wood, the grain and the type and so on. You have to understand that and understand the differences, hardware, software, etc. The same goes with data. And sometimes you have to inspect it closely to understand things with issues it could have with quality that might make it very poor for machine learning, for instance. So have to understand how to improve it, how to improve the data quality, how to protect it, how to mitigate it, and so on. So another thing that's also important to take into account during the journey is that learning and growing is gradual. Nobody started at the finish line. In fact, in data science, there's no finish line, but we all started from zero. It will take you time and effort and patience. There's no magic book or 6 week course or method. It will take, as I said, time and effort and patience. As you see here to the right, I started going to the Open Data Science Conference first as a volunteer, which allowed me to enjoy the conferences for free, then as an attendee, and then finally as a speaker. So it's a bumpy ride, but you're not alone. You will experience highs and lows. I suggest you manage confidence and self-esteem. Learn from your mistakes. You don't have to be too harsh to yourself, but also be wary of overconfidence. So now I have another section, which is getting your foot in the door, which is about how to get an entry level position when experience is always required. So there's a few hacks here. First, if you don't have an experience, you have to make your own experience. Create projects that have a business use case, a clear real world business use case, and then design a prototype. It must be creative and well thought through. No cookie cutter stuff you copied off of Kaggle. Think of projects that would impress or be useful for companies you would want to work for, and do those. To the right, you see a drowsiness detection computer vision project I did, with machine learning back in 2018. So another thing is to cast a wide net. Competition is fierce, so don't apply to only 10 jobs. Apply to at least 20 a week till you start to get traction. Don't wait on others. Don't be like, okay, I'm only going to apply to people I know, referrals. That referrals can be helpful, but don't just focus on those. Don't focus on only the FANG companies. There's exciting data science jobs in all kinds of companies. And now, this is a side note, but it's important. Anyway, some of you might be too young to remember 1999, but it was the year of the Matrix, the Fight Club, SpongeBob SquarePants, Britney Spears, Star Wars Episode 1, and the craze for Y2K. It was also the year of my first paid job, as I said earlier on. I was a web developer back when most people dialed up and websites looked like this. Also, in the early days, it was so easy to get your website ranking in search engines because there weren't that many websites. But that started to change as internet became more crowded and search engines became more clever. So it became difficult to rank, so websites had to leverage something called search engine optimization. So here you go. Just as it's difficult to get a website to rank into the top spots in a search engine results page, these days it's equally difficult to get your resume on the top of a pile of resumes screened by recruiters. You have to understand that recruiters often get over 1,000 resumes for a single position. So they're not going to look at every single one, which is why their systems they use do this for them. They rank them for them, and if they have to automatically reject some applications, they will do so. So how do you overcome this? The trick is to optimize your resumes just as you would a website through SEO. In other words, make sure that the keywords being searched for match the content you are offering. That is, if the job description features X and Y and Z keywords, your resume should include them organically if and when possible. But don't make the mistake of sending the same resume for hundreds of different roles. Each job description is different, so it doesn't make sense to send the same resume. Right now, applicant tracking systems automatically filter and sort applications based on if they have the right keywords and even if the years of experience required they count them and see if they match. The most sophisticated ones use machine learning to screen you. I suggest you make different versions of your resume and cover letter based on the job, and even tweak a little for the job description. As you see to the right, here are a bunch of different versions of my resume. I have a general one for computer vision, one for geographic information systems, one for NLP, one for time series. Then sometimes I tailor them to a specific companies based on I found some additional keywords that weren't there, or they wanted more of this kind of experience. I happen to have it, but let me highlight it. So you have to do that. Unfortunately, it's going to take more time, but it's going to be worth the effort. It makes no sense to invest the time to make an application, which is somewhere between 5 minutes if you're lucky to 30 minutes if you're unlucky. If it's simply going to slip underneath to the pile, kind of sink to the bottom of the pile. If that's going to happen, then there's just really no point. So you have to put a little bit more effort to make sure that it has a greater chance of getting to the top. Okay, so you want to be a data scientist. So this is par for the course. To think strategically, you need to track the process and record every data point. Fortunately, you should have the skill sets to do that if you're thinking seriously about this job, or you should have already, before you applied, already worked on projects where you're building this skill set. Doesn't need to be a complicated thing. It can be a spreadsheet. Put the name of the company, industry, role, title, salary range, link to the job description, date applied, and what date it reached to every other stage. I also myself ranked it based on my own interests to know how I prioritize it. This is important, so at a glance you realize how much effort you should put into scheduling a coding test, or if you should try negotiating a better salary. You should have an idea at a glance of where are like the low-hanging fruit. And so this is a Sankey diagram based on that kind of workflow. And it's important that you track it. You don't have to make a Sankey diagram, but it's important that you track it so you can improve the process over time, because it might take some time. The whole process of applying, unless you have every single thing employers are looking for the kind of position you're applying, should take a number of weeks, sometimes a number of months. So tracking you can improve what you can't measure, basically. So the last section is making your mark. So what it's about is how to continue to advance your career in the direction that is best for you. So the first piece of advice I have is embrace I don't know. It's a big field, so it's okay you don't know every topic or every method or algorithm. Admit it. You can ask someone who does or Google it. Your colleagues will appreciate it. Your manager will too. When they say, okay, this guy has humility and he says, I don't know, maybe it's an opportunity to opens up opportunities where they'll pay for a course for you to take, pair you up with someone you do know, and you get a lot to gain from it because you're going to learn on the job. And that's an amazing opportunity when you get to do that, because that's probably the best way to learn once you have already have a job in data science, because you can read all the books you want, but they're not going to be the sort of real world scenario that you'll get on the job. So another thing is comfort zone forbidden. Be prepared to learn new things all the time and dive deep into them. Be prepared to do things you never imagined you would do. Like here I am speaking to you guys on this conference. I never imagined I would be a speaker. Not once, much less dozens of times. I didn't imagine I had it in me. I was super shy. Why would I ever do that? But that is part of what it is to be a data scientist. It is communicating things, ideas about data is a large part of the job. So, don't get comfortable with the part of the job that doesn't involve that. Not everybody has to be speaking at conferences, but you'll probably in this career find yourself speaking in boardrooms or in team meetings, and you have to communicate very clearly. This brings me to another point. Data doesn't speak for itself, so you have to speak for it. Data problems are not often a one-man job, so you'll have to be able to work with others. Real-world data can come with many surprises, so you have to be adaptable. In other words, strengthen hard skills just as much as you strengthen soft skills. And data science is a creative pursuit because data is super malleable. I was speaking about wood earlier. It's not like wood. It's closer to Play-Doh. You can do so much with data. You can transform it in so many different ways. Don't get stuck on one way of doing things. Like I've been in projects where I take data that others would look at it and say, okay, this is clearly a time series problem. This is going to be modeled as a time series problem. No, I aggregate it and I turn it into a tabular problem, and the project works so much better that way. I've had projects where everybody sees it as a regression problem, and I turn it into a classification problem. But I made all the changes to make that happen. So there's a lot of transformation that can be done. There's a lot of adjustment. There's a lot of, and in the data cleaning process, there's definitely like also another kind of transformation that happens to the data. And it's important to get to the point to know what to do with the data. You have to play with it, as with the process. And this is where you use both sides of the brain when dealing with data. Don't always follow recipes. Feel free to color outside of the lines. Lastly, it's important that you share your knowledge, you share your ideas, you share your work, whether it's to pay it forward or help promote yourself, because it can lead to opportunities. It will be a gratifying experience to engage with colleagues and learn from each other, if anything else. Also, you don't have to be a social media influencer to do this. You can share with coworkers or strangers in local meetups. You don't have to be posting all the time in social media. You can post in your own pace if you're doing social media. You can post things that you like, and you'll find people with commonality with you. And again, that it will work the other way around. You can learn from others in the same way, and that way be part of this, an active member of this global community of data scientists, because the field is evolving so quickly. If you're not active, you're gonna be left behind. That's the reality of it. It's not that the textbooks and the courses they're always a few steps behind of what's being discussed in academia, what's being discussed by practitioners. It's always a little bit behind, and so you have to be catching up to this. Anyway, it's been a pleasure to talk to you all, guys. I hope to hear some questions from you. Thank you for listening. You can contact me also directly, or connect or follow me through these different platforms. Thank you.
Everyone, if you have any questions, thank you, Serg. If you have them prepared already, please head to the comments and head to the chat and ask your questions. And this will be your chance to win yourself a free ticket for the pro track, and for the senior day, and for the day with the bootcamp. And I want to introduce and invite our next speaker, Daniel. Munoz. Hi, Daniel. How are you doing today?
I'm doing great. How about you?
Doing awesome. Thank you for joining us, and thank you for sharing your time with us. Thank you for preparing a talk for us, because AI is another cool and important part of this whole data science story. And just a couple words about yourself. So what's your current position? And I heard you're moving to Microsoft.
That's right. So yeah, I used to work with Fiscal Note as data scientist slash all-encompassing AI professional. So basically, that would mean, hey, there's this task that we need to figure out. Well, what is the best way of figuring that task out? Going all the way from analyzing data to, okay, now this is a practical behavior, the practical problem that we're solving. And then basically that sort of knowledge and way of thinking is the same kind of thought process that I'm going to be applying at Microsoft, where I'll be joining their what they call the Nerd Center, the New England Research and Development Center, and I'll be working there as a machine learning engineer as well, right? So I've been able to sort of like see along with other friends of mine what the process of the industry or getting into the industry looks like, and there's a lot more than just being a data scientist to be able to work in AI, right? Like there's a lot more roles, and so I just kind of want to talk about that whole encompassing journey because there's many ways by which people are able to actually join that industry.
Exciting. We appreciate your time joining us. And I guess without any further ado, the stage is yours. And thank you once again.
All right. Awesome. Thank you so much. Great, everybody. So thank you for joining me today. I'll start just by saying, if you have any questions, drop them in the chat. I'm more than welcome to be able to address those questions as they are heading out and as you're typing them in the chat. Now, first, I would like to talk a little bit about what kind of roles exist in the AI industry, right? So, as previously mentioned, there exists the data science role, right? The data science role, everything was sort of like a breakdown and talked about earlier, right? Analyzing data, figuring out what are different models to be able to use for that data, so on and so forth. Now, the thing is, you don't just want to come up with a model for that data and come up with a prediction value and then stop there. Why? Well, because at the end of the day, there have to be a value add that you are producing for the company or for a research lab or whatever it may be. And that is where this aspect of what could be called machine learning engineering would come into play. So in this case, you would say, okay, well, someone in the company or a group of people came up with a machine learning model to, let's say, classify two different kinds of emails or support requests from a customer. Well, now that we have this model, this predictive model, we would then be able to productionize it, basically wrap it into, let's say, an API and an application programming interface, and then be able to utilize that in, say, for example, an admin dashboard, where we're able to monitor what is the ratio between severe tickets versus non-severe tickets, right? And this is an insight that we otherwise would have not been able to get had we not, A, made a classifier, yes, but also B, be able to wrap it and make it into an API and then hook it up into the dashboard, right? And so now we're kind of talking about this whole all-encompassing roadmap of going from there's an idea, there's an idea of, hey, there's this model and there's this data that we would like to make into something useful, and then going into making it actually something useful. And that whole pipeline includes a lot of different things. Yeah, like for example, it's Rafkat is also saying like there's also data mining, right? Like there's that aspect of going ahead and extracting the data, right? Like data is not just gonna fall out of a tree, or it's not just gonna be there readily available as there would be with, say, for example, Kaggle, right? Like you're gonna have it coming in all sorts of like different ways, and you're going to have to be able to, or the teams, the companies, the research institutions are going to have to pull up the data from somewhere, right? Come up with the models, the prototypes, the hypotheses, uh, create those proof of concepts rather quickly, and then expand and iterate on that, right? So there's many different such components of what AI work in industry looks like, right? Let me just see. I have learned from many platforms that you cannot self-taught yourself data science. Or are your thoughts on that? Well, I think actually, yes, you can teach yourself data science, and broadly speaking, machine learning for a couple of different reasons. First of all, the field of, broadly speaking, computer science, of which data science is a subset, I would say that that field is entirely open. Um, that field is entirely open, and that is something that you're able to have the research papers freely available. There's people that produce a lot of online content, so on and so forth, right? And so you're actually very much so able to go ahead and take all of that knowledge that if you were at a private institution or like a university, for example, you would actually be able to learn all of those things, right? Like having come from a US university, I can tell you that a lot of the things that I learned from online, from YouTube, from reading papers that were freely accessible, right, under no paywall, uh, and from just like trying things out, right? So definitely you are able to come up with a roadmap of things to learn, and then learn them on your own, building side projects, so on and so forth, right? And that's actually part of the reason why I really do think that it's important to not just think about, okay, I'm building a machine learning model and it lives in my Google Colab, in my Jupyter notebooks, and that's it. Why? Because at the end of the day, what is it that you're trying to accomplish? Well, you're trying to deliver value and deliver insights for companies. Let's say that you're trying to get into the AI industry as a practitioner, and not as a researcher. And so if you're trying to do that, the most important thing is to be able to give value. And sometimes giving value doesn't mean you coming up with the model itself from the get-go. Sometimes it may mean for you to combine a bunch of different techniques together to then be able to come up with the right answer, or something that would be very helpful, right? So now let me address a couple of other questions that have been posted here in the chat. So does learning programming in backend help to become a data scientist, a data engineer? Okay, great question. So I would say one of the first things to think about is not just about being a data scientist, data engineer, right? There's actually a couple of different positions that are out there in the industry. And so, for example, you have machine learning engineering, uh, which, for example, would include, okay, how do you take this model and make it into something that can actually be used in production? Basically, users or the business utilizing it. A certain part of that is also what's called machine learning operations, or ML ops. So that's sort of like also thinking about the different containers that you might put these models into. Also thinking about A/B testing and how do you even do something like that. Also in industry, one of the things that's very interesting about the data science, computer science field in general is that you also have researchers producing research out there, right? And the thing is, it's not just your big companies like Google, Microsoft, OpenAI, DeepMind coming up with research. Actually, at many other companies, say for example at FiscalNote, we actually come up with research and research questions. And the reason why this is like very, very important and something that we do is because we are always trying to figure out what are different insights that we're able to produce and what are different pieces of information that we're able to incorporate into the business and then create valuable insights for our customers, right? And so going back to that question, does deep learning and does learning programming in backend help? Definitely. Why? Because it gives you another tool in your tool set to come up with a company and say, hey, not only can I create a machine learning model, but I can also make it into something that is going to be actionable and usable for your company. And that means that you're not going to have to hire another person to be able to do this. I'm going to be able to do all of these different things. So definitely, I think programming in general is going to help. And so one of the things that I would say, if you're thinking about, okay, how do I practically get myself from I am a beginner to I'm going to be like a very skilled professional that people are going to be willing and wanting to reach out to and to work with, what I would say is start by just sort of like studying the very broad overall overarching basis. So this would mean, say, for example, looking at something like fast.ai, fast.ai. And what it is what's called practical deep learning for coders. That is a wonderful course. And they basically go ahead and break down how do you use pre-trained machine learning models to fine tune on data and then be able to start delivering insights and value from the get-go. And these are actually one of the biggest, most important sort of like techniques. So if you were to come out of this conference with one thought, is that you don't have to train all of your models from scratch. You can actually use models that other people have trained, and then through this process of fine-tuning, basically adjusting to data that you do have access to, then go ahead and train them a little bit with not as much data, and then go ahead and then go ahead and fine tune this machine learning model, and then be able to start delivering insights, right? So this is actually all of the, for example, one of the things that does happen is there's a Huggingface transformers library, and that Huggingface transformers library is all about fine tuning, right? So you have, for example, models like BERT, you have models like GPT-2 available there. Recently from Meta, the open pre-trained transformer, so on and so forth. And these are all models that you're able to take in, fine tune to the specific test that you're trying to do, and then from there be able to go ahead and you can, because it's now like a very well-developed library, you could actually take these machine learning models that you fine-tuned and then wrap them into, say, for example, an API using something like Fast API, and then from there deploy it, let's say, on AWS Lambda, and then there you go. Now you have a very clean and neat API, and then from there you can go ahead and create a website for this. So that's how you would go from, okay, I collected some data, maybe on Kaggle or maybe on my own. Then I went ahead and created a model. Then after creating the model, I went ahead and wrapped it into a fast API. And then I created a front end that I was able to integrate all of that, right? And so now you just basically went from the entire stack. And now as you went through that entire thing, you're actually also experiencing, okay, what does it feel like to work on all of these different components, and what parts of it would I like to specialize in, right? So I think all of that is like a great journey of not just being able to learn these things and teach yourself this, but also to be able to come up with what is it that you want in particular your specialization to be like. Okay, yeah, so how do you prepare for machine learning interviews and stuff like that? So I would say there's a couple of different things like that. So if you're going for more like machine learning engineering positions, research engineering positions, then what I would say is that you're also going to be doing a lot of like lit code grinding and maybe some sort of like broadly speaking machine learning questions, right? So those would be, say, for example, the variance versus bias sort of like trade-off, talking about linear separability, what is something that's like linearly separable or not, right? So a lot of these sort of things that are kind of like data science basics, right? So those would be sort of like some of that. And then, if you're going for more sort of like niche particular topics, right? Let's say that you're applying to be NLP specialist at a company, right? Be it NLP data scientist or NLP machine learning engineer. They might ask you more specific questions about NLP, right? And this is actually why I would also say it's very important to develop that experience of actually building things out, because then you're going to be able to talk about, okay, well, actually, I built this before. This is one of the problems that I ran into, or this is one of the situations that I had, and therefore, this is how I would address it. Let me see. Given how competitive the field is, do you think that it is realistic for someone without a quantitative degree to enter AI and ML, provided one has several real-world projects such as portfolio? Yes, absolutely. Actually, one of my own personal managers and mentors, he is someone that doesn't have a formal degree. Actually, he has a degree in I think it's Russian studies, and it's not something that like is specific to AI, machine learning, none of that, right? But what is it that he did? He was able to create things that were valuable. He was able to create insights. He was able to create pipelines of data and combining those different models to create something valuable. And so because of that, he was then able to create a company and then get acquired, right? And of course, you don't need to go ahead and make your own company and go ahead and then get acquired. But that just goes to show that if you are committed to learning and developing your skills, there's really no limit. And one of the big reasons for that is that there's actually a huge lack of people that have this kind of knowledge and it's actually able to like produce value. So actually, I have a friend of mine, another friend of mine that I met recently. They went from because of the whole like recession situation that is going on, losing their job, and then in 3 weeks, being able to get another job as a data scientist or a machine learning person working with NLP in 3 weeks, right? Like, so yes, there it is competitive to a degree, but once you have the skills, once you're able to talk about it, then it becomes a lot easier to be able to get noticed and to be able to actually get those jobs. Reason being because there's a huge lack of people that have these skills, and if you show yourself that you're someone that is capable and willing to be able to learn and grow, that's one of the most valuable things, because as they were saying earlier in the previous talk, you're not always going to know everything from the get-go. You're not always going to be ready because the field evolves. A couple of years ago, I was just talking to a friend of mine about it. A couple of years ago, transformers were not a thing, and now they are. And because of that, the field got totally revolutionized, and now we have massive language models and bunch of different things like that was not a case before. And so there's always going to be an improvement in the field. There's always going to be a new change. And because of that, if you are someone that's capable of just like teaching yourself things, then that's one of the most valuable things that you can do, because you're always going to be then catching up to the industry, to the state of the art, and always be able to bring valuable insights to your company, to your colleagues, to whoever you're working with. So okay, well, one question more along the lines of like preparing for interviews and stuff like that. How would you prepare yourself? So there's a couple of different things, right? So what you can look up is you can look up data science interview questions. go through those and study. Okay, well, there's this question. How would I answer it? So on and so forth, right? This works perfectly also if you have friends of yours that are also trying to break into the field. And then, for example, sometimes you might be looking into the data structures and algorithms, DSA. And so in that case, for example, that would be something where there's things like the blind 75, and then it got converted into what's called the grind 75. Those are two sort of like different sets of data structures and algorithm questions that are all focused around developing those skills so that then when you're in an interview, you're able to crush the interview. And speaking of interviews and all the whole world, one of the things that I would say is that when you're thinking about getting a job in this industry, or not really in any industry, but at least in tech, there's, I think, 3 levers that you can move and that you can play around with to then change the probability of you landing the kind of job that you're looking for. So what are these 3 levers? The first lever that is there is being qualified. So this is kind of like what we were talking about. This aspects of developing knowledge in the industry, right? Let's say in data science, machine learning, training models, so on and so forth, right? That just being qualified and having that knowledge, that practical knowledge that you were then able to bring to the table. The second thing would be getting noticed. So getting noticed, that is different from being qualified because you can be the most qualified person, but that does not mean that you're gonna be noticed. Why? Because in this sea of information that we find ourselves in, we are not always as easy for people to notice us and to really be able to say, oh yeah, like there's this person, their name is Daniel, and they do all of these different things, right? I was able to get noticed, say for example, for giving this speech because of LinkedIn, right? So if you're looking into getting a job in the industry, one great thing that you could do is as you are preparing yourself to getting qualified, you could be documenting this journey of you working through different problems, of you building different sort of like test products, different classifier models, so on and so forth. You could be documenting this journey on LinkedIn, and then sort of like for prosperity, you could be documenting that as well on, let's say, something like medium.com. And also maybe on your own personal website, or if you really want to go out there and sort of like become very well-rounded, you could even go ahead and create your own YouTube videos of how you are working through different things, right? Obviously, there's different sort of like time versus effort sort of like trade-offs, and so that would be something that you have to personally think about when it comes to how much time do you have available. But I would say the highest ROI on your time, return on investment on your time, would be documenting things on LinkedIn, documenting the journey that you're going through, not coming up with like all of these different fancy presentations or anything like that. Just sort of like saying, this is what I've done, this is what I've worked on. Just would like to share. If you have any questions or if you have any tips, go ahead and share them with me. Why do I say this? Because at the end of the day, when you show that you're someone that is learning, growing, so on and so forth, other people are gonna notice. And actually, this is some research that came out of Reid Hoffman. Most of the jobs that people get actually happen because of someone that was in their network telling them about the opportunity. And actually, it's basically what happened with me with my experience at Fiscal Note. Long story short, a friend of mine got me the opportunity to interview at what used to be Fact Squared and now Fiscal Note, and were acquired by Fiscal Note. And because of that, I was then able to join as this data scientist, machine learning practitioner inside of the company, right? And that is something that happened because of the network, right? So, and I think that oftentimes people in the sort of like tech fields overemphasize the process of being qualified. There's a lot of content out there on how to be qualified. how to do data science, how to do data structures and algorithms, how to do machine learning models, how to deploy them, etc., etc., etc. However, there's very little about being noticed and on networking, right? Being noticed, it really just means kind of like networking, being present in the minds of other people, right? And so if you're documenting this journey, if you're reaching out to industry professionals, for example, today and this conference as a whole, it's a great opportunity for you to be able to then connect with other industry professionals. And oftentimes when I hear of an opportunity, I then share it to my own network. And that means that now by you being connected, let's say to me, or to follow me on LinkedIn, then that means that you're gonna be able to see when I share an opportunity that someone else shared with me. And so those are different ways of you being able to get noticed. That also means, for example, being able to pass the resume screen. Another big important thing about getting noticed, for example, is reaching out to industry professionals and communicating with them. I think one of the things that works the best is if you are from the same background. So, say, for example, I would be reaching out to people from Latin America or people that speak Spanish. Why? Well, because we already kind of have that little bit of common understanding. So, even if they work for a different company, because we have that common ground of being from the same university, same background, or something like that, actually it becomes a lot easier to be able to talk with them and to be able to start that conversation. By starting that conversation and talking about it, then I'm able to ask for some advice, maybe get my resume checked, different things like that. Just talk about the industry, just get some insights from more developed professionals, and then eventually, if I wanted to, or if I needed to, I could ask them, hey, if you were to be comfortable with it, would you be open to giving me a referral? And sometimes they will, sometimes they won't. But if you have some different companies, that may be a way for you to be able to get noticed. Why? Because getting a referral and getting referrals into the company, that actually pushes you and blows the water out of other people and other applications. Why? Because not everybody is applying to a referral. And so if you are, then that just will give you an advantage over other people that are also trying to apply for these different sort of roles. And then the last component of the last of these three levers is interviewing, becoming really good at interviewing, become really good at presenting in public, for example. And that is also a skill, something that you develop. All of these things are different things that you develop over time. These are not just things that you can just come up with out of nowhere. And so interviewing means studying the basics of your field and the sort of questions that they will ask in those interviews. So, say for example, for data science, you would be talking about the bias versus variance trade-off, linear separability, different machine learning models. Why would you apply sort of like more like supervised models versus unsupervised models, like bunch of different things like that. But sometimes you might also have some maybe more like mathy questions. Sometimes you might have more like data science, data structures and algorithms. And what I would say is that one great thing to do would be to reach out to people that are already in that company and ask them, hey, I'm really curious about the company, really wanting to learn more about it. I'm curious to hear if you have any recommendations on how to study for the interview process. At bigger companies, they have more standardized processes to be able to apply into this field and into these roles. At smaller companies, they might just be like, hey, yeah, just send me your resume and I'll send it to my boss, right? So it really depends. And that's another reason why networking or getting noticed is also really important, because sometimes just by reaching out, they'll be like, oh, actually, yeah, we've been looking for a data scientist for a while. And you happen to be here and you happen to be interested and you like demonstrate that you're always learning and you're always growing. Great, perfect. Let me just reach out to my boss. And just like that, you might be able to get a job, right? So those are the three levers. Being qualified, getting noticed, and interviewing. Those three different things are things that you can be working on in parallel and you can be working with. If you want to hear a little bit more about it and sort of like get more sort of like insights, I would encourage you to look up Munoz.ai and then through that, I have a series of blog posts that I'm working on and that I have published, and they sort of like go in detail into these different aspects of all of these 3 different levers that I talked about. So let's see, how would ML/AI impacts on ethics? So, so this is a huge topic, and actually something that is very underdeveloped when it comes to the industry. So what I would say is that there's not as much work in the topic of AI ethics, and when it comes to when you're a data scientist, when you're a machine learning engineer, at the end of the day, say for example, the issues that we have heard about from, let's say, Facebook, and Facebook causing, you've seen the headlines, right? Like Facebook causing this massive problem in elections, or causing these other problems in countries where there's political instability, and then that led to some sort of conflict between the government or between different people in that country. So all of these different things are product of people making small choices throughout the development of the product as to how it's going to be developed and how it's going to work. And what this means is that it's up to the individuals and it's up to the people that are working in these companies to be critical of what is it that they're developing, and not just say, oh, I'm just a data scientist, like, the company is deciding how they do their work. Well, no, that is not something that, for example, in the Nuremberg trials, like, was something that people could just say, okay, yeah, I'm just working for this institution, and therefore I can just absolve myself of responsibility. At the end of the day, we're all professionals and we're all working in this field, and therefore we have a responsibility to have ethics when it comes to the sort of things that we're developing, and to be critical about why is it that we're developing the things that we're developing, and what will be the impact of those things that we're developing, right? So, one great book on this topic would be Weapons of Math Destruction. Weapons of Math Destruction, and that book is incredible. Amazing research from the author, and basically what it touches upon is, as a data scientist, how do you or as someone working with AI and data and so on and so forth, how do you think about these different problems of bias, discrimination, so on and so forth, as you are developing products, as you are thinking about different algorithms? Because when you are developing these different things, you're actually going to have a very large impact into the direction of the company, and therefore you have to be critical about what is it that you're developing. So what are effective ways to create a portfolio for the market? So I'll take that as mostly how is it that, or what sort of things that you can develop for the market in context of trying to get a job. So what I would say is, think about something that can be easily understood by people. So what I mean by this is, you might have many different ideas of projects that you could build. Now, if you require a lot of background knowledge to be able to understand the model that you worked with, and the insights that you're getting out of that model, then that is going to be a lot harder for, let's say, recruiters to understand and to be able to say, like, oh yeah, this is, like, very valuable. So things that are interesting, that are eye-catching. Say, for example, a friend of mine a while ago, this was actually kind of like a research project that he was doing, but this is actually totally something that you could do on your own. What you could do is go ahead and look at different political pages, let's say, like news articles, so on and so forth, right? Go ahead, take them, and let's say that you know for a fact that XYZ political page has a left-leaning or a right-leaning bias, Okay, great. Now, what you can do is like, after you compile a bunch of websites, you can scrape the different headlines from their articles, compile a data set of right versus left, and then go ahead and take a new what you could call unbiased or unclassified um, website, and start saying, okay, what percentage of their articles are left versus right, and then assuming that your data was good and you actually compiled a good data set, then that would mean that you would be able to address or sort of like identify, okay, yeah, this website is more left leaning, this website is more right leaning, and that might be interesting for sparking discussion about the media, for example, right? And biases in the media, for example, right? And then from there, you could make it into a website where you like can plug in the URL and then it extracts the headline and it tells you it's right leaning, left leaning with this amount of certainty. And you could have a blog post talking about how is it that you did it, right? So those are a bunch of different things, and it's easy for people to understand what is it that you did. You train the model to be able to classify news articles to say whether or not they're right or left leaning, for example, right? You could say um, to classify whether or not they're talking about cats or to classify X, Y, and Z different things, right? So those are fairly straightforward to understand, but also something that can be very much so sort of like visual and interactable. And if you're building a portfolio, then you want to be thinking about how you see that you're hitting the three levers. Well, it would be getting noticed because it's something that people can interact with, they can share with other people. It's also sort of like becoming qualified because you're learning all of these different things. And it's also um, this aspect of, well, of practicing for interviews, kind of like by talking about ethics, by understanding different challenges that you got, right? Um, what what I would also say is that when it comes to breaking into the industry and breaking into AI, is that kind of like as I was saying earlier, there's many different roles. So I just kind of want to very quickly break down what would be the different kind of roles that are in the industry, right? So there's a researcher slash research scientist. That would be basically you're coming up with the next 5 years. So something that's gonna like be important in the next 5 years. It's not something that's gonna be relevant important right now, but you're kind of the company's kind of staking on these insights becoming important in the next 5 years or the next 10 years, so on and so forth, right? So that's very much so something similar to like what would be a researcher in academia. There's machine learning engineering, research engineering, ML science. That would basically be sort of like understanding these models, knowing how to work with them, but also then being able to create interfaces for them into applications, into dashboards, into many different things like that, right? Making them production ready. There's a data science kind of role that basically is saying, okay, well, the data science role, taking in data, analyzing it, coming up with models and insights, so on and so forth. You, depending on the company, you might have to kind of, as I did, take this model that you've made and then also like come up with how is it that you productionize it. But at some other companies, at some other places, it might not mean that. It might just mean, okay, you're taking in this data and then you're creating insights and you're making presentations and you might not even be working with machine learning, right? So it really depends on the company. It really depends on the job description that you're looking at. And then there's like software engineer, data engineer, where you might be working in a machine learning AI team, and you might be doing more of that work of like getting everything together or creating the data pipelines for the rest of the people working there to be able to create value, right? And everybody's kind of working together to create the value, right? Is it possible to find a data science job remotely out of the USA? That I would say probably yes. I haven't yet tried to look for one like that, or have many colleagues that have done that because most of my colleagues are in the US, right? So it's kind of like a catch-22. But I would say probably yes, and I would say that because I have personally seen, first of all, because of COVID, everybody was working remotely, right? So that would mean that there was no like specific restriction of being able to go to the office, all of that sort of thing. And then the other thing would be that if you're bringing in valuable insights, people are going to be willing to pay for that, right? If you're bringing something that is fun, right? So, and that goes back to this aspect of getting noticed, right? And why it's very important to be able to talk about those things that you're doing and the work that you've been developing. And then the other thing is that I would also say I have personally seen groups of people, companies that hire talent from abroad to be able to work with them, right? So I don't see why it wouldn't be possible to get one of these jobs outside of the US. And also, if you expand your perspective, there might be opportunities in your country. So that might also be something to consider, and then that may open the door and the road for you to then get other opportunities, let's say, for example, in the US in person or in the US remotely, so on and so forth, right? It's not just like a one-step thing. It could be a little bit of a process through a couple of different steps. How can I get good data for my project when I don't want to repeat all of the well-known Kaggle projects? Well, that's great. Well, a couple of different things. Well, so first of all, you're not always going to have access to data, right? So that's just one thing, right? And what I mean by that is like sometimes you're going to have to come up with your own with your own data sets. And so that would mean that, and that is because in the industry, like you don't always have like a readily available data set that you can just go ahead and pull and then start working with it, right? And so what you can do is think about, okay, well, what is the project that I'm trying to accomplish, right? And don't worry too much about like replicating the data from Kaggle or not. What I would say is like, if the data's on Kaggle, great. I mean, I had a project that I did once when it was about sentiment analysis, or rather stance analysis on tweets. And one of the things that we did is that we looked actually at one of the competitions, like data science competitions, and they actually had a data set for stance. And so we took that data set to pre-train a transformer model, sorry, to fine-tune a transformer model on this task of stance analysis. And then we then also labeled our own proprietary data set of stance for tweets for the particular task that we were looking for. And then we came up with our classifier model. And then we were able to then use this classifier model to bring insights for the company, right? And so, as you could see, like it wasn't just taking a Kaggle data set. It was like taking the Kaggle data set, yes, but also at the same time coming up with our own data set by labeling, but it could also be by scraping, for example. And then from there, training this model to then be able to generate these insights. So I would say first think about the project that you're trying to make and think about it from the lens of like, is this something that people are going to be able to understand? And then like understand relatively easily, because then it'll make it shareable. And by making it shareable, then you are the one getting noticed, right? And again, this is all from the context of you are a professional that is trying to get noticed by companies and by colleagues, of being able to do great work because you want to get hired, right? So that is kind of the perspective that I would take if I were to start from zero and sort of like go in that journey, documenting the journey and sharing the knowledge and the things that you learn and building interest in projects that people can look at. Are there any professional benefits that justify working to obtain a PhD? So I would say do a PhD if you are interested in research. Do a PhD if you really like academia. Um, and that would be, roughly speaking, it. Reason being, at the end of the day, I feel like it's more and more becoming the case that if you're able to bring the insights, if you're able to bring in the value for the companies, and if you're interested to work in industry, then focus on that. having a PhD like means that you can go through the PhD program and you can jump the hoops of getting a PhD. And also, it also means that you can develop like very, very specialized knowledge in a specific subfield. However, the thing with that is that you might be over-indexing in one specific task. So if your personal goal is to just go ahead and work in the, broadly speaking, ML AI field, then I would say getting a PhD might be a little bit too much of a commitment, because you're basically spending 6 years or 4 to 6 years working on one specific subfield, and maybe that subfield might not be relevant anymore after you're done, right? Like, let's say someone started working with RNNs, recursive neural networks, in 2015, and it's like a 4-year program or 6-year program. Well, by the time they're done with it, actually their work is now not as relevant because of transformers and the impact that they have done into the industry. So it's to a certain degree a gamble, in particular if you're just trying to get into the industry. Now there might be migratory sort of like concerns or issues to think about there, right? Like, so a PhD does give you the opportunity to say, for example, come to the US or Europe or something like that, where you would be able to be working there and like open up opportunities. Because if you're a PhD student, then you can apply to like research opportunities in the country that you're in, for example, internships. And so it is a method, but what I would say, and sort of like the advice that I have been given by industry professionals and by other researchers, is do a PhD if you're interested in the research, if that's something that you really want to be doing, because it's going to be tough and it's not going to be easy. And if you're only doing it for getting into the industry, it might be very difficult. You might also want to consider something like a master's or research-based master's. And really the professional advantage comes in being more easily picked for researcher positions. So like a researcher scientist or something like that, where your main output is research papers, and not necessarily coming up with new models, or you might come up with new architectures, but not new applications of those architectures. Maybe you would do a little bit of that, but your output is the papers, rather than the insights and the products that you would be able to produce. What is your vision about AI in areas such as sports science, medicine, so on and so forth? Right. So medicine is huge. I was listening to Lex Friedman talk the other day. One of the things that they were talking about was this aspect of how the field of biology is being revolutionized, just like the field of computing was being revolutionized, let's say like 20, 30 years ago, right? So what I mean by this is there's a lot of opportunities in biotech, in data science, AI, all centered around biology. And if you see a graph of machine learning being mentioned or deep learning being mentioned in research papers in biology, it actually looks like an exponential curve. So that's a great opportunity. And that would also mean that if you have a background in a different field, medicine, biology, physics, etc., you might actually be like at a very interesting position if you then teach yourself also programming, data science, and deep learning, all of those different sort of things, because then you can combine those two fields together, your understanding of those two fields together, and then be able to bring in even more insights to the company. Also, I want to do a little check with Nick on in terms of the time, how we're doing, and how much longer
we have just like 1 or 2 minutes, Daniel, and also we have a Q&A session, and you're the part of the Q&A session, so we're going to have banners, so we can continue. You have another 2 minutes to wrap up, and we already have Benjamin with us, so we'll be starting with him just in a few minutes.
Sounds good. All right, so then just to wrap it up, what I would say is think about sort of like summarizing what I just kind of like mentioned throughout this talk is, first of all, have hope. Basically, you're able to develop all of this knowledge and all of this expertise just by you being here. That means that you already have the opportunity to learn all of these different sort of things, and that it's opening up a lot more of the different fields of knowledge that are available, right? Focus on developing your skills. So that means being qualified. Focus on getting noticed, connecting with different people throughout the industry, and also developing your skills and your expertise in interviewing. Those two things together will allow you to then be able to break into the industry and to be able to work in the field of AI. There's a lot of different paths to it. There is not just one, and you can craft your own narrative and you can craft your own journey to be able to get there. And so I really do strongly believe in all of you guys, because just by being here, that means that you're already interested in knowing and learning and growing, which are the most essential skills when it comes to our digital era that we're in, but also when it comes to breaking into AI. So with that, thank you so much for being here. And if you want to connect with me, feel free to reach out on LinkedIn. And also, I have my own website, munoz.ai, just like my last name, .ai. So if you want to do that, feel free.
So we posted that one already in the chat, so be sure to reach out to Daniel. And since Daniel mentioned that the connecting and networking is very important, and he actually offered graciously his own profile on LinkedIn. So let's go, everyone. Let's connect.
Definitely.
Okay. Daniel, thank you once again, and we'll see you at the Q&A session.
Sounds good. All right, everybody. Thank you so much.
Okay, and we have our next speaker, Benjamin, with us. How are you doing today, Benjamin?
Hi, Paul. I'm doing well. How are you?
Doing great, doing great. And how is it going in Oracle? Everything's good?
So far, so good.
So far, so
All is
good.
well.
Okay, so
Yeah.
yeah, and thank you for joining us. And this time we're gonna have a presentation from you about data wrangling with SQL. So basically, SQL for data analysis. And I believe we're gonna have some practical presentation. You're gonna share some practical knowledge with us. And thank you once again for joining us. And everyone, as we mentioned at the beginning of this conference, please ask your questions, because we have 10 or even 15 tickets for the pro day available. So be sure to comment, be sure to ask Benjamin questions. And yeah, we will give out those tickets right after part of the tickets after this block. And okay, I'm out. The mic is yours. Thank you.
Thank you, Paul. And thank you very much. It's a pleasure to be talking to the junior track, Data Science Global Summit 22. My name is Benjamin. I'm based in Kenya. And so without wasting much time, let me just go straight to my presentation. And I hope you find it interacting. So let me just share my presentation with you. So probably I would ask, what are the expectations of you guys as far as data wrangling is concerned, and specifically measuring with SQL. So what will be your expectation from this talk? So maybe you can put it in your private chat and we can talk about it. So I believe you can see my screen. And so let's move straight to my presentation. So as you can see, data wrangling using SQL for data analytics. Just give me a minute, please. Sorry about that. I hope you can still see my screen.
Yes, we do see your screen. Yeah, the screen was visible, but the slides were not changing.
Okay. I don't
So
know
we
why.
saw
Let me just.
we saw the initial screen with the title.
Okay. Let me just do that. Second again. I believe you can see my screen right now.
We can see our website.
Yep. A second. A second. What
Mm-hmm.
about now?
Yeah, now we see.
Good. Well, so I'll be talking about data wrangling using SQL for data analytics. And basically, the agenda will be a brief overview of what data wrangling is, where it's probably applied, and maybe now finally the practical examples, just a few small practical examples using SQL. And so to start with, maybe we can introduce the term data wrangling. What is data wrangling? You know, in summary, data simply means transforming data into a format that makes it easier to work with. It also refers to a number of activities between collecting data and analyzing data, and a much more involved labor-intensive process. So it might be a manual process because you are dealing with data whereby you would maybe want to fine-tune it to how you want it to be. And so maybe to quote somebody by the name Kurt Bolaka, an American computer scientist, he said that data that is loved tends to survive. You know, maybe to elaborate briefly, raw data doesn't provide companies with valuable insights, but data analysts can manipulate it to access deep insights that lie within the data. And as a result, how you treat your data can have a profound impact on the conclusions you make. So I would ask, how do you make your data lovable? And so our topic today, data wrangling, is one of the methods. And maybe to briefly talk about the process, or rather the data flow process. In my context, taking it as analytics, I took this conversation in the analytics environment dealing with the use case of data warehousing, for that matter. And in any use case whereby you're dealing with data, there will always be a source. Source basically means where are you getting this data from? It could be an HCRM, it could be flat files, it could be an Excel. So how do you get this data? And so this architecture, or rather process flow, is basically showing that process of getting the data from the source data, bringing it to your environment, which I would call it a data warehouse. Basically, you can see I have a staging area whereby I would say is where you prepare your data in readiness for it to be fully compliant to the DW or DWH principles. And then now after the data is ready, then it can be used for analytics. And so you can see from that section, we have the data wrangling environment indicated here, and I just have a few activities that could happen in this environment. So you can transform the data, you can clean the data, you can reformat it, you can do validations, as well as enriching the data. And it's good that we dig deeper so that we see what data wrangling entails. What are the various steps when you're doing data wrangling? So moving next to my next slide, I would like to speak about the various steps in data wrangling. I think it's just 6 steps. So the first one is data discovery. And in this first step, you get familiar with your data. And after understanding the data, then you are able to start making use of the data. So basically, this is where you start trying to get familiar with your data from the data sources. And then the second step is structuring. Structuring basically is when you collect raw data, it initially is in all shapes and has no definite structure. And such data needs to be restructured to suit the analytical models that your enterprise plans to deploy. It's basically changing how data is displayed or stored. Then on our third stage, we have data cleaning. Simply goes without saying, you're basically cleaning the data to be ready for use. And raw data comes with some errors that need to be mixed before data is passed on to the next stage. And cleaning involves the tackling of outliers. Probably you see that in our practical cases much later. Making corrections or deleting bad data completely. We also modify data that is incorrect, incomplete, irrelevant, duplicated, or improperly formatted. Probably you'd want to pivot and pivot, change some aspects of the attributes or rather the columns and how they come, or even the values within the rows. So maybe we can have small use cases on that. On to our fourth stage in Wrangling, we have data enriching. By this time, you have a kind of become familiar with the data in hand. In summary, this is combining data with additional data to contextualize or expand analysis. So maybe to expand briefly on this is where maybe data from one single table or even data from one single database would not be enough. But there are systems which have kind of a connection with this data. So you are able to connect these tables from the various databases or even within the same database. So here in SQL, you'll come across terms like joins, outer joining, inner joining, and such, left joining, right joining. And it's good that you also understand how that is used as far as data enriching is concerned. And basically, this is done to bring a 360 kind of a degree view when you are trying to do analytics. After that, we have the validation stage, which is very important, cannot be ignored. This stage basically involves confirming consistency and quality of data. The rules of validation require repetitive programming steps to check the authenticity and the quality of your data. So this is where you really check whether all that you've been doing is correct. And if it's not correct, then you'll have to repeat as a point in the stage so that you get it right. And then finally, in our wrangling stages, then we have data publishing. Once all the above steps are completed, the final output of your data wrangling efforts are pushed downstream for analytical needs. So maybe if you can remember from my process flow or the architecture, I have the analytics section at the end of it. So this is basically making use of the data warehouse, which I would say maybe is my production, and data there is already fine-tuned, already validated, ready for use for the analytics team, machine learning engineers, and the like. I hope we're moving on well. So moving next is the tools. What are the various tools used for data wrangling? I wouldn't maybe waste much time in this slide, but as far as the users or rather the consumers of data wrangling is concerned, I would say this depends on the skill that one has. So if you can do some tasks in SQL, then let it be the one. We have different kind of capabilities in terms of technical skills. And some tools might be more technical than others, which is very true. And so you can see we have CSV Kit. You can also use Python. You can use R, Tabular, Excel, OpenRefine, and then we have our SQL. I put it in bold because it's our subject topic for this session. And so not to waste time, moving to the next slide. What are the benefits of data wrangling? Data that is already wrangled saves time. So you will not be doing repetitive processes probably because you have already done away with maybe the data, the dirty data. Faster decision making, definitely goes without saying. We also have data usability. Of course, data can be used across various departments. It's not only exclusive to subject areas, probably if it's HR or maybe customer care. It can even be used across HR, customer care, or even finance. Data preparation, this is where you achieve your data preparation in Wrangling. Also improves data analytics process, makes it easier for you. Removes errors by removing outliers and the likes of maybe formatting problems and such like. You have already removed the outliers. Also improves handling big data. And also data analysts can focus on analysis. You will not always think of, man, I have dirty data, and maybe spend hours trying to clean this data, but rather you're focusing on the right tasks using data that is already fine-tuned. And then lastly, we have accurate, actionable data. Remember the saying, garbage in, garbage out. So if you have dirty data coming in, then and you have not done curation or data cleanup, reformatting, and all that, trying to ignore the data cleaning process or wrangling process, despite the kind of tools you are using, then the garbage that comes in, it is the same garbage that will be consumed by the users, could be analytics and ML engineers, data engineers, and the likes. So it's very important. And we've been talking about data wrangling and SQL. So probably I believe I'm dealing with people who understand what SQL is. A minute. So basically, we have known what wrangling entails, and so moving to SQL. So basically, it stands for Structured Query Language, or others called SQL. Depends with how you call it. And it's basically a standardized programming language that is used to manage relational database and performs various operations on the data in them. So maybe to check on SQL compliant databases out here, I might not have listed all of them, but majorly I'll have captured most of them. So we have the Microsoft SQL Server. We also have Oracle database. We have IBM DB2. We have SAP HANA. We also have the SAP Adaptive Server, Oracle MySQL. For those that don't know, MySQL also belongs to Oracle. And we have open source PostgreSQL. So I hope that is quite clear. And moving next, what can SQL do? So SQL has a lot of capabilities. We just cut across and see what it can do. So the first one is SQL can execute queries against the database. Maybe we'll see that as we move on. SQL can retrieve data from a database when you're trying to query from a specific table, could be a table or a view. SQL can insert records in a database. SQL can update records also in a DB. We shall see that in our practical examples. SQL can also delete records depending on the use case whereby you want to do away with data permanently. SQL can also create new databases, depending on the kind of tools that you're using. Probably you can create a database using an SQL query, or maybe using the guided user interface based on the kind of tools you're using. You can also create new tables in a DB. You can create stored procedures in a database. SQL can create views in a database also. And also SQL can set permissions of tables, procedures, and also views. So broadly, that's basically what SQL can do. And so maybe to not waste much time in speaking about theory, I decided to do my practical still on the slide because of the factor of time. But probably if we shall have time as we continue, once I'm done with this, then we can switch and I move straight to the practical, still doing from my PC. So I have an example here. It's my first initial example. Basically, this is a data set. This is our data set is a single table about flash drives. And that is our subject of interest exercise for now. So you can see we have a flash drive here. It has various attributes. We have the case depth. We also have the case width. We also need to know what is the price of this specific flash drive. What is the color? Probably it could be the color of the casing or the color of the specific flash drive. And also probably the date, when was it bought? So maybe I could say this is a customer data. Some customers have been buying these specific electronic products. And then, so there is a table. You can see we have a table here, which basically collects this data by having our primary key ID. We have the color. We also have the case width, depth, price, as well as date. So maybe to start with, like I said, how is SQL used? So this is a good example of how you can use SQL. It's good that I clarify that I'm using Microsoft SQL Server for this specific use case all the way moving forward, so that maybe you don't get confused maybe on the syntax, because syntax could be different based on different vendors. Could be Microsoft, Oracle, even BigQuery, so Postgre and all that. But SQL syntax, it's always the same. The theory is the same. You will find we only have various small changes, maybe in functions and a few little bit things there. So we're going to create our table. We're going to create our database. We are calling this database a gadgets DB, whereby we will be storing all information about the gadgets being sold for this specific use case. And this is the specific syntax. Maybe if anyone would need the compiled version of the script, I can provide that later maybe. So after we create our database, we're calling it gadgets DB. Then we're going to create our table. I'm calling my table flash drive, and this table has specific columns. That is the primary key, flash drive ID. We have color, we have case width, depth, we also have price, as well as purchase date. So if you're using Microsoft SQL and run this query, then you'll be able to create flash drive table. And then we shall be inserting just a small bit of data to this table. I will not be using big data set for this specific use case. I'll just be using a small set of data. And actually, this is the data you're seeing here, nothing more from this. So for those that maybe are not quite familiar with SQL, this is the syntax for inserting values or other data into the table. You can see we have insert into our flash drive table, and then you specify the various columns as they are, and then values, and then you put the values as you can see. Yeah. So once we create our flash drive table, then here's our table. So like I had explained before, our table, or rather data set, small data set for that matter, is ready for wrangling. And you can see we have the flash drive ID, which basically I would call it's the primary key for this specific table. We have color, black, white, purple. We have case width, case depth, price of this specific flash drive, as well as the purchase date. So maybe I would ask, what actually are you seeing? What is your initial observation of this specific table? Maybe you can put your observations in the chat. I'll be able to see that once maybe I stop sharing the presentation. So if we look at the data set, we can see something is missing from the table, and that is not complete. So I believe you can see we have some nulls, -1, -2, other more nulls, yeah, randomly. And the table is partially populated with some missing data, which makes it an excellent case for data wrangling, because we must clean the data to analyze it properly, as the missing values are more or less time consuming in the data analysis process to make better decisions. So remember I said one of the benefits, or rather the advantages of doing data wrangling, is not to spend time. It reduces the time for for analysis process. So if you work with maybe a data set which is dirty, probably, let me call this dirty as is, then you will find yourself not contented with the output. And so always you'll have to start with the data cleanup so that you are contented with the cleanliness of the data. Remember the quote, so that now you can be able to use this data for analytics. We have quite a good number of null values, like I said, in the various columns, but also can observe further we have two numeric values. You believe in the color column, you can see we have two numeric values. So how about replacing these values with null so that we have a uniform data set? Well, so I'm thinking just out loud. How about maybe making this uniform? So what drove me to such a conclusion? I'm dealing with a column here. You need to take some time also to understand what kind of data you're working with. Remember, in the stages or the steps, you need to get familiar with the data. And once you know what the data entails, then now you can be able to come to decisions or other conclusions when dealing with it. Now, maybe to clarify, when you're dealing with data or maybe doing data wrangling, you might be the expert of this data, so you already know it. Or you might be maybe the technical guy dealing with data. Let me call this guy a data engineer. But they know less about the business, so they cannot really make decisions on their own. But they would they are supposed to consult from the various business stakeholders so that they help them understand the data, or rather the data owners, and even come into conclusion as a team on what should be done on a certain use case. So for instance, if I'm a I'm a data engineer for this case, I have observed this kind of a scenario whereby I can see we have -2 and -1 in color column. Surely this doesn't make sense, but maybe it would have made sense from someone else. So it's good you also consult. And if I consult and find out that the data set I'm trying to use is not right, then conclusions like replacing it with a different value, they might know the values, or maybe trying to replace these values with null so that we have a uniform way of areas where we don't have exact values from the system, and that's how I came up to the conclusion. Probably this doesn't make sense, and maybe after doing my consultation, it also still doesn't make sense, and so it would make sense if first of all I do away with these two values. So how are we going to do that? In SQL, writing your syntax. So we're going to write a simple SQL syntax, basically to filter out these two specific use cases whereby we have color is -1 and -2 values in specific row values. So maybe to explain a little bit on this SQL content syntax. So it will be select all. By selecting all, and basically I want all the output present in a table. And then I have a comma is numeric color. And you can see we have a no column name here with 1 value. And this is it's generated by this is numeric. It's a function basically to check whether the color column is a numeric column. I mean, the value in that column is numeric or not. So if it finds a numeric value, it should return 1. And this is because you can see we have -1, which is numeric. So the function, that's right. If it's not numeric, assuming maybe we had a null value here, then it would have returned 0. So it's basically a checker function in SQL whereby I only want to filter out specific use cases. And my case here is numeric. So from the specific table, which is flash drive, where I'm still using the same function, is numeric color column is equals to 1, So I've already filtered it out to give me the specific 2 sets of my color, but I want to be more specific and accurate in my results. So I'm going again to add another where clause and cast color. Cast basically is used when you want to change the data types in SQL. The syntax might be different, maybe probably in Postgres or even in Oracle, but the context is the same. So I'm changing color to an int so that now I can equate it to an integer or rather number. So I'm casting color as an integer and then putting is less than 1 because you can see our color values are -1 and -2. So it will not bring anything more than that. It will be less than 1. And so if you run this specific syntax, these are the results. So we're trying to do this specific query basically to start working with the exclusive data set only that we want to make use of. Remember, we add other columns which we have no focus with. So for a start, we're going to start with the 5th and the 6th rows for our first use case. Maybe I could call this data wrangling by grouping data into non-values and non-values. So now we need to move the above odd values, invalid values for that matter, to nulls to improve the data set for analysis. So on my next slide here, we're going to write an SQL syntax basically to update. Remember, I said in the uses of SQL, how you can be able to use SQL. You can also update data in a table or in a database using SQL syntax. And so this is a simple SQL syntax for updating. So basically, it means that update our table, which is flash drive, and then we are set color column to the new value which we want it to be. And then we are using the same where clause that we used to filter out the only relevant output for us to focus on, which is where is numeric color is 1 and and color is an integer less than 1. When you do updating on the go this way, it means that you will have updated the live data existing in the table. And I would call this a permanent change. So this is a very important decision to make, whether you want that change to be permanent. And maybe going back to the architecture, you remember I had to pull the data from the source systems to an exclusive environment, which will make me play around with the data as far as I want. So that if at all maybe I'm making some changes like updating in this case, I'm not affecting the transactional based database, which is already running. You might affect the operational reports and all that in the live system. So it's important to always pull the data and maybe make use of it in an exclusive environment whereby even if you make mistakes, you can always go back and pick the right one. So it's quite important. So remember I said when you run this specific SQL syntax, it's a permanent change. So you need really to be careful when you're trying to do this updating. Like I said, if you don't know exactly if it's right to do this, consult with the right subject people. If you all agree, then you can go ahead and change it permanently. Otherwise, if maybe you're more careful, like me, I would say, you would decide maybe to write a query that probably will omit the various cases of, you see, we're dealing with -1, -2 values. This is what we want to replace with null. So if we use this specific query down here, you can see I called it an alternate query. And basically, I'm using a case when statement. So I'm saying case when color column is numeric is equals to 1, then replace it with null. Else, if the numeric is equals to anything else, which is 0, it should return still the same value in that. And so if you run this specific query, it will also replace our -1 and -2 values to nulls. Like I said, this is permanent. This one, you are doing it on top of the table. Maybe how you can be able to make use of this one, you can go ahead and create a view. A view, basically, it's a representation of a specific query that you have written. And for that matter, I will create a view, maybe call it flash drive underscore clean. That's the view I'm calling it. And so you will always be querying this view like a table. So the same way I'm querying this, I select all from the flash drive. Then if I use the alternative query and created a view, then I will select all from my flash drive underscore clean view. And the results will be the same. So like I said, there is a permanent solution, but there is the one which is more better so that you don't lose some aspects of the data. Now, you can see now we have already cleaned the data set. This is the screenshot for our result if we select all from this table, and you can see we have already replaced the numeric values with null. So what can we do next? So dataset has been cleaned by using one of the techniques of data wrangling, in which we have removed the negative numeric color values and initialized them with the nulls. So I hope that's clear. And so we're still on the same data set, eliminating problematic nulls. So you remember once we created this table and inserted some values in it, I asked what were the observation in it. And so now I'm trying to dig deeper to find out what are the observations by writing queries, so that now maybe they could lead us to making decisions as far as wrangling is concerned. So for that matter, we saw that the table has various nulls. And you can see in the first syntax, I'm selecting from the table where color is null. And you can see the color column has 3 rows with nulls. I have decided to do this check for all the tables. So let's also add the case width and the case depth. And so you can see if I select all from the flash drive where case width is null, then I'm getting a return of 2 rows. And also if I do the same in case depth, I'm getting an output of 1 row, but in this case, it almost has all the column values as null. So I hope you can note the 5th row has no assigned value for all the columns except the primary key. And this is the easy looking target for us to eliminate for a better analysis. So for a start, even without having to look on the other values of the other columns, that is color and case width, we can see the last one for case depth does not fit for analytics because it has nothing. So I would say here's another technique of data wrangling where we will remove the rows with nulls, provided those nulls are a very small portion of the main table. Else this will be avoided. So probably if we would have decided to maybe eliminate all this data, you can see we have the first one with 3 rows returning, the second one with 2 rows returning, and the last one with 1. So basically, I would say this is 4. Let me call it 3. Yeah, this is 3 rows. Remember, our initial table only had 6 rows. So if you delete all these 6 rows, then you will have lost 50% of the data. So you'll have to look for ways to eliminate only which that is relevant, because this has all the nulls, then we went with that option. And so maybe how do we go ahead and do this specific change? Like the previous example whereby we were updating a value existing in this table, in this case, then you can go ahead and delete. Remember how I emphasized it? Updating or rather deleting, these are permanent use cases which you can use in SQL. So you need to be very careful when you are doing an update or even a delete. So for this case, this is the syntax. We are deleting from our flash drive table where color is null, where the case depth is null, case width is also null, and the price is null. So we would like to delete this specific column, which in our case is column 5. So if you run this specific syntax, you will have eliminated all the values in that specific column. But again, if you really don't want to do away with it permanently, there is always an alternative of having a query. And in my case, I just wrote a simple query, which is select all from this flash drive table. And then I'm using the where clause, where the flash drive ID is 5. So you can see for this specific one is 5. So if I don't want it to be portrayed in the output, then I can quickly eliminate it using a query like that. I would say maybe probably this is the most preferred way of doing it, not to delete the data. But again, if the data really doesn't make sense, then go ahead and do away with it, so that you also save time for other people not always to be doing the same thing. But also remember, for this specific query, you can create a view for it, and you'll always be querying it as a view or rather a table, just the same way we're doing it for a flash drive. Excuse me. So basically, those are the various use cases. Maybe I would want to change a shift, maybe from now dealing with data, updating it, to maybe formatting and reformatting of data. How the analytics team would want to make use of the data for that matter. So my second example is unpivoting. So I know maybe most of you are very familiar with unpivoting data. You might want to unpivot data sometimes, also called flattening the data, to put it in a matrix format so that all similar values are in one column. So initially, this is how data is seated in your source. It could be a database table somewhere for a transactional database, or even it could be an Excel, a CSV, whatever that is in this kind of a format. So when you unpivot this data, this is how unpivoting. Now this will be the last result after you unpivot it. So when you unpivot, you unpack the attributes. You can see in our initial table, we basically add an item column. Here we have values, flash drive, earphone, mobile phone. And then adjacent to it, the same columns, then we have years extending this way. But for analytics purposes, or even for data preparation purposes, maybe if you want to do things like line graphs or even pie charts, these years will be better if we put them in a column, one column, so that they will be values you can see. And the revenue, these dashes represent the revenue, different values for those years across the various items. You can also put them in one specific column. So when you unpivot, you unpack the attributes, values, pairs that represent an intersection point of the new columns and reorient them into flattened columns. So basically that's unpivoting. Probably most of you are very familiar with doing this pivot, the pivot term mostly used in SQL. You can also do it using, mostly used in Excel. You can also do it in SQL. So again, moving faster, I'm just simply creating my new table. So I'm calling this table electronic revenue, basically with the same format. So no need to explain what the columns are. This is the table I'm trying to make. And then I'm inserting various measures, or rather revenue values, as indicated in our use case, to this table. So if you run this specific syntax, then you will have all these values. You'll have the table ready as is, and this is what we are going to use. So maybe to go a little bit quicker, SQL is all about writing syntax and you get the results. So this is the specific syntax for unpivoting your data set. So if maybe you know how to read SQL, or maybe you are in your first stages of familiarizing yourself with SQL, then also these are things you can do in SQL and don't have to rely other external tools like Excel and the likes, you know. So if you flatten this table this way, you can as well put this query in a view, so that always when you query it, then it will be in this format. Yeah, so basically that's it. And also it will be unfair if I talk about pivoting, and I'm not talking, talking about unpivoting, and also not talking about the vice versa of it, which is pivoting. So again, what is pivoting? A common scenario where pivot can be useful is when you want to generate cross-tabulation reports to give a summary of data. So initially, my table is in this format. Now remember, this is the format that I already had when I unpivoted the data. So now this data is already in unpivoted format, but I would like it to be pivoted. So for example, suppose you want to query a table in our sample database to determine the revenue generated by electronic items over the years, you know? So this is the result we want. And mostly, this is basically, the tabulation reports are mostly used in finance. They really want to see some various key attributes or measures in a tabular form, which is more in a summary way. So this is a good use case whereby for financial reports, you can have it this way, still using SQL. Remember, you can still do this using Excel. You can also do this using Power BI. But again, you can also do this in SQL. So like I started, I said, your technical skills, what are you best in, also determines what kind of tool set you will use. But also, if maybe the data is so big and some tool sets might be taking time, maybe loading, for instance, SQL, then it will be better to do it in the database environments, so that always when you are using this data for analytics, it's already ready in its best format that it could be, to waste time and also resources.
Benjamin, we have like 2 minutes to wrap up, if you don't mind, and yeah, then we can continue with the questions, or maybe if you want to show something specific additionally during the Q&A session, because we already have our next speaker with us.
Okay, thank you very much for that info. So actually, I'm finishing up. So to continue, this is my, this is the syntax for doing pivoting. So I will share all these resources. If maybe you request from me, I can also put it on the Git so that you can quickly have it. So basically, we have already done the changes for that. And so maybe in my last scenario, I would want to talk about date formats on a broader level. You know, different vendors have different functions of doing this. And so maybe if you want a specific date represented in a certain way when you're doing analytics, then you have a certain way of querying it, querying the specific date column to get that specific format, function to return how you want it done. So you can also do this using SQL. This is the specific syntax that actually generated this kind of a cheat sheet, which will guide you. So for instance, if I want my date column in this column, then I will use convert varchar get date from get date could be any date column, and then I use this specific 23 and it will give me this kind of result. So Microsoft SQL can also guide you in that. So this is the specific syntax that guides you to know which kind of functions to use and their format. So basically that's it from my end, Mr. Paul. Thank you very much.
Thank you very much. Thank you very much for your presentation. And yeah, everyone, if you have any questions or if we stop Benjamin at very interesting point, please ask those questions and we will be sure to answer them during our Q&A session. Benjamin, we'll see you in half an hour, 40 minutes roughly. And we have our next speaker, Kshitij, I believe. Am I pronouncing your name correct?
That's right.
Wow, awesome! Thank you for joining and pardon for. So I was trying the best I can. So yeah, how are you doing today? And thank you for joining us.
I'm absolutely great right now. It's evening over here, so glad to be joining. I hope we could have done this in person, but remote is as it is.
Absolutely. One day we will gather an awesome on-site live event, and we will be more than glad to host you or to visit you back at your place. So we'll be talking about the automatic document processing when we have AI at our disposal. So we are excited to have you with us, and thank you for joining and thank you for allowing us to finish the previous presentation. And we will be sure to give you the full time that you plan for this presentation. Thank you.
Sure. Thanks. Let me start by sharing my screen. Is this visible? I see it is. Okay, perfect. So, hi everybody. Thanks for having me. And today I'll be talking about document understanding in the age of AI. Before we start, a little bit about myself. So, I am been working in computer vision field for the past 8 years, and I worked across applications in document understanding more recently. Prior to this, was working in autonomous driving, object detection, segmentation, and the like. And before that, I was in-game advertising, where you have images or advertisements playing in the game. And before that, I was doing some cool stuff with thermal imaging for the military and defense systems. So apart from this, I like interacting with people. So do put your questions up. We have a Q&A section, I think, after this. I'd love to interact and hear your thoughts and questions. So before we get started, I'll just give a quick overview. So what is the need for document understanding? We'll go over that first. And how it is done right now or prior to deep learning. And then we'll get into the separate sections or the tasks at hand, which could be like text extraction, document classification, information extraction, and then we'll see what else can we do using all these tools that we learned today. So why do we need document understanding as an AI system, right? Documents are a part of our everyday way of interacting with the real world. And typically every transaction that we do with this world results in some form of a receipt or a document. It could be as simple as placing your order at a restaurant and then getting a bill. So at the end of your meal, you do get a printed bill of what you had there, right? Typically in business processes, there'll be much more documents floating around between different departments. When you go and interact with any business, if you want to, in fact, start a business or a startup, you have to fill in so many documents, submit it to the government, legal, so on and so forth. So documents could be of many types. Essentially, they could be forms, they could be plain text, they could be handwritten text, and certificates, legal documents, what have you. And when we look at these documents, they could exist as physical documents or be digitized in some form of an image, a PDF, etc. When we look deeper, you could have different types of content within a document. At the high level, it seems that a document is a singular entity, but it essentially could contain different layouts. It could have tables, images, or stylized text, which we'll see in some of the examples uh, in the next slide. So what kind of information can we see in a document? When we look at a poster of this sort, can can we ask the computer to tell us what are the titles of the books? And when we ask this question, it inherently means that the system or the code knows what does title, the word title represent, and what does this word book represent. So in a very simple question, there's a lot of complexity at the background. The system needs to identify that this image corresponds to some sort of a book, know that there are 6 books within this image, and then also understand that the text written on this image is essentially the title, and do all of that to give you such a simple answer. For humans, it's very easy to ask this question, but when we try to codify this in AI or as ML, we need to understand the nuances that go behind this. Only then we can tackle this problem. Let's take another example. Suppose we have an invoice. You have ordered something from e-commerce, gone to your nearest store and purchased something. Let's just take this example. And there's so many things happening here. There's some section that says who's this invoice to, a section that gives some information about the invoice number, date. Then you have this table that represents what did you purchase, how many quantities, what was the total. At the bottom, we have some sort of payment information that is probably of the seller. And we have a total along with some other terms and conditions and other text. Now, a simple question can be, who is this invoice to? Right? And again, going back, the system needs to understand this is an invoice. So it needs some sort of understanding of this document. Within the document, it needs to identify that this field here, Santosh Nayak, is the one this question is answering. If we look at what is the date when this invoice was created, again, from all this text, basically you're extracting invoice into an image and an image into text. And from that text, we need to understand which part is the date, which part is the total. I hope some of these examples are being clear. This is one popular restaurant I'm sure many of us have visited, have seen across the world. I'm sure you all can guess which restaurant this is. It's McDonald's. But given this image to a system or a computer, can it essentially recognize from all that's happening here? There's so many images, text, so many things going on here. And look at this logo and tell me that it's probably McDonald's menu. When we ask a question that what is the price of a burger, it needs to identify that this location is actually a burger and the price is written next to it. Just one last example and then we'll move to our next section. Sometimes, I don't know how many of you are interacting with your credit cards and doing online transactions, but sometimes you do get these alerts from your bank that there is some sort of irregular card activity, you need to approve something. And just imagine that you were busy on the street or sitting in an important meeting and you receive this email. It's so hard even for a human to understand what is really happening here. And all I can make out is that there's some sort of like an alert or a fraud that is happening. Wouldn't it be better if we were able to somehow extract just the key information from this email and in 1 or 2 lines understand what needs to be done and why it needs to be done? Suppose just one line that could have said fraud alert and the transaction amount, and then the step that needed to be followed, whether approve, disapprove, or hotlist this transaction or report it to the bank. Would have been so much easier. So, in summary, if we can extract information from documents, we can search across documents, we can automate processes. So, currently, documents may exist as isolated points of information. All that information that exists would be in the physical form, and when someone asks for it, you have to go physically, extract that, and then relay or extract the related information. It becomes so hard to search. Even if it is digitized and put in some database, you still need to take decisions to automate some processes downstream, and we'll look at some of them. Let's look at what a journey of document digitization is. So first, a document could be in a physical form, and it is first digitized as an image through scanning or through taking a photograph through a mobile. Then an operator views this document and enters the related field from these documents manually. You could have another agent or operator actually verifying whether this information was correct and then approving this information for the next stage to be stored into a database for later use. Now, once it's in a database, it can be retrieved by any sort of processes through APIs for any sort of business decisions that you might want to take. What do you think are the issues with this system? Since it's a manual system, a human is involved in multiple parts of this process. It's time consuming, it's error prone, and if business decisions rely on it, it could lead to mishaps. Just imagine if you need to do a payout to a vendor, and instead of $100, you end up making a $1,000 payment to that vendor. It's a good day for the vendor, but probably not for your business. And then, as we saw in some of the examples prior, there's so much variations in how the information is displayed, in how it is captured, in the forms of information that could exist. So let's see some of the applications that could be here, right? And if we can automate the information extraction, then we can automate lots of business processes. We can do lots of things absolutely well. The bottleneck right now seems to be extracting these information from these documents and digitizing them. And this could be heavily applicable in banking, insurance, and credit card businesses, where you have a lot of customer verification happening through physical documents or even scanned images of identity documents, their addresses, their identity proofs. For loan document processing, email classification that could be based on customer support, customer queries. And once you are able to classify such emails, once you are able to identify the content of such emails, it could go to the right person for fetching the answer. Another use case could be in e-commerce and logistics, possibly for delivery verification. Once an Amazon order has been shipped to your doorstep, probably the delivery person does some sort of scanning of this package to identify that it has been delivered to the right location. Can we do it just from an image? Similarly, when large-scale shipments move through multiple warehouses, there's lots of tracking and processing of documents going on. Each package needs to be tracked and correlated with what they were charged for. And that is typically in two places. One is in the physical package, and the second is the corresponding invoice that you would have. And once this information can be digitized, you could also do payment processing automatically. So lots of applications. So we saw why document processing is a problem, and what benefits we could see from this. Now let's break this down and see how we can do this. So at the bottom, we have forms of data in different document formats. It could be web pages, it could be some high-level document formats like Word, PPT, Excel, PDFs, or scanned images. Let's consider this as our inputs. And into our system, when you have this digital form of data, you can have some sort of text extraction through optical character recognition, or OCR. We'll look at OCR in a bit, but before that, what's happening at this stage, it's essential to understand. So from this stage, what we are doing is converting all these sorts of documents in various formats into some text representation. And from this representation, we're also trying to understand some visual characteristics in the next level, where we do unified document representation. So the idea is to extract text as well as visual cues from this document. That could be the positions of words, that could be the layout of this document, that could be the format of this document, so on and so forth, which will essentially help us in the task that we are interested in. And those tasks could be just identifying the layout of this document. Sometimes that may be more than enough to understand if this document is relevant to the system or to this process or not. The other could be extracting information from this document, or document visual question answering, how we saw in the examples in the starting. Given a document, can we just ask a question to the system and get the relevant answer for it? A simpler task could be document image classification, where we want to show the image of the document to the system and have it classify or convert it into which type of document it is. Let's see some details of these tasks. So on the left side, we have some simpler tasks like image classification. We see that this image is of some sort of a form, and can we classify it as the correct type of image? It could be a form, invoice, email, advertisement, lots of variations. It depends on our requirements, but this essentially can be a deep learning task. Another task that could be given a document, can we identify where different sections of the document are? And if we are able to do that, maybe we can also enhance the type of information we are looking at. So in this document, we are able to identify figures, figure caption, headings, paragraphs, and so on. And this actually, if we break it down, is related to layout segmentation. So image segmentation is a known and well-studied problem, and now it's being applied to document understanding to identify different areas of the document. And that is called as layout segmentation. Segmentation is nothing but a pixel-wise classification problem. So considering this as an image, and all images consist of pixels. So at each pixel level, we're trying to identify which class this pixel belongs to from all the given classes. So you could have 4, 10, whatever classes. Classes basically represent categories. So you could also do table detection or image detection using the same or similar kind of approach. So layout segmentation, or it could be detection. So detection is more coarse than segmentation, and it could just try to identify the bounding box, the 4 corners of where this object of interest lies. It could be table, it could be an image, so on and so forth. Let's say we are given a form similar to how we had in the starting where we saw an invoice. Can we extract only some key information from this? So an example is given here, and we are able to extract, or we want to extract, the company, date, and product with which this invoice is related to. You can see from this example that there is a lot of other text, but it would be just helpful for us for some task to identify only these key fields. So this task is known as form extraction. Moving to the right, receipt extraction. So a lot of people might have faced this uh, for their own personal use, where they want to do tracking of your expenses, or if you're employed and you go on a business trip, you probably have to file expenses. So you have to upload images or you have to submit these physical receipts. And wouldn't it be awesome if we were able to extract just the information from this image and then submit it automatically? So for that, we would need to extract the company information from this receipt. You would need to identify where the date is present here. The date is present here. And what was the total? So the total is present over here. A breakup is present at the bottom. Sometimes the information is present at multiple parts, and the algorithm or the model needs to be smart enough to identify the right type of information. On the rightmost side is form understanding. So given a form, these colors corresponds to multiple fields in the form. The blue is the question that could be in the form, and the green is the answer that is filled by someone filling up the form. On the top is an orange, that is the header, and the pink essentially represents non-related fields or others. So form understanding is more generic in concept, where we are not sure about what are the key fields that we want to extract from from a document, but we do know that it's probably a form and we need to extract such information from this. So within form understanding, there are lots of things that go on. That could be entity detection, basically identifying the type of questions that are there, and entity linking. So which field relates to which field? For example, in the previous receipt, what does company stand for in this field? It's probably this Uroko Japanese cuisine. Or it could be general visual question answering. So once we understand what the information is within this document, we could help answer using some other system based on visual question answering. So at a high level, we can see that these tasks, the one on the right, are related to information extraction, and the ones on the left are more on document understanding and image understanding. But we do need both of these to work at a superior level to extract the information that we are seeking. And how do we do that? So here I have a timeline of a very popular OCR application. That's an open source application called Tesseract. And interestingly, Tesseract was started all the way back in 1984 as a PhD project by Ray Smith. So just imagine a single person working on it for his PhD project, and he got into this company called HP, and HP decided to pull it into a product. So it went through multiple phases of being put into a product and being cancelled and things like that. But things changed in 2006. In 2005, actually, it became open source, and Google acquired the maintainer rights for it in 2006. And then significantly, they improved upon it, expanded it to so many languages, 6 European languages soon after that, 60 languages after that, and now 100. And in 2016, we have one of the latest versions, 4.00. I think we are on beyond that right now, which integrated deep learning techniques like LSTM for detection. So just imagine this piece of open source code is probably 30 years in the making. So why is this important? Basically, from your raw documents or digital format of documents, it's important to extract this textual information. And when I say that, what essentially is happening is something like this. So you have an invoice on the left. Basically, you run this through an OCR system, and it helps us give two information for every associated word. It gives us the bounding box location of a word, where the corners of the word are, where is it present in the document, and it gives the text associated with it in a string format. So for example, this top invoice, the system will detect that it's the word associated, the text associated with this word is invoice, and it will give us the bounding box location of this word. So that's the process of OCR. Now we know that so many things are supported. There's so many features in Tesseract 4.0. I've just put it here so that you guys are aware of this, and if you want to use it in your own projects, you can. But let's take a brief look at what happens under the hood, right? And this is from a very simplified view of how things work. It's become much more complex and complicated now, but this is a basic understanding that would help you to understand what happens in an OCR system. If things don't work as per your requirements, you know where to look at it. So given an input image, let's consider this image. The first step that would be present is adaptive thresholding. So adaptive thresholding is nothing but a binarization of the image. So first, this color image is converted into a grayscale format, and then some sort of normalization has to happen on that, so that if there are some parts that are overexposed, there are some underexposed part, the system cannot make out what is the text. So it helps. It's more like a pre-processing step. So it results in a binary image. After that, a connected component analysis takes place. So basically, if we go back to our pixel analogy in the first place, all these pixels are connected with each other and they're all black. So it would identify all connected components, and basically through this, you would get character outlines. You would also get other information along with this. Let's say this blue color box with the arrow, yellow color arrow would also be included at this stage. So what we need to do after this, since there's lots of other information, this logo could also be extracted at this point. There's a process of finding lines and words. So basically, inherently, what happens is these connected components are chopped into the closest possible character that is possible, and they're mapped with a dictionary that the system has. Now this dictionary helps us to recognize words in the first part, and there's a word classifier that is trained on the fly from the starting of the document till words are extracted at the end of the document. So it starts from the top left and goes all the way to the bottom right in normal English reading sequences. There are some languages that have opposite order, that start from top right and go to the bottom left. Very few languages. But as you see, there are 100 languages supported. So it has both orders depending on the language. Now, in the first part, what we did is we identified some words, we improved our word vocabulary and word detection, and came all the way to the bottom of the document. But as we did it, our model actually improved, but some words may have been missed in the first part of the document. So that's why we have a second pass that does this extraction. So our improved model is applied to already extracted pieces as well to give us the final extracted output that we see here. Now, as I said, this is a simplistic view of how things are. Now, in the current way, this word recognized word, first pass and second pass are essentially replaced by deep learning models like BiLSTM that helps us understand words from characters. And this word vocabulary that I talked about is inherently built into it through large scale training systems. So that's where better, deeper language models come in. So moving on, just one thing I would like to highlight here, it's available as an open source module, and you can all use and interact with it through this Tesseract OCR API. I think it has C, C++, Java, and Python bindings all available. So feel free to use that in your projects. So optical character recognition has evolved all this while. Just Tesseract we saw has been 30 years in the making. There are other approaches that people have applied, and I'll just give you a very brief overview on what those are. So there are detection-based approaches that detect the various objects present in the document, where the text is present in the document. And once this text has been identified, it goes into a recognition or transcription model. So as we see, the transcription model is unified at this stage for simplification, but we see there are so many ways to identify text. You could also have text instance segmentation model that goes down to the pixel level and not just creates a bounding box, but creates at the pixel level where this character is and how many characters make up this word. So some of those approaches are borrowed from classical segmentation approaches that are based on FCN, fully connected or fully convolutional networks. And then there is character segmentation model that does a mix of both text segmentation and segmentation to give you at the character level what's happening. So once you identify where this text is, it could go into a transcription model that has a language model, basically by LSTM CRFs or just by LSTMs that help you decode this visual information into text strings. So that's how modern OCRs are functioning these days. So we talked about the first stage of processing. So from the first digital document, we have now extracted our OCR, and now we want to do some sort of document tasks with it. It could be document image classification. And how would we go about it in the first approach, right? So I have taken an example of this RVL CPID dataset that has 400,000 images of 16 categories of documents. And these categories essentially consist of letters, emails, forms, handwritten documents, invoices, etc. Lots of them. So our task now becomes, given an image, can we categorize this image of a document into any of the 16 categories? So this would sound somewhat familiar, like an image classification task. And some of you may have heard of ImageNet. And ImageNet essentially is this large-scale image classification task that has lots of downstream applications. So typically, architectures like AlexNet, VGG, ResNet, etc. are applied for image classification in ImageNet. So why can't we use those? So someone came up with this idea that, hey, let's just use the same architecture, the same approach. And since a document is also in a digitized form, it's at the end an image, why won't this work? And so they took this document, applied a ResNet, put some softmax for classification at the end, and got the document class as input. And they were able to achieve 90% accuracy on this data set, which is surprising, right? You have, just by treating it as an image, you're able to achieve 90% accuracy. So that's great. What else can we do? Can we go beyond 90%? And there's so many things happening here. It's essentially, there is text as well, we are not leveraging that text right now when we look at it just as an image problem. Also, it could happen that these documents are essentially having white background with some black text written on it, right? At least this data set does. So that could also lead to some confusion and issues in classification, which is why the performance may be staggered at 90%. So people came up with different approaches. They said, okay, we can break this document down into 4 parts from the middle, chop it into 4, and then feed it into the system. That did lead to some improvement, 2-3 percentage points improvement in this method. But again, the question is, it's not just an image. There is text content, there's text information within this. Why don't we leverage that? So the modern deep learning architectures are now an amalgamation of vision and language models. So people have now come up with this unified framework of leveraging the vision information, the information from computer vision, from the visual features, and language features when we are able to extract this OCR and textual information. And based on the text, then you have these large scale language models like BERT. So can we have a joint architecture, a joint training, or a joint mechanism that leverages both these things? So one of these, or the first model that came up with such an architecture was Layout LM. And Layout LM essentially introduced pre-training of text and layout for large-scale document understanding. So they took some 6 million images of various documents, some of them from the previous data set that we saw, RVL, CVIP, and trained it for a joint task. We'll see in detail how Layout LM actually functions. But at this stage, just consider it as a joint task of classifying this document based on language and vision features. So some of this design or some of this architecture is essentially inspired from BERT. So BERT is nothing but a sequence to sequence model that takes in sequences of features, as we see at the bottom here, and then predicts whatever based on whichever task that you wanted to work on. It could be sentiment classification, document classification, so on. So here what's happening, lots of things are happening. Let's take a look. So you have a document image at the bottom right. And the first step that is done is OCR extraction. And that's why we saw OCR and how OCR works. Once you have the OCR text, so you have some sort of text and their related positions. So previous language models always worked only on the text location. Sorry, the text string, not the location. In Layout LM, one of the key features that the authors introduce is to integrate the text string along with the text location. So what's happening here is it creates this textual embeddings and their location embeddings of the x0, y0, x1, and y1. If we look in detail, to represent a rectangle, all you need are 4 coordinates, x1, y1, and x2, y2, since you know it's a uniform rectangle. So that has been put into the network as embeddings and goes into this system of Layout LM. On the other hand, you have this detection framework, which is faster RCNN connected to fully convolutional layers. This essentially creates this as a classification problem. So faster RCNN gives us these image embeddings, and they are concatenated with some of the embeddings that you get from the previously trained layers. On this concatenated network, we use it for downstream tasks. You could add a softmax classifier for document classification. You could add some other classifier for sequence classification. So by doing this, the authors at the time of publication at 2022, they were the best performing ones at 94.5% accuracy. And even now, I think there's one or two architectures that are marginally better, and they are at 95, 95.5, 96, or something like that. So Layout LM actually broke the ground and joined text along with vision for these tasks, and they actually unlocked so many different use cases. So as we saw, that it's the first time that text and layout was jointly learned, and it adds these two types of input embeddings to the BERT model: the 2D position embeddings and the image embeddings for the scan token text. The architecture we saw in the previous slide has improved upon BERT, and also for the pre-training of this layout LM, they added two loss functions, which is basically multitask learning objectives of masked visual language model. So earlier in BERT, how it is pre-trained is masked language model. There's no visual in BERT. And in layout LM, they create a masked visual language model. So I'll just give a brief about BERT. In a sentence, during pre-training, some of the text or some of the words are masked, and the task is for the network to predict the masked word. So that's how BERT works. So there's some sort of processing and randomization that happens for the masking, but at the core level, this is how it works. Now for masked visual language model, what happens is the image along with the text, or basically the image itself, is masked, and that is input to this system, right? So you have masked images, you have crops cut out from this image, and then OCR will not be able to read that text, so there'll be a gap. And in the image embedding also, it will be altered because that crop existed in the data, and that's how they train it on 6 million documents. So they do a joint training for this masked visual language model. So the task here is to predict what word will be there and how it will look like, the image of the word as well. The other loss that is applied here is document classification loss, where it treats this similar to our ImageNet problem. So in my view, this has unlocked some sort of like a Transformers plus world, where we are able to leverage word and position embeddings for our different tasks. And some of the tasks we saw before, and you can see from the data that they are able to break quite a few barriers. So form understanding, the previous benchmark was at 70.7%, and they had a 9 percentage point improvement through this architecture. Receipt understanding is at 95%, and document image classification at 94%. And this is the state of the art right now. So one question people may have is, how do we get started? What can we do to leverage these architectures? So one personal project that I could recommend is information extraction from receipts. And it could help to track finances from purchase receipts. And it's something you could apply for your own learning and financial journey. So what you could do is essentially download this dataset, SROI dataset, that contains information of receipts and their bounding boxes. Use this dataset. In this dataset, essentially there are 4 fields for extraction, which is the company date, address, and total, which looks like this for this receipt. And that's how the extracted information will look like. So now you have all the data in place. You could essentially use layout LM to form understanding. So basically it will learn joint representation of your receipt words and location and help you extract this information, just these 4 fields from an image of a receipt. And in your real-time pipeline, you can also integrate Tesseract for converting the image of the receipts into OCR output text and bounding box, and then put it into layout LM. So there is one notebook that is published by Niels Roge, and it's available on GitHub. I put the link here. I'll probably share it in the comments later on again. And you could use this as a good starting point for your applications. We have seen some of the state of the art and different tasks that exist in document understanding, but it's still an unsolved problem. People are coming up with ways to handle large scale data where there is millions and millions of images in databases of companies, in large websites, e-commerce websites. So people are trying to apply self-supervised learning in those domains. The other part of the spectrum is where data is very scarce and you do not have sufficient information. So in those areas, people are trying to apply few shot learning. Some of the parts that are susceptible in this whole pipeline is image capturing and pre-processing that plays a large uh, a large part in how information is extracted and how well you are able to extract the key information or form understanding from these images. So if we can improve on image capture in image pre-processing areas. The other part, when you're dealing with large scale data, is lots of noise and how to deal with that. So just some open research areas that I wanted to touch base upon before we close. So that's all from my side. I hope I was able to give you a good overview on this topic, and we'll move to the questions.
Yeah, thank you very much. And I will ask everyone else to join. We have Serg here with us. Hi, Serg. Please unmute yourself. Yeah, now we have you over here. Also, we have Daniel with us. Hi, Daniel. Hi once again. And also we have Benjamin with us. And here is Benjamin. So thank you very much for joining us. Thank you very much for presenting, and thank you very much for sharing your knowledge. And we have some questions. Please pardon for the delay with the beginning of the Q&A session, because we kind of got off the schedule a little bit. Yeah, but I'll start directly with the questions, and let's start with this one. And please pardon if I would not be able to identify who this question exactly is directed to, because not all the questions, they have names. So please, if that's question you feel like you want to answer this question, please just let me know. Yeah, so let's start. Does online completions like Kaggle, etc., bring much value to building one's portfolio? And I believe this one was Serg, either yours or maybe it was Daniel's.
Yeah, I'm not sure, but yeah, I can answer that, and then Daniel can fill in. I think it does bring value. Much depends if that means like it should be everything. I definitely think that's not the case. I think it's a good experience. And as far as like showcasing your work, like unless you're planning to like obsessively try to rank and become a a Kaggle grandmaster or something like that, you get no bragging rights from saying you're like in the 300th place or something like that. Honestly, it's a good experience, but you're better off trying something original, because everybody showcases Kaggles in their resumes. And when I see a resume, someone applying to my company, I rather see like original projects that have to do with the industry I work in, especially.
Okay, Daniel or
Yeah.
anyone else?
What I would add to that would be that Kaggle might be a good way of starting off a project. So it might be like, oh, there's this Kaggle competition. It's really interesting. There's a whole community of people competing on that specific thing. Maybe you don't get to rank on the first one. I'm sure maybe you're not a grandmaster, but that would be a great opportunity for you to be like, wow, this is an interesting project. Maybe I would want to expand on this, add more data, collect more data here, make this into like an entire application. So again, it also kind of depends on what kind of role are you seeking. Are you seeking just like a data science role, or are you seeking more of like a machine learning engineering kind of role, right? So that also will change the perception and the approach that you take.
Okay. Ben, Kshitij, maybe you have something to add?
Yeah, I'll take a stab at it. So I agree that it's a good starting point, and also in your learning journey when you're not sure about which areas of data science or machine learning you're interested in, it's good to get that breadth in. And once you know these certain areas you're able to tackle or that arouses your interest, you can use other resources to dive in deeper. And as someone said here, that you could get projects that are more related to the field and you operate.
All right.
Yeah, maybe to comment on that. Yeah, I think it's very relevant, and as the three of us have said, in this field, sometimes maybe if you are new to it, you need to keep practicing, because you cannot always wait to always learn on the job, although it's the best place to learn on the job and corporate. But also it's good to identify some various use cases, try to see what other people are doing out here. How best can you use what they are doing to maybe learn something or even come with something better or new? That's also a good way of building your portfolio, and even your Git will be quite an interesting one when you have it in your CV and such like things.
Okay, thank you. Here is another one. Or let's start with this one. The previous one was kind of long. I'll need to digest that one. So let's start with this one. Which is the best ML model deployment tool? Anyone is welcome to answer.
I mean, I can take a little stab at it. I think it really depends. I mean, as with many things, right? It depends on the demand, right? Like, are you gonna be serving millions of customers, or are you gonna? Is this like a side project that you're doing for one or two people, or people are just gonna be visiting your website and looking at it, right? Depending on how fast does it have to be? Do you need to deploy it, or can you just do things in parallel, right? Sort of like asynchronously, right? So there's a lot of questions there. And so to maybe give some answers to that is like, generally speaking, most like cloud computing platforms will allow you to do, scale like production. So that would be your Google Cloud platforms, your Azures, your AWS. They're going to be comparable. They're just like cloud computing technologies that you can just deploy, put a Docker container to wrap your model. But again, one of the things actually that I think is very underrated is actually something like AWS Lambdas for then being able to deploy very small and lightweight APIs that run on demand. And it's just-in-time computing, which means that you're only going to be charged for what you are using. And this can be really helpful for personal projects, because it means that you can have basically an API, a regular API, but also be able to have really, really good compute. And at the same time, like only if someone is requesting that project, that model, it's going to be able to react. So, and also, sorry, the biggest thing is they have 1 million free requests per month forever. So it's really good for value proposition for people that are just getting started. and just want to get something out there.
Awesome.
Well, that's very well put. I would add, and this is coming as a former web guy. Like there is also the ability, if you don't have AWS, if you don't have any cloud provider, you're starting out. Like you can do it on Heroku or DigitalOcean or one of those. It's not really nothing for although for training you might need like specialized services, GPUs and that sort of thing. For inference, you all you need is fast API or Flask and container and some really cheap, $5 a month or less web hosting. Nothing fancy is really needed unless you're like on the job and you have like this access to these cloud providers that charge by the by the compute, which can really add up. So there are use cases for that, but starting out, I would say not always the case.
Okay, thank you. Okay, so we have another question. So this one is definitely for Benjamin. The SQL can be written by a wizard or by hand. So this one is related to your presentation, I believe.
Well, yeah, SQL can be written by wizard or by hand. Well, let me start with by hand. Because what you're trying to find out is maybe a scenario to get a specific result. So in this case, you have to do it as me. I have to do it as me because I understand the use case. Wizard even understand maybe his point of view. Probably there are defined tool sets whereby you will be using user-based interfaces, maybe dragging and dropping and all that. But even at the end of the time or the kind of task you're doing, you can be able to get an SQL script from that. So maybe this is not for the techie people, but if you are really good in SQL, then you can go direct on query. That's how I would put it.
Okay, so since I have one more question related to, or two more questions related to your presentation, I'll ask you to cover those ones. So you did not insert the ID column. Is the ID column done automatically?
You're talking about the primary key? I believe so. Yes, sure. Yes. Definitely so, yes. So when you're doing your syntax, you can well define in SQL whether you want it to be defined automatically. So the answer is yes for that specific one.
And how do you set if a column is numeric or string? So I believe
definitely. Exactly. So this is one of the function I used. You can, if you can remember, I used is numeric. So for this specific use case, I was using the Microsoft SQL. And so if you select is numeric a certain column, it should return either a 0 or 1. 1 means true, 0 means it's false. So for that specific one, if you want to check if it's numeric, it should return 1 if it's true. So if it's not numeric, it will return 0. So it's a kind of a way of filtering out such scenarios if they are there.
Okay.
Got it?
Okay. Just a second. So this question, how the algorithm runs correctly from left to right before identifying the language. Tricky. So I believe this one is for the last presentation from Kshitij.
Yeah, sure, I'll take that. So I think the question is basically in the structure of parsing the document before identifying the language, and the person has rightly pointed out basically before identifying the language you cannot do that. So typically in the modern OCR systems, there's a first language identification step and document parsing step or document layout analysis to identify where the words and structure of the document is. And after that, it decides the order of reading this document. So that's right.
And also, here's another one. Can you correct wrong numbers by understanding the math behind the receipt?
That's a great question, I would say. So yes, so let's say the tax component is 3%, right? And you could probably do some basic algebra to identify if that was correctly extracted or detected. And you could definitely use math in certain parts. The other way to identify errors is also, it's somewhat similar to a human system, right? If a 2 is always confused as some other number, let's say as a 0, so by understanding when this replacement errors happen, you could have essentially another ML system to correct these errors. If that makes sense.
Great. So another question for Benjamin. Please share that it's not a question; it's a request. Please share the slides. I never touched pivot in SQL. Okay, so let me check. What else do we have? Another one, I believe, for Benjamin. How do you set if a column? Okay, we answered this one. Pardon. Okay, question for Daniel. Daniel, what would you say is the main challenge you have encountered on your journey as a ML engineer, and how did you overcome it?
Right. There have been many different challenges. Very briefly, I would say there will be like categorized in maybe two components, right? One would be professionally speaking, and then the other one would be technically speaking. So on the technical side is just getting over the hurdle of you don't always need to understand like all of the nitty gritty of, like, let's say a new paper comes out. You don't always need to understand like all of the little like small pieces of math, because chances are you can just use the model as a library, for example, at some point. Different things like that. And so like getting over that mental switch, particularly from college, to saying like, okay, like you have to like understand everything, to, oh well, understand the things that you need and go as deep as you need, was kind of like a technical challenge that sort of like I had to like get past. And then professionally speaking, I would say biggest challenge was sort of like getting into this aspect of having companies sort of like believe in me being able to actually do machine learning work, right? Because there is to some degree a level of credentialism that exists in the US about, oh, hey, like, you gotta have like this kind of degree, so on and so forth. And so some places are gonna restrict it. And so I just had to like apply to many different places, find a lot of different opportunities to then eventually be able to land into those sort of positions, and a lot of like self-advocacy and sort of like reaching out and finding those opportunities that I had to do, right? And that was certainly a challenge, but very much so very rewarding.
Okay, thank you very much. And we have a question for Serg. What does climate data scientist actually do?
Yeah, actually, my title is Climate and Agronomic Data Scientist. The emphasis on the agronomic. So that has to do with agriculture. So what I do is a lot of digital agronomy and precision agronomy, and the idea is to help farmers make better decisions through our predictions. So yes, there's a lot of weather involved, because weather is very important variable, well, set of variables for everything that has to do with agriculture. So that's where the climate part comes in. But yeah.
Okay. Awesome. Thank you. And we have one last question. I guess this will be for everyone, and I'll ask you just take like 30 seconds to briefly give your ideas about this one. So, if you have an opinion on this one, how generative algorithm impact in some ethic concepts, discrimination bias, for example, deepfakes are becoming very harmful. So, and we have a couple of questions which are pretty similar to this one. So We can start with you, Benjamin, and then maybe Daniel, and then Serg and Kshitij, if you don't mind, like that. But
Well,
if
maybe
you
I
have,
will pass it, probably.
okay, Daniel.
Yeah, I think this topic is incredibly interesting, and there's a lot of different aspects that are going to come into here. It's not just the ethics of like, okay, someone is like making a deep fake and then creating, let's say, blackmail of a person, but it could also be in the marketplace. For example, we have generative models like DALL-E, where people are then able to generate art. Well, what then does it mean to be an artist? And especially when it comes to popular marketplaces where people are creating t-shirts and mugs and different things like that and then selling them. This could be like a big issue when it comes to like economics and the ethics of hey, this is my art, but actually it was just an algorithm that made it, right? um, and I would say like, yeah, there's also this aspect of these models sometimes are not trained on a diverse enough set of data, which then means that the things that they're going to be able to produce are not going to be representative of the entire population that they are trying to simulate, right? So again, I would just say that at the end of the day, we have to be very careful about not just blindly trusting a model and saying, okay, well, it says this or it's doing this, therefore it's good. And also not just saying, well, because it's a model, I can just use it without any repercussions. Like, no, we are actually creating this field and we are actually leading in the way in which we use AI tools. And that is a very large responsibility that we all have to take into account and be very cognizant of the kinds of products and models and research that we are producing and creating.
Okay, thank you very much. Serge, maybe you, Kshitij, maybe you have something to add to this.
Yeah, definitely. I wouldn't just say generative algorithms. I think the greater source right now of bias and ethical quandaries is discriminative algorithms. And generative just shows it in a different way. People are surprised when perhaps they start writing an email and they mention a doctor and then it fills in like a he pronoun in there and they're like, oh, that's strange, right? It assumed my doctor is a he, right? But that is perfectly normal, and it just comes to question the same training data that's used for many of these generative algorithms is used for discriminative ones. And more often than not, people don't notice what's going on with discriminative algorithms as much. It's not so easy for them to find out, like well, at least here in the US, finding out how your credit score is calculated is a pain, right? And so like if you're denied for a loan or something, you have no idea what they have. And in theory, they're supposed to, take out all these discriminative factors, but there's so much like that bleeds in. Like a lot of variables are correlated with each other. So you may say, well, they don't have race in there, but there's other variables that do correlate with race, and that is being used against you. So the question here is, how do we remove bias from data? And it's really hard. In my book, I have a chapter devoting on mitigating bias, and it's really tough. And it's tough for discriminative, and it's just as tough or even tougher for generative. One thing I have to add about generative, like especially deep fakes, like I think actually it's an opportunity. Deep fakes and any kind of adversarial robustness problem is an opportunity for us to make the algorithms more secure. So I often relate it to my own experience in web, in the early days of web, how insecure the experience of websites are, and of the internet in general. And it's gotten a hell lot better, I have to say. So there's opportunity for a lot of work there and a lot of improvement, so people trust the technology more.
Okay, thank you. Kshitij, if you have an opinion on that, please. And we are about to wrap up.
Thanks for the comments, Daniel and Serg, and I agree with quite a few of the points that you have made. Moreover, I'd just like to highlight that there are two parts of this coin, right? The people who are able to generate such deepfakes with such amazing accuracy or amazing images or videos. One part is the latest development. OpenAI is trying to control who has access to such uh, models. State of the art DALI 2 is actually controlled by OpenAI, and they're giving out limited accesses. Another part is they're not allowing people to generate images with specific prompts. Like you can't give a prompt that Trump doing something, Trump reading, Trump jumping off, so on and so forth. So certain parts are actually being restricted to control the generation of such images. The other side is on the detection, where companies like Facebook are spending a lot of energy to identify these deep fakes early into the system. So when you upload on Facebook or on Instagram, there's lots of algorithms that try to verify what you're uploading, and they have made lots of strides in identifying deep fakes because they have certain signatures in the image, in the pixels, that are not representative of real images or images that are created by artists and stuff. So it will have certain artifacts which another algorithm could essentially view. So both the sides are happening, and we are trying to balance it. Of course, people also have to play a larger part, and I'm sure some regulation might also come in the future to tackle this.
Okay, thank you very much. Thank you, everyone. It was my pleasure to spend this 3 hours with you, and thank you for joining us. Thank you for answering these questions, and I hope to see you this autumn for the second edition of this event. So have an awesome rest of the week, everyone.
Thank you. Thanks for having us.
Thank you very much.
Thank you, everybody.
Okay, and I have a quick short announcement. All right, everyone, please have a quick glance at your emails, because I believe 10 of you received an email with a ticket, and you can check your access on the platform. So you won a ticket to our senior day, and at the dashboard now you can choose second and third day. And also we have Ivan with us. How are you doing today?
Hi Paul, I'm great.
Okay,
Yeah, it's nice to be here.
Thank you for joining us. And my shift is over to you, Ivan. Have an awesome day and have an awesome block.
Okay, thank you. Hello everyone, my name is Ivan. I'm glad to be here with you today. So I'm going to moderate this event for next couple of hours, and we will have 4 speakers with us. They will present their topics. Also, please prepare your questions. The speaker will answer them on the Q&A session. Please welcome our first speaker, Javier. He is data scientist at Qatar. Javier will start with our topic, learn about Huggingface to start your journey in machine learning and open source. Hi, Javier, how are you doing?
Hi, Ivan. Hi, guys. How is everything going? I'm great. I'm great.
Okay. Thank you for joining us today. Thank you for sharing your experience with us. Also, I want to add a quick announcement that you can use Geekle data science hashtag to share the session you excited the most on social media. Also, please share your feedback with us. It will help us to shape our future conference. At that point, I guess we can start. Javier, the floor is yours.
Thank you a lot, Ivan. So yeah, in this talk, I'm gonna talk about mostly how or what is Hugging Face mostly. I'm not gonna focus a lot on the technical part of machine learning. I'm gonna focus on the community part of Hugging Face, right? But I'm also gonna show you some code. So talking a little bit about me, well, I'm a data scientist working at Kantar. Kantar is a market research company where we are working in giving insights to our clients using, data science and machine learning techniques. And basically, in the last couple of months, since I'm also a senior student studying AI engineering, I've stumbled upon a huge rock, right? The problem was that I was trying to find a way to share my knowledge, to start participating in a place where I can feel like very listened to in the part of machine learning without the need of being like a total expert, right? Besides that, I am a data scientist. There's a lot of people that maybe they don't have a job, maybe they're like kind of starting their journey in machine learning and they don't know how to ask questions or where is the correct place, because there's a lot of communities on, for example, Reddit. There may be some communities on Twitter, but uh, some years ago there was like a huge platform that was like very centralized and very focused on this. So for a lot of people, machine learning also can be quite intimidating and complicated to break into. However, nowadays there's like a lot of tools, as I mentioned, and then a lot of communities that can help us to start our journey in machine learning, and it will provide you with a lot of examples, a lot of demos, mostly, and tutorials, because a lot of the times with machine learning, one of the main things with courses and a lot of information or tutorials is that a lot of tutorials tend to focus a lot of the theory part, and there's a lot of people that really don't like that. There's a lot of people that really like applications, mostly engineering students, because they're not really focused on the theory. They are focused on how to use or how to use some usage to these models, mostly how to deploy them, right? And you can ask yourself which platform, which community will help me to get to my uh, correct area in machine learning, which will help me in the future to start providing with information to get to know to other practitioners in machine learning that are also in the same path as me, and how can I deploy a model at the same time. So there's a lot of people, that is trying to get into machine learning lately, and it's getting kind of confusing. So there's a platform that is called Hugging Face that I think a lot of people that is watching this live stream right now can know of. And basically, I think that Hugging Face is a platform that can help us in guiding us in one of the friendliest ways possible. And that is because Hugging Face is not only like a platform where you can find some models, some code, and that's it, right? There's also multiple tabs in the Hugging Face page that I will present to you right now. And these options will show a lot of the parts that are extremely important in the AI or machine learning community. So I hope that you're watching my screen right now. So yeah, basically, this is a Hugging Face page. I'm going to give you like a guided tour in order for you to understand all the parts that are very important for us to train a model and are very important for us to interact with other machine learning practitioners. So basically, we can start by watching the home page. And as you can see, it's like very friendly. That the UI is very easy to guide into, because once you start, like for example, this is my activity in the last couple of months. The last activity that I made was that I created a model, right, in the last couple of months, and it will show you that space. I'm going to explain later what is a space. So I think that one of the things that are very easy to start looking on are the tabs or the navigation tabs in this part of the page. So we can see that, or a lot of the time, people will tell you the most important things that are in a community in a machine learning setting are data sets and models, and that's totally right. Like machine learning cannot function like one without the other one. So basically, this part of the Hugging Face platform is like one of the most important ones, but there's also been a lot of changes within time. So I'm going to tell you about the model parts. So the model parts are basically like where you can find like thousands and thousands of models. Like you can see more than 50,000 models are available here at the platform. And this can bring us the conclusion that Hugging Face has been very important for not only like open source contributors, but also companies to bring out their models to the open source community and try to bring as much impact and value for people that maybe are not in an industrial setting, but also from their home. Like they want to try out like some new models that are very popular right now. For example, GPT that is from OpenAI, and you will want to start like contributing to know how to run some code, how to deploy a model, etc. So you can find basically almost any kind of model here. For example, I think that one of the most um, famous algorithms or models that are right now is the Lee one. So basically, there was some group of people that tried to, give opportunity to the people to try out the Lee in a very easy manner, and this model has been quite popular, essentially in Twitter, right? So these kind of opportunities will bring you to the conclusion that not only I have access to tons of models, but also to the most popular ones. And this can be easy because you are sorting it from the most downloads. You can also sort it from the recently updated. So the Hugging Face platform automatically will update every single model that is being trained right now or that is being deployed right now. So there is no like necessity or trying to monitor every single movement. You are already automating this process from your computer. So if you're trying to upload a model and you already have the script ready in this platform, the thing that will happen is that Hugging Face will automatically update the information about this model and the usage of this model. And I will talk about later, like how you can use this model in different places in any demos. But basically, this will update the behavior of those kind of demos, right? So it is very important to know that there's no need to worry about how it's updated and how it will affect your demo. If you already are trying to have some use cases for this new updated model, there's no need to worry. So basically, also the Hugging Face platform has a lot of things, like for example, a lot of tasks. I think the previous speakers tried to talk about a lot. The different usages of machine learning and how to start your journey, etc. And as you can see, there's a lot of types of machine learning techniques. There's a lot of use cases. There's a lot of examples that are not only in the industry setting, but also in the research setting. And a lot of these models can be quite overwhelming because there's tons and tons of models that we can get an example of. So in the way that Hugging Face helps us in that way is to separate the models via tasks. So basically, we can start by computer vision. Maybe another day you can, you want to create a model that translates to another languages that are not like very well represented in some way. Like for example, indigenous like languages that are there maybe or have a lot of population that but they are not very well represented, right, in our countries, or people that don't have like and a specific model or a specific way to translate something automatically to some other people. So for example, translation models in this part like can be quite important for like, you know, some community or some population in order to translate things quickly. Maybe some person maybe, you know, for example, here in Mexico, people that are talking in Nahuatl, there may be Nahuatl native speakers that really want to learn more about Spanish. They really want to learn more about English. So this is an opportunity for the open source community to guide us and to try to create a model that will help us to you know, to give this translation to people that really want to learn some other languages. And this is not only like an opportunity for, you know, the state of the art techniques for some languages in the NLP area, but also like helping other people in their knowledge. So this is the part where Hugging Face excels, right? Like you don't really need to be an expert. You just really want to, if you just really want to help, Hugging Face will help you or guide you to try to create this model that will have a lot of impact in the future. So, for example, I think this is from English to German, I suppose. So the way that this works is that once you try to access a model, it will tell you everything in a model card. The model card is very important because basically it will tell us like how the model works, which were the parameters that were considered, maybe some benchmarks even, and which was a pre-processing in order to do that. You can also find for some models, for example, the original weights and the stat set translations and the scores that they have based on the performance of the model. Another thing that will tells us, or Hugging Face will tell us, is the downloads last month. So as you can see, this model like was hugely used, right? It's like more than 1 million downloads. And you can see it in this graph. And there's also like a hosted inference API. So not only Hugging Face, as I told you before, is not only to deploy some code and to test it out. So you can also deploy it as other kinds of very well-known platforms, but also you can deploy with an API, and you can compute some examples or compute some demos in order for other people to try your model out in the most simple way. So there's no problem like having evidence or on how your model works and what it can do. So basically, as you can see, I have already this sentence. My name is Sarah and I live in London. So for example, my dog is very cute, right? I can compute it and the model will load and it will try to inference based on the input that you gave it. Let's give it a second. So it will translate obviously to German, and obviously it will try to base on the data that it already has. In some cases, you may be able to, you know, copy paste a huge paragraph, but beware that a lot of these models are not that robust, or maybe they're not that big because they are not programmed to be that big. Maybe they are programmed to, you know, to basic vocabulary and basic sentences. And yeah, the model will start inferencing, and my hunt is as such. So basically, as you can see, this model is working pretty great. And after that, you can see some examples of how you can use these models. So as I told you before, these models not only can be deployed as, you know, like this, like a hosted inference API. So you can also have some use cases in demos that are called spaces. So I'm going to talk about spaces a little later, but basically you can know from now that spaces are the part of Hugging Face that will let you train a model consistently, right? and the space will have like a very good interface where you can test out your model in different ways, even with different parameters, and with a very nice, UI, as I told you. And the great part is that you can use other people's models, and since it's open source, you can use it in different use cases and different ways. So there is no need to have like some kind of permission, except if you're trying to modify other people's code. But in reality, this is the great part, another great part of Hugging Face. You can try a lot of these models, and there's no need to go to other place. Like the platform already has the way to download it and the way to train it, right? So yeah, I'm going to talk about the spaces a little later. So basically, this will test us the test set and the benchmarks, right? Another thing about this is the files and versions. Where when you are trying to to give some data to Hugging Face, it will tell you that the most recommended way is to do it in the GitHub or Git way. So basically, this has a lot of similarity to GitHub, where you are seeing, like, for example, this is a model. Let's say that it resembles a repository, as an example, in GitHub, where you can find the files and versions, where you can find even the TensorFlow model that is like currently like frozen in order to work with another computers, and the weights are already there. There's also configuration files and the README. This README, of course, is the part that contains the model card and so on. So as you can see, not only you can find the model card, but also as every single open source platform, you can also find the files. So you can also have, and this is a very new feature, where you have a community tab, and this basically will have like discussion forums as well as other platforms. I think this is not like very new, but it's kind of important to have discussions per model maybe, or per topic, or per documentation or space, because you can basically talk about anything related to the model. Maybe you can talk about a bug, maybe you can talk about a new use case, and so on. So I think it's very cool to have that feature in this platform. And talking about how to train it and how to deploy it, you had like two more options. You can also have like Amazon SageMaker, which is a very well-known platform for this, and the AutoTrain, which was created by Hugging Face, which is a platform with that with almost no code, you can like train some models in a very easy way. So that can be very, very good for a beginner to understand how you can train a model in a very easy way. Like, you don't need any kind of expertise in even Python, right? With the deployment, as you may know, you can have accelerated inference. Like, for example, this is a very thing for Hugging Face is a very important thing, because it tries to deploy a lot of models frequently and very easily for a lot of users concurrently. So it is very important to have a very fast inference, and you can also use Amazon SageMaker. So this is all great, but how about like coding? How can I use this kind of information to try it out? So it is very easy. The way that you can use this kind of models is via the transformers library. So basically, this is like a very important part of Hugging Face. I think is one of the most well-known parts of Hugging Face, which basically is a library that provides a lot of, as it says, pre-trained models to perform tasks on different modalities as text, vision, and audio. So I think it's very powerful, because this library is very easy to use. As you can see, you can import it in the most easiest way, and you can initialize a tokenizer and then initialize the model and then use it however you want. So there is no need to start trying to code out like the whole model. And if you're trying to pre-train again, there will not be like a huge disadvantage to other frameworks. It will be very easy and very, very fast. um, you can also find like most things about the model by itself, like not the pre-trained model with some English and German data. You can also find the original model, which Marianne MT model, and it comes from the transformers. So it will tell you how it is trained, which parameters it has. This can be very useful because you can find how it works exactly, and which things you can or you may consider when you're trying to train this model again in order to have another task. So this is very important, and it can be very easy for a person to not only trying to have like the pre-trained model in order for a test. Maybe you can give it another use or another test, as I said, another languages. And yeah, here's an example that you only need the source language and the target language. Then you need the model name, and you need to extract that model from the Huggingface transformers library, and then you can just decode it or generate the usage of this model, and then you can decode with the input that you're trying to give. So basically, from French to English is basically translated very easily, and the inference can be done very quickly. So in the part of the code, there will be no problem for beginners. I can assure you that. So in that way, Hugging Face is very friendly too. So I'm gonna go for the datasets part before talking about the spaces, because another important thing, of course, about using the model is which data are you training the model on. And you can also do this. There's people that prefer to have their own dataset and not publish it, but I really recommend that if you're trying to get into machine learning communities, try to reach out to a lot of people, or try to reach out to the people that are like publishing these data sets, because there's a lot of things about this. Let's see, I don't know, maybe Wikitext. So there's a lot of things to consider here, because the dataset part can be a lot trickier than the model parts, because you have like a subset. You can try to search up for different subsets of the data sets, and you can also see the test, the train and validation sets. So in this way, the complication may be that maybe you are trying to train the model in a very different way. There's a lot of people that don't have validation sets, and that's totally valuable. Like, there's no problem. But in the community, there's a lot of people that really value that you have a validation test set. Sorry, because it's very important to validate how your model works. And so basically, you will have tons and tons of examples on how this dataset is reviewed. You can also have a dataset card, as well as the model card in your models part of the Hugging Face platform. You can also find supported tests and leaderboards, and the languages that it supports, and basically the data instances, etc. There's also a lot of things about Hugging Face, where a lot of contributors try to give their models as much impact as possible. So they're not only trying to publish their work out there and try to say, hey, I done this amazing thing, but they try to give it a very social impact sense, in order to help other people to get into these kind of platforms or these kind of communities. So yeah, you will find out that in a lot of data sets and in a lot of models, they will talk about the social impact of this model. So there's also files and versions. You can see that in this part, there's like a lot of data, and a lot of data that is like very updated currently. Basically, in this part, you can also update your information as well as the models, and it will update the behavior of your demo in the spaces part. but you may consider that maybe the model is not that big. Like there's models that are, for example, the generative ones, let's say the GPT ones are quite big. They're quite big to train and quite difficult to manage around workspaces and from your computer and servers. So try to take in account that if your data set is like very very big, there can be some problems, or not problems, like it can be slower to have some changes or very visible changes in your space. So take that into account. Also, if you're trying to have some fun and try to also give a try besides the inference API, you want to create, like, for example, a demo. And let's say that you come from a web background, right? For example, me, I came from a web developing background, and when I started, like, machine learning, one of the main things that I started questioning is that how can I deploy a model into the web? How can I use it in the future, and how can I demonstrate the usage of it? So the spaces part is basically that you can discover so many machine learning applications that are being used with a framework that I will talk about it later. And it helps you to basically have a UI and take into account many edge cases, a lot of parameters that maybe were not taken into account when you're training the model. So yeah, you have like very very huge models here. What can I have? Let's say the Lee gallery, right? And let's say that no, it doesn't have anything. Well, we can go for Dali directly. This is the most popular one. Yeah. Basically, you will have like an AI model generating images from any prompt. So I'm sure that a lot of you guys have seen this one working on a lot of stuff. Let's see if it's gonna work right now. So you can start like running immediately your models with this interface. And as you can see, it's very friendly. Like, it's very important to see that how it works, and that the interface is very easy to see, and how easy and manageable it is. So in your demos or your spaces, you can also find a lot of people that are trying to give the limitations, the biases that are in the model. And I think that is very important to say that it's important to clarify that your models aren't like Superman, right? They have tons of limitations. Maybe they're very expensive, like in computation, as well as DALL-E. There are models that are very fast, but they don't have like that much accuracy. They're not like that much of a usage. Like, they're not very useful except for a niche specific topic, right? So um, I think that is very important to remark that, and to have that into consideration where you're trying to deploy a model here in Huggingface. So I think it's taking a quite long. I think it's because Delhi can be very expensive, but basically the part what I was talking about some minutes ago was about the linked models. Yeah, it generated. Cool. So as you can see, I could say that the main bias here is that, of course, tons and tons of pictures of koalas are in their trees at their home. So basically, the model will understand that if you want to generate a koala, the context of a koala is being in a tree, right? So this can be like a bias, but I don't think that's a problem. I think that's totally okay, because most data, I'm assume that from koalas images are on trees. So there's not like very huge problem here. So what I was talking about some minutes ago, like the usage of your models can be very distinguishable from others, and you can use it for a lot of things. Like, maybe, for example, the English to German one, is very impactful because you cannot not only use it in some few cases, but you can use it in huge applications, right? And this can be seen with the linked models. So basically, every single space in Hugging Face needs to have a link or reference of which model is using right now. So the demo by itself is an application, like a user interface application where you can use a model as a backend, right? So basically, it will tell you like which models are linked to this demo, and you can access it very easily, and you will have the same things that I told you before about the spaces and the demos that you will have in this platform. So basically, this is like the main thing about Hugging Face. I will talk more about the part that where Hugging Face is also doing a lot of work, which is documentation and also community. So documentation is very important in tons of platforms and tons of programming languages, frameworks, and very a lot of things that data scientists and programmers have. And this documentation is very easy and very straightforward. Like it will tell you everything about the Hugging Face platform. Like almost everything that I told you in this conference will be there. Like you can access it right now, and you will have some models about data sets, about spaces, and others. Um, you can also find that the spaces thing cannot only be done with Gradio, which is the main platform that Hugging Face uses. You can also have static HTML spaces. So if you're not that comfortable with Gradio spaces that mainly uses Python in order to have like a framework or UI, you can also find that static HTML spaces can be very helpful for you, especially if you're a web developer, right? So as you can see, this documentation is very straightforward. It tells you what to do, and it tells you a lot of links and how to do things. So this can be very helpful for beginners mostly. So talking about Gradio, Gradio is great. Like you need very little information about how to do things. For example, a text box can be used in this way, but the only thing that you really need for Gradio in order to work is some lines of code. So searching for it, and you can see some examples of how Gradio works, and this can be totally implemented in Hugging Face. So basically, you're trying to import Gradio as a library, and then you want a model here, right? You're going to train your model, or you're going to have your model users here, and the interface is pretty straightforward. How are you going to use it? Well, your function that will try to give functionality to the interface is sketch recognition, which is the model. Which will be the inputs? Well, the inputs can be a lot of things, but in this case, it's a sketchpad. So then you have like some outputs, and which will the outputs be? Well, I need to have some labels in order to have. So let's try to, I don't know, like draw a cat or something. And the most probable thing is that it will predict that, oh, well, I think I draw it as a pillow, but there you have it. Like there's a lot of information that you can compute on these models in order to have like very accurate results or very raw results, as well as this, where you can have multiple examples and multiple uses. I think this can be very helpful, especially for people that are very interested in interactive apps that use machine learning. They're very interested in education, and they're very interested in having some examples, maybe not only for their class and not maybe only for their work, but also for themselves, and try to process how these models work. Gradio does not only support computer vision related stuff. It can also manage question answering, image segmentation, and speech verification, where you can also record from your microphone. So that's very cool. Like most things about this are very good.
Javier, sorry for interrupting your great presentation, but we still have a few minutes to ramp up. Yep, sorry.
Okay, no problem. So finishing up, I think that it's very important for you to try to give it a try to Hugging Face. And the thing about this, as I told you, is not only the platform, it's also the community, where you can have like a lot of courses where you can try to understand more about the platform and how to use it. And also give it a try to the blog. The blog talks about a lot of the stuff that I'm talking about, and it's very like very well documented. It talks about use cases and how they are using their platform in order to give some knowledge to the community. And there's also a lot of support from their machine learning engineers, mostly on Discord. And so yeah, definitely take give it a try. I think it's very important for every single person that is entering machine learning now to give a try to Hugging Face, not only for because of the platform, because there's a lot of people that are trying to reach out to you in this community and try to give you as much information as possible at these kind of forums or Discord groups. So yeah, I think that's pretty much it, and I thank you a lot for your time.
Thank you, Javier. Thank you for your presentation. It was very useful and interesting. Please stay with us. We will have a Q&A session at the end of the block. And see you then.
See ya.
Yeah, bye.
Thank you. Bye-bye.
So, everyone, once again, if you have any question, please please just write down it in chat, and we will have a Q&A session, and speakers will answer them. Also, one point I would like to say, we still have tickets for the Pro Day. You know what to do. It's easy. You just need to write down the question in the chat. And we move forward with our next speakers. Hi, Kundan.
Hi, Ayhan.
How are you today?
Doing good. Thanks for asking.
Yeah, Kundan is an engineering manager and works for Microsoft, and will share the topic deep learning for NLP.
Yeah.
Yeah. Could you tell us a few words about your experience?
Sure. Thanks, Ivan. Hey, hi everyone. Good morning and good evening, whatever the time zone you are joining from. My name is Kundan Karma. I'm the engineering manager in Microsoft. And just to tell something about me, I'm having 16 plus years of software development experience, and since couple of years I'm working on a data science and machine learning projects. And I done my Bachelor of Engineering in Information Technology. I done my Master's in the Machine Learning and Artificial Intelligence, and currently I'm pursuing my PhD in Data Science. And I'm working with Microsoft since more than 6 years and handling the data science, machine learning, and software engineering projects. And today I'm going to talk about the deep learning for natural language processing.
Okay, thank you again for being with us. Also, a quick reminder, at the end of the session, we will have a survey. Please please share your feedback with us. And at that point, floor is yours.
Yeah, thanks a lot, Ivan. Hey everyone, so I hope you could see my screen, and let me just put it on this presentable mode. And um, so I will be looking into another screen, and then we'll talk and discuss on this topic. So this topic is about the deep learning for natural language processing. And I already introduced myself, and let's move ahead. So now you could see now, because data keep on growing, I mean, each and every field, specifically the text data we think of. And the previously we used to keep our all the documents in the files, paperwork, and everywhere. Even if in the digital world, if we keep on keeping our documentation, or we're doing our communications, most of the time we use the text. And the NLP is one of the field that we can call it as a natural language processing. And natural language processing is the actually the capability of the computer to understand the human language, uh, it's spoken or written. um, Often we call it as a natural language. So whenever we do the communication with other people, or we would like to pass our message, we either speak or we write, okay, and we share it, right? Somebody can only understand that message, either from an audio or from a written, by understanding first the language. You mean the language means the technicality of the language, uh, understanding the language words, uh, their letters, right? And then on top of the grammar, right, what the grammar being used for that language, somebody need to have understanding of that. And sometime beyond grammar as well, like sometimes some sentence has some hidden meanings, right? So the person need to understand that as well. So it's easy for human beings to understand any language, whatever is their preference and the choice, or whatever they have learned for a long time. But to make this understand to the computer, it is little tricky, because the computers are nothing but they are machines. So we need to uh, make them capable so that they can understand our language, which is always in an unstructured form, and they can either respond us, reply us, or take an action based on whatever we communicate to them. So that is a field called NLP, natural language processing. Uh, and in the today's world, that is one of the biggest need as well, you could see. Now we, because we have a lot and lot of digital and text data around everywhere, you can see. So uh, in every domain and the field, like healthcare, banking, finance, social medias. So now we can make use of the advancements into the machine learning and deep learning for that processing of text. So these are the few of the top applications of NLP. Uh, like a sentiment analysis. Like suppose now from a text, we would like to know what is the uh, sentiment of the text is. Like, is it a positive sentiment? Is it a negative sentiment? Is a neutral sentiment? This can be useful in social media, or this can be useful for email communication, or this can be useful when some customer is logging some request. Like, is this customer feedback is good? Is customer is unhappy with the product, or customer is facing really some challenges in the problem? So by looking at the text, it's easy to understand the severity of the request, so that the customer representative can act promptly on that request. So this is about sentiment analysis. Some other text classification as well, like suppose in right now, if you write your complaint to any department, take an example of a banking department or the insurance company department or anywhere. uh, if that first that email need to be read, or that request need to be read by some person, then the person will understand, okay, this request belongs to some X department, like a banking department. This belongs to some credit card department. This belongs to some loan department, mortgage department. Then they can route it. So it's still the manual process. If we from a text itself, if we can classify, okay, this request is for a mortgage, this request is for the loan, this request is for the uh, some credit card transaction, then we can create some automated routing mechanism, so it can route to the particular department. So we can make use of text processing here, so to automatically classify text into some certain categories. And currently, if you'd see, like you could see around many virtual assistants, many chatbots. So instead of a person is typing and then responding you, uh, there are automated chatbots which understand what you are talking, what is your intention, for which area you are talking to that chatbot or virtual assistant, and then based on that, that virtual assistant replies to that, right? So and some good advancement you could see, like a language translation. Translating the one language into another, like if you went to some country, some place, you could not understand the language of that area. This actually services can really help us to convert the return language into our language of choice or preference, or the audio, uh, whatever we are listening into some other language. So it can really help the people to move around the places and understand somebody else language. Some others as like text summarization, corrections, auto correction, intent classification, urgency detection, spam and ham classification of your emails and SMS, whatever. That's like you keep on getting some spam messages. It's easy to classify so that you will not lose your the important information. So these are some of the important or the crucial applications of NLP. And in this session, we'll see how we can make use of deep learning for natural language processing. So let's move ahead from there. Okay, so in order to make use of an NLP, it is actually divided into certain categories. Like one is a speech recognition, like people do the dialogue communication or do speech and audio, or uh, communication, or record the audio. So that is one of the area. Another is the computer first need to understand the language, like whatever we are writing. The first thing is computer should be capable, or machine should be capable of understanding that. Second is responding with the same way, like in the natural way. Instead of responding in the mathematical numbers, it should respond in the same way which person can understand. So these are the kind of areas it is divided, or the three parts. And yeah, let's understand a little technicality of NLP processing. We can call it as a stages. So the first thing is, whenever we have a suppose written language, if we think or take an example of a written language, uh, the first understanding is that language, whatever is written, in order to process that text, okay, first we need to divide that whole text into some single words, or the whole text into sentences, and then each sentence is into some words. So we can call it as a tokenization, right? Dividing the whole text into some tokens, so each word can be understood by the machine and extract the meaning of that. So that we can call it as a tokenization. And after that tokenization, some kind of a things called stemming and lemmatization, like so in this one, like uh, suppose one word has many kind of forms, like present, past, future forms, like take an example of a go, went, gone, right? All three belongs to the same kind of an the word category. So one thing we can do, we can whenever we get such kind of words, we can always go to its the root word. We can call it as a lemmatization. And that can be achieved by the stemming as well, by some removing some prefix from the word, like a chopping the end, like a going ing. If we can chop, we can get that word. And gone, same thing, we can chop and we can get that word. So such kind of things. So in the lexical processing, generally we do the text pre-processing and the text cleaning. Text cleaning in the sense, many times some words doesn't make sense. Like take an example of in our whole sentence, there are some words like is, a, the, these are the words which supports our sentence, which don't have any meaning, but they support our sentence. We call them as stop words. So one thing we can do, we can remove that word, so that the size of the whole vocabulary to process will be reduced, right? So it's easy for us and computationally effective for us. Another thing is, there are some, always when you will do communication in the emails, or in any text document or somewhere, we write some kind of an special characters, some punctuations, some symbols, some special symbols. So it makes sense to remove all of them as well. So such kind of things we can achieve in the lexical processing stage of NLP. Another one which is called syntactic processing. So now once we have uh, the text is totally clean, we tokenized it. Now we need to check its grammar. Like suppose the sentence or our the text is grammatical correct or not, right? To understand its meaning, uh, the sentence in the sentence, the one word can be work as a verb. One the same word can be work as a noun, or same word can be work as an pronoun or something. So we need to understand in which context that word is coming, right? So we can call it as the POS tagging, parts of speech tagging. So it will tag each word with either it's the noun, adjective, or a verb, or whatever it is, so that it can tag each word too. So it can really help us to understand the syntactic information from the text. Another is the semantic processing. So sometimes what happen, there is a hidden meanings from the text, right? So sometimes whatever we are writing, um, some has some latent meaning. If it's easy for humans to understand that, but it's not easy for the machine. So in this one we do that kind of processing, like a uh, uh, dependency processing. So take an example of the Alex supplied uh, goods to uh, 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 some person, and so here there is a dependency. One person is supplying the goods to another person. To understand exactly the meaning of that one, it's only possible in the semantic processing. So such kind of a things we do here. So let's move on and uh, now understand what exactly the deep learning is and how we can make use of deep learning for NLP. So the deep learning is actually comes with a uh, uh, idea of the human brain, like how the human brain works. So like human brain has the neurons, and all the neurons are very much connected with each other. So they pass on the information. Each neuron will process um, the the very specific information, and then in order to process the whole message, the all the information which is processed by each neurons is combined by our brain, and then it has been presented to us, and then based on that we respond. Same idea is applied for deep learning or neural network. So here the deep learning is actually using the artificial neural network and making use of it. So artificial neural network is another machine learning algorithm. So it is trained with inputs, and it's loosely coupled. So it works totally like a neural network, like a human brain works. So let's understand that. So this is the one of the structure of artificial neural network. So here you can see like the you have an input is input can be anything, right? It's not only text. Input can be a text, music, or the images or anything. So now once you have input, that input will process across multiple layers, and each layer we can call each one as a layer. So this is kind of a layer one, this is layer two, and this is layer three. So we call the first layer as a input layer, the last layer as an output layer, and the all the layers which comes between input and output, we call them as hidden layers. So now you could see like how exactly each neuron works in neural networks. So each neuron has something called the activation function, right? This is one of the complex function which actually process the information, your information. So this function is different. There are many functions are there called ReLU function, 10H function, or softmax function, and many functions are there which you can read about them, so will not cover here. But yeah, there is some function which actually converts your input into output, but only for a specific input which is coming towards it, and each input data which comes through that activation function which has a weights associated with it. And this weights actually the one which has been learned by the neural network by training on your data. And this is one of the activation function which is we keep fixed. We always whenever we train our neural network, actually behind the scene neural network work go and identify the optimal weights which can be used to classify the information. So and then it is the whatever the output it passed to the next layer. So usually this the neurons are interconnected with each other. Like if you see, this neuron is taking input from all the neurons uh, from the last layer. Same like that, it's very much connected so that it can process the information at a scale. And then finally the number of neurons in the final layer is based on the output what we need to show. Like if it's two output, we need to show like a binary classification, more than two like a multi-class classification. So now in the deep learning, actually we make use of artificial neural network. We create a network and which has a millions of neurons or the so many layers around it, and they all are interconnected with each other so that they can process the information at a scale, and we can process as much as information. So it can help us to learn better compared to the conventional the machine learning. So usually these layers are very much connected with each other, and they process the information in the sequential way, the from an input to the output. And then it whenever they do the learning and they do need to do the adjustment, they do the adjustment in a backward direction. We call it as a back propagation. So this is the way like information keep on passing from one layer to another, so that through this uh, uh, deep layers we can process as much information and learn from the data. So this is about what exactly the deep learning and artificial neural network is. Let's see what exactly will not go too much detail, but we'll understand on a high level where exactly the machine learning and the deep learning have a difference. So artificial intelligence is a very broad category. This field has been invented very long back when we was not having the compute at a scale, and this something are based on the mathematical formulas, mathematical calculations and algorithm which was been developed long back. And uh, and the idea was like the machine can understand each and everything what humans can do or can understand. So this is one of the thing which we still not achieved everything in artificial intelligence. So now since last few years, because there is a latest advancement come into the compute power, storage power, the hardware is getting cheaper and we can afford the more advanced hardwares. So now there's a machine learning, which is actually the subcategory of artificial intelligence, which uh, actually try to mimic the behavior of a human being and try to process the information in an automated way, and it can make use of the machines like latest advanced GPUs, CPUs, and latest all the computations, and then make use of artificial intelligence algorithm and the predict the information or forecast the information for us. Now since few years we can see like now there is a latest algorithm been designed around it to make to process the data at a scale and do the as much as maximum parallel processing, and then it is learned from the how the human brain works instead of a classical algorithm, and then applied that to create the artificial neural network. And then the compared to the classical the machine learning, this is performing more better, but only the thing is for deep learning you require more and more data. So as more data will be there, it can predict well and provide better predictions. So this is about these three categories. So let's understand how the deep learning or the regular classical the machine learning life cycle looks like to process the text data. So this is one of the model building life cycle which I'm going to show, and the same we can show it into the demo as well. So here I'm going to show how the life cycle looks like, and then what are the stages which we need to follow to actually process the data. So you can see, like, first we have all the text data, whatever we have. We need to understand what we need to do. First we need to understand the problem. So once we have a problem, like we need to collect the relevant data and do some kind of an exploratory data analysis to understand exactly what the information is talking about, what is inside it, to explore as much as possible. So it helps us in the later stages. So once we explore the data, the next is the some kind of an the lexical processing which we talked about. We actually like a lower like convert everything into lowercase, remove the special characters, remove the punctuation, stop words, white spaces. We do the tokenization, dividing the whole text corpora into the words, and then we can either do stemming or we can do lemmatization. We can do some normalization as well for some places, like suppose we have some values, maybe we are using some numbers or values anywhere, that some values, suppose temperature, some temperature is in Fahrenheit, some is in degree Celsius. So we can come to the one scale, do this normalization conversion, or some other value. So that's we can do. Another is this is one of the optional things. So suppose if you really would like to understand the syntactic structure of your data, so this can be used especially for the advanced NLP application like a chatbot, virtual assistant, and some other place. So where we do the POS tagging, like parts of speech, like tag each and every token or word into its relevant like part of speech, like a verb, adjective, um, noun or something. We can tag them. So it will help us for uh, uh, to extract exactly the kind of an words from it. Uh, Name entity recognition, we can call it as a name entity recognition, so that we can easily know, okay, suppose some word we receive, like a take an example of San Francisco, then we understand that San Francisco is exactly a city. If you understand some food, like a pasta, then we know, okay, it is into the food category. So name entity recognition is the one where we can do this. And the next is now the one. So all the machine learning algorithms or the deep learning algorithm, not behind the scene, it is nothing but the mathematical the calculations. So everything works on the numbers. So because now we are working on a text, and the algorithm or computer don't understand the text, what exactly the text is. So we need to convert the text into the numbers, or we can call it as a vectors, right? So to convert that, we again need some kind of an the pre-processing. So we call this as uh, bag of words and TF-IDF, term frequency, inverse document frequency, when we do the classical the machine learning. But in case of a deep learning or some classical algorithm can also work with the word embeddings as well. But the word embedding is the one which is more and more popular right now, because it helps us to project the word into the low dimensional space, so that computationally effective. So that's word embeddings. It's convert your text into the numerical vectors, and put it into the dimension and dimensional space, so that you can know the similarity among the words, the easily classify the certain words into the same category. So yeah, that's the one here. Now we have everything converted into numeric form. Now it's easy for us to input that data into the machine learning or deep learning or neural network algorithm. So here we do once we feed the data, and then the model will train on the data which you supplied, and then it will give you the model output. That model we can use for all the predictions. Like, it can be supervised machine learning or unsupervised machine learning. Supervised machine learning, we have already labeled categories or labeled data, that easy for the algorithm learn itself, and some kind of an unsupervised machine learning as well, like a topic classification or kind of a clustering. So all such applications are also there. So let's move and jump into the demo which I'm going to show you. Okay, so how we can make use of neural networks. So now there is one thing called the basic neural network, which I just shown you. We just study basic neural network. If we think about this one, we have multiple layers, and one layer is passing information to each other. We can call it as a MLP, like multi-layer perceptron. Like this is one of the basic form of neural network, which you just need to go ahead and create the layers. First is the inputs, last one is output layer, and then you provide your input data to it, and then through around the layers, the network learn from your data, and then based on that it will adjust the weights and then provide the output and the finally model to you. So we call it as a multi-layer perceptron. First we'll see how we can use a multi-layer perceptron for the text classification. Another example which I will show you, there is one specialized neural network called convolutional neural network called CNN. So it actually works in a fashion where it convolve around the whole of text and then learn from the text what exactly the text, or in case of an image, it actually works like a filter which actually swap your whole image and learn what exactly image is talking about. So we are not going much detail into this, but you can read about it from the reference links. So CNN, so here actually we are using a special CNN called one-dimensional CNN. The 2D CNN generally we uses for the image classification, and beyond that 3D for the video classification, kind of 1D especially we use for the text classification. Okay, so here it is one of the either we can use some pre-trained, or we can create our own the CNN. So here you can see like we have the first layer is called embedding layer, or this is the layer we do all the word embeddings, whatever you are talked about, converting your text into numeric vectors. So this is the place it do. And then beyond that there's a multiple layer. So generally this area which I just highlighted, this can be keep on repeating. So because it's a deep learning, we can keep on repeating this layers into the whole network. We can put as many as layers we need. So generally it's followed this structure, but some are optional as well. Like you have a CNN layer, and then you have some max pooling layer which do some the polling operation, and there's some dropout. So there's one thing called regularization. It helps us to not our model being overfit. So that's we do. And then some batch normalizations, also one kind of an regularization operation which we apply. So this is and these are the optional last two layers we can but it's good to place them for that our model will not overfit, and these layers can keep on repeating. Finally we have a flatten layer which convert the whole this output into flat format, and then because here we have we have in the matrix format, and then we convert into flat layers, and then this flatten layers we can then finally output it to the final dense layer. Dense layer is nothing but like our regular neural network layer, and then finally the output is there. So now number of output is based on the number of classes where we need to do the prediction. If it is a multi-class classification, the number of classes based on the number of classes we are going to classify, or if it is binary, only two. If it is a regression, like one. Okay. Now one more special neural network called LSTM, long short-term memory for text classification, which I'm going to show you. So you can also read about it. It's one of the complex network into one of the advanced network for learning into the kind of an it's one of kind of a recurrent neural network category. Okay, so another one which I'm going to show the example, we can do the combination as well. We can do the fusion of CNN and the LSTM, and then we can keep placing like first CNN layers and then LSTM and then product and output. So it's not a thumb rule how you can design your neural network. It's based on you how you need to design it. You can follow some basic thumb rules, but it's based on your problem. You can start doing experimentation around but before starting your experiment, your number of layers should be fixed. and then what you need to place, you need to know. So that's one kind of an hyperparameter, you can say. And then once you design a network, you can you can train your neural network on the data, and then it will provide the output. Based on your output and prediction, you can keep on changing the layer, remove the layer, adding the layer. Based on your compute power, you can do that. So these are the reference links which you can go through it. So let me jump into the demo part. Here I'm going to use one of the data from Consumer Financial Protection Bureau. So here actually the customers or consumers can log their request or their tickets, and then this tickets can belong to multiple financial categories, and this data is publicly available and it's free. I took it from a Kaggle. And then some of the important libraries which we need to take. There are some NLTK libraries from NLTK we can use for natural language processing. Some libraries are from the scikit-learn. And then what we done first, which I told about, first we need to explore the data. Like I just loaded this consumer complaint. There are many columns, but we are not interested in all the columns. We are interested in few columns, and then we are actually exploring it. So just for a time constraint, we are exploring and understanding the text first, what exactly text is talking about. And then what we are doing here, we are removing all the stop words. We are removing yeah, we are removing all the special characters, we are removing all the symbols and lowering down the text. All these things which we are doing a stemming lemmatization operation, and all these things we are doing. Then if text is much more cleaner, then we can finally do the experimentation. So the classical experimentation is just like dividing the data into train and test, and then like this is one of the which I told. Our classical machine learning, we applied TF-IDF to convert the text into numeric, and then applied some logistic regression is one, and then finally we predict our output. But in the case of a neural network, like the one neural network which I'm going to show you about is the MLP, multi-layer perceptron. So here you can place your network layers, and you can decide what kind of neurons. But the input layer and output layer has a fixed neurons. Like suppose there's a 10 categories, so my last layer has a 10 neurons. So this is the one of the network which we designed, which I shown you in the image. And then we need to train this neural network, and then you can see like how I am checking, like how the accuracy is going, how is the validation accuracy is going, and then how is the loss. So all this we can monitor and keep training our neural network till we don't get a desired output. And another one which I'm going to show you about, the one where we can do so all these operations. And then same, we divide the text into train and test, and then here we are using a convolutional 1D network. So here actually for deep learning, especially for neural network, we are using the kind of an TensorFlow behind the scene framework, but on top of that we are using a Keras framework. Keras uses the TensorFlow behind the scene. It helps us to create the neural network. It helps us to create all the things which we can do with the neural network. So this is some important libraries which we are using. We are converting the text, and then here one important thing is that one thing you can either learn from your text by yourself by creating the word embedding. Another thing is we can use a pre-trained word embedding. So there are some pre-trained embeddings created by the Google Stanford research group. Just like this is the one glow embedding, word embedding. So you can directly use that. Directly download that word embeddings, and then you can directly apply this word embeddings on your text, so that it will already trained on the big corpus of Wikipedia. So you don't need to retrain on your text. You can easily make use of it directly. And then here you are creating the neural network with CNN. Like you can see, like first is embedding layer, like a word embeddings we are using here. Like here we are using a pre-trained from the Stanford Glow, and then we are using some dropout, convolutional, max pooling, batch normalization, all the layers we are doing, and then the flattened, dense, and then we can play around these parameters, and then we are actually training our neural network around it. Same like this LSTM. So we have an LSTM. After embedding, you have just placed LSTM, and then finally some mandatory layers here, and then it has been this network is in place, and then we trained on our data. And then another is the fusion one, which is a combination of the CNN and LSTM, which is I just been created here, and then we can train around it, and we can keep monitoring what's the loss function going on, what's the validation, what's an accuracy is coming out of it, and then based on that we can apply predictions around it. Yeah, that's something about this session. And then just to wrap up the session, we discuss about the NLP, we discuss about the neural network, the advantage of that, some type of neural network I shown, and then you can read and then experiment some other neural network as well. Yeah, that's it from my side, and the back to Yvonne.
Thank you, Kundan, for such interesting topic. You can stay with us or just join a Q&A session. So thank you once again, and see you on Q&A session.
Thanks a lot. Thanks, everyone.
So everyone, if you have any question, please ask in chat. Q&A session will be at the end of the block. And meanwhile, we continue with our next speaker, and welcome Sergio.
Hi.
Hi, Sergio. How are you doing today?
Good. How are you?
Nice, thank you. So Sergio works for Imply. His current position is Senior Developer Advocate. Yep.
Correct.
Yeah, Sergio will continue with topic Kafka plus Druid, immediate intelligence. Sergio, could you please tell us a few words about your experience and share with our audience?
Sure, certainly. I'm just trying to share my screen here.
Yep.
To get ready. But yeah, so I my experience is in data warehousing. I worked for Teradata for about 16 years, and I did professional services, so implementation of data warehouses. I worked in engineering, doing high availability, and since Teradata, I've been in. This is my third startup in the analytics space, and so I'm now all about real-time analytics, and that's what we're going to talk about.
Okay, thank you for being with us. Yes, and brief announcement. Just if you are while you are sharing your posts on social media, just use Geekle Data Science hashtag. Follow us, and at the time, Sergio, floor is yours.
Perfect. Thank you. So again, I'm Sergio Ferragut, the developer advocate for Imply. My job is the open source project, Apache Druid specifically. It's about teaching about its existence, about what it's good for, and how it works. And one of the other open source projects which it integrates really well with is Kafka. So in order to establish real-time analytics for modern analytic applications, the combination of Kafka and Druid is a powerful one, and that's what we're going to talk about today. So we'll get into Apache Druid, what its use cases are, what's its architecture, and what makes it so fast, why it's good for interactive analytics, both for historical data and real-time data. And then we'll get into how it integrates with Kafka to produce that real-time streaming and analytics at any scale. And then I'll leave you with a few more things to learn. And I think we'll have time for a bit of a demo on ingestion from Kafka. So Apache Druid, what is it? It's a database, first of all, right? It's a database that's meant to be a high-performance database. Its requirements were originally to provide an interactive experience, both on petabytes of historic data as well as large volumes of streaming data, all concurrently. So very low latency queries, distributed query execution to be able to deal with scale, and very high throughput ingestion were part of its main characteristics. Like I said, real-time data. So it's not just about being able to process large volumes of data efficiently and do quick queries. It's also about receiving data in real time and being able to compare it to to historic data, and the kind of analytics it does, counting, ranking, statistics, typical OLAP kind of measurements across n dimensions, and being able to slice and dice the data that way. And finally, it had to be a database. So high availability is important to Apache Druid, which required the data to be sharded, replicated, partitioned for performance reasons. It was decided that it would use a columnar structure, and it has its own data structure, which we'll look into and see how it automatically indexes and compresses everything to enable this really quick response time experience. A little bit about the open source project. It's a very successful open source project, but we're always looking for more people, and that is a part of my job, is recruiting committers and well, not just committers, people who want to participate in the project, either as committers or even just as to report bugs or report new functionality requests. All of those are community members. Out of those, there are 400 active committers. It's an active project with over 1,000 in production implementations. So what does it do? It creates this experience. This is an example of what we call a real-time analytics application, right? A modern analytics application. This is a product that the company I work for sells. It's an implied pivot. But the point here is this is a visualization tool, right? Like many other visualization tools like Tableau or other tools that allow you to slice and dice the data across different dimensions, filter it interactively. But what I like to point out about this in particular is that what we're trying to show here is the database behind it, not necessarily the user interface. And in order to show the database, these videos are not really accelerated. They're actually in real time. These are actual user interactions, dragging dimensions into the chart and changing the visualization by slicing and dicing or filtering the data. And with this response time over billions of rows of data, right? So the idea is fast response times on queries that are on large volumes of data, on fresh data, so on the data that's inbound in real time. Enabling high concurrency, so lots of users interacting with this data, and creating this highly interactive experience. So this is what it's about, right? This is what the Druid primary use case is about. It's about creating such experiences. It's being used in many industry or many different sectors. In risk and fraud, it's used to analyze spending profiles as an example over history, and then do comparisons of those spending profiles to, as an example, individual credit card transactions to figure out whether one of these may be at risk or potentially fraudulent, and doing that really quickly at very high volumes. Data-driven applications. These are applications like mobile games or mobile apps that produce a lot of data, that produce data about the use of the apps, and that the developers, for example, can use to analyze how individual groups of users interact differently with the application, and then maybe even shape the behavior of the application based on what you've seen historically, what you want to achieve with those users, and be able to interactively change the behavior of the application based on the analytics that you're doing in real time. Network performance, this is all about reliability, right? It's about network infrastructure and understanding what events are occurring with them, what kind of traffic. So it's individual packets and their traversal through the networks, and understanding the aggregate level traffic patterns and so forth that allow you to detect security issues or potentially failures in equipment, and be able to address them such that you're keeping a service up and running at high availability. Clickstream data is about understanding individual sessions and what's occurring in the individual sessions, each of the clicks, each of the events within applications or sessions, and being able to, again, not just understand the history of those clickstream patterns and be able to analyze and classify different behaviors, but also be able to interact with now, what's occurring right now on an application across sessions or with individual sessions, such that you can use those analytics to shape the behavior. There's many more. I'm not going to go through all of them now because we want to get to the how-to or the how this works. So let me start talking a little bit about how this works. This is the architecture diagram for the high-level architecture diagram for Druid. So I'm going to describe it in terms of three different processes that are scalable and resilient. Right? One is data ingestion, the other one's data management, and the other one's query. So in the data ingestion, if we look on the right side, we have this idea of both streaming data and batch data, and we can do it at scale. So the indexer jobs that are in these data servers and that can scale horizontally as much as you want. We haven't hit a limit yet. These indexer processes are either processing large volumes of data in batch and generating segment data from them. This is these little yellow squares that you see all over the place. So they generate this segment data that is the columnar optimized index format, and those are stored in deep storage, and we'll get to that later. But through the ingestion process, either high throughput batch or high throughput streaming, which is a live indexer tasks connecting to partitions in some streaming engine, like we'll talk about Kafka in a second, that produce highly scalable streaming live. They keep that data in memory so that the in-memory data is queryable while they're building these segment files that get produced periodically and pushed to deep storage. So that's the ingestion side of it, right? And it provides high throughput, high volume ingestion, and very scalable ingestion, both for streaming and batch. And so it ends up producing these segment files that are pushed to deep storage. Deep storage is an external dependency of Apache Druid. It can be S3, it can be HDFS, any distributed storage that is reliable, right? It's meant to be a resilient storage mechanism. In the background, there's also the coordinator process. This coordinator process understands all of the data that's been loaded into an environment. So all of these segment files that have been created, and it distributes them with replication for high availability across the historical processes, which are these other processes running also scalably across the data servers. And it distributes them with multiple purposes, right? It distributes copies to different historicals for high availability. It distributes copies to different historicals for parallelism, and it evens out the distribution of the data across all historicals in the environment. And it does this continuously. So if you grow the number of historicals, it redistributes automatically. And what does this give us? This gives us the pre-cache. So these are these segment files that are stored locally on the historical processes, giving them a quick access rather than having to access them from like deep storage or S3, for example. You're accessing them locally because they've been pre-cached into the local storage, which could be SSD, and they're even mapped into memory. And depending on the memory to storage ratio that you're using, you could have a lot of it cached in memory. So in the end, what you get before we start with the query, we've ingested data, we've distributed across the older data that's not in the now, has been distributed across the historicals. The now data, what's being streaming right now, is being kept in memory in the indexers, and it's in that state that the queries come in, right? The queries come in through the query server, which is also scalable itself. And the broker processes SQL requests or processes native JSON query requests. It understands where the different pieces of data are, whether they're in memory in the indexers because they represent the last hour or the last 30 minutes, whatever it's been configured to, or it represents data from further back that's already been pushed out to the historicals, and therefore is that portion of the query is distributed to the historicals. So multiple tasks go out to historicals, go out to the indexers to resolve portions of the query in parallel. And the queries there each respond with their subset of the results back to the broker, which then sends the results back to the user after doing final aggregations. But that's the high level architecture. I'll check on questions toward the end here once I get there. I don't know if there's any questions yet, but anyway, I'll check in a second. So then we have this architecture. It's highly parallelized, highly scalable. It can grow both in ingestion and in query capacity. But it's also important that what each of those do when they're processing a query be an efficient process, right? So that we are capable of using very little CPU to resolve these things and therefore allow for higher concurrency. So it uses a few different strategies in the data storage mechanism to drive this. One is data compression. This is the idea that data is not stored in its original values. It's stored in an encoded form. So you see them encoded values stored. It's stored in columns rather than in rows, because that's more efficient for analytic queries where you don't have to access all columns. You just access the columns that you need to. It's all pre-indexed. That means all of the dimensions have two different strategies of indexing that we'll get into in a second. And they all have a unique dictionary. What this means is that for each column, we'll have a dictionary that encodes the distinct values of the column into numeric values, which are then stored in the data. And finally, it uses late materialization. This means that when it's processing the data and processing the queries, it's processing them in terms of the encoded data. So the zeros, ones, and twos, not the Melbourne, Perth, and Sydney. And once it completes the calculations in the compressed form, then it uses the dictionary to convert the results. If you've grouped by that column, it only grabs the values. If you have 0 and 2, it grabs those values from the dictionary, produces the results set back to the user. So let's see how that works in real life, right? This is an example of a segment file where we have really just two-dimension columns, artist and city. We have time, so this Druid uses event data, and so there's always a time column involved in the events that it records, and that's how it segments the timeline into time buckets, right? And that's the first level of partitioning that it does. So there will always be a time column. We'll have one of these sets of data, dictionary, and indexing for each of the dimensions, and then we'll have the metrics, right? In this case, we're talking about sales of tickets at different venues in different cities for different artists, and what the price was and the total count of tickets for that particular time frame. So in this simple case, let's see how it gets used, right? Let's do a simple query. If we're doing a group by the total sales for a given artist, what's going to happen is it uses the artist column. So it uses the dictionary that's been pre-sorted and stored in this segment file to determine which value, which encoded value, and which position within the index includes ACDC. So it finds it at the first position. With that, it knows that at the first position of the index, it can determine which row IDs, so there's 0, 1, 2 are the row IDs in which it is present, or it can use these bitmap indexes that have a bit for each row, representing the presence of the value within those rows. The bitmaps become really interesting with complex where clauses, because then you can do things like if artist in a couple of values, you can just do or bitwise ors of multiple index values to quickly find the set of rows that are interesting for the query. But anyway, we figure out which rows are interesting, and then we access the other columns that we need, only the other columns that we need, and only the rows within those columns that we've already filtered on. So it very quickly finds which rows it needs to produce this query. It does the calculation at that level, and finally does the materialization. So in this mechanism, it's interesting to point out that there was no scanning of all of the data, right? We used dictionaries, we used indexes to access this data set. If you have absolutely nothing in the where clause, then yeah, you'll have to scan the segment, but it's still an efficient mechanism to scan the individual columns and be able to do fast aggregations. So now you see these little yellow things that with columns are those files that we just walked through. And you can see how the historicals and the indexers can process portions of the query really quickly to produce those results and do it scalably based on the horizontal scalability of this platform. So that's Druid. Let me see how I'm doing with time. Okay, I'm still doing pretty good. Let's talk a little bit about Kafka integration, how Kafka comes into play with this architecture. So in the world of Kafka, it's about you get higher volumes of throughput of event messages by having more brokers, right? So in the Kafka cluster, you have more brokers, and within each broker, each topic of events is partitioned and potentially partitioned into multiple partitions in each broker. This allows us to use the parallelism of the CPUs and the memory in each of the broker servers to be able to increase throughput essentially infinitely, right, with Kafka. So there's a set of producers communicating to Kafka and producing this massive amount of data, right, or whatever volume you actually need, right? You size it, you create the number of partitions based on the needs of each topic and how many events per second you're processing. We've configured it to millions per second, but that's not a limit, right? It's just one of the larger tests that we've done. So Kafka has this capability of processing and streaming large volumes of data. Druid also hooks up to Kafka in the same way, in that it can have n number of tasks. The maximum number of tasks that can be used for a given ingestion for a given topic is the number of partitions in that topic, because that's the minimum granularity that we can use, right? Kafka will subdivide the data into partitions, and we can have a task reading a partition or reading more than one partition. So at the maximum configuration in Druid, you'll have the same number of tasks as you do partitions in this data flow. It's not necessarily what you need. It depends on the volume of the size of the events, the volume of the events. You may need less tasks than partitions. But the point is, you can parallelize this as much as you want, and therefore scale it as much as you want to deal with any level of throughput. Something to notice is that what we talked about is the indexers. Each of the tasks, whether they're reading from one or more partitions, is producing one of these segment files every X period of time. Right? And so that's how it works. I'm pushing those to deep storage. Now, from the query perspective on the Druid side, what happens is that the parallelism of the real-time queries is completely attached to the number of tasks, right? So that controls the number of parallel tasks that are dealing with the now on a particular topic of data, right? Or a particular table of data where you're ingesting that data. So application queries that are only requesting data from, the most recent, let's say if you're doing it every 30 minutes, from the most recent 30 minutes, will go directly to the in-memory tasks and indexers, partition the query into as many tasks as there are, and produce a result through the brokers back to the application. Now, not all queries are just real time. They have a portion of real time that's taking advantage of this highly parallel indexer tasks to process that part of the query, but portions of the query may already be in the past, right? Past that 30 minutes or past that, maybe it's a week before, or whatever the time frames in the query are. So the broker will partition the query into the real time portion, talking to the indexers that are consuming the data right now, and also to the historicals, and produce the overall result of the query back to the application. So I mean, that's the overall architecture and how it scales. Just as some recommendations that are also important in Druid is because you have two counter objectives when ingesting data from a Druid perspective. One is this parallelism, right? We want it to be parallel enough to deal with the throughput that's coming through Kafka. So that's where we have a T number of tasks here, and it could be a large number of tasks. And each task produces one segment for a particular time frame, right? We're seeing here the 9:15 to 9:30 if we're doing it every 15 minutes. And as it produces these, they're smaller segments than you might want. So there's a compaction process, and it can be configured automatically to occur with a delay. In this case, it has a delay of 15 minutes. So 15 minutes after the now, it begins to process the previous set of segments and reduce the number of segments that were useful in ingestion to be such parallel, but are going to be more useful compressed to a more efficient form in the historicals, and that's what the compaction process does. A few other things about the pipeline and how it can be used to enhance event data in order to bring it in to Apache Druid. Maybe you're adding more dimensions, you're adding demographic data, you're adding other data to the data set to be able to query more richly with more dimensional data, maybe even more metrics. So one of the ways of doing this is by using Kafka SQL that allows you to query to do live streams of joins and queries and transformations that are reading from some topics and writing to others, and therefore transforming the data as it moves, and enabling potentially the ingestion in this case from topic C, while topic A and B are used to combine and generate the data that's actually being exposed for analytics. So this is one option. Another option that we see a lot of implementations of are using Beam or Apache Spark or Flink to process the live streaming in different ways and enhance the data in different ways. But in many cases, we see that same pattern where you're maybe reading from multiple topics, maybe other external sources, combining them and feeding them back into a Kafka topic that then uses the parallel ingestion in Apache Druid to enable the interactive analytics. Also, there's a PyDruid, for example, a library for Apache Spark that allows you to directly load enhanced messages into Druid without having to come back through Kafka. Anyway, these are options in how the pipelines can be configured to use this. So at this point, I'll do a little, I have time for a little demo. Let me jump over to my demo and tell you what it's about. So this is the Apache Druid console, right? And what I've set up here is, well, this is all on my laptop, so, performance is not really the thing I'm trying to show you here. It's more about the functionality. So I have Apache Druid running on my laptop. I have Kafka running on my laptop, and I've created a topic where I've pushed some data into it. And what I'm going to show you is what it takes to actually load data from a topic, right? And it's actually pretty simple. So you can you select Kafka as a source, connect the data. All you really need is the brokers. In this case, it's all local. The topic I have is Wikipedia data. And I could just do apply. And it just read from the topic, brought the data structures from it. It supports messages in JSON. This is messages in JSON, also delimited formats. I believe it also supports Avro, and there's another one, Protobuf. So there's a bunch of different formats of messages that it supports. But this is the simple. Actually, this is part of the tutorial that I'll point you at in a moment. But so it reads it, and then you can just go through the steps. You'll see that it parses it automatically into columns. And it maps, well, it decides what format it is, but you can change that here. I'm not going to go through all the details, but it assigns a time column. Remember, the time column is an important aspect of Druid ingestion. It's separating stuff into time, so you'll need to assign a time column. You can transform columns, so you can take columns, create new expressions, and add more. You can add filters to the stuff that you're ingesting. And finally configure the schema in terms of whether you want to do aggregation. So that's what's roll up. You can aggregate, let's say these are events that have up to the millisecond in their timestamps. Maybe you want to aggregate it by second or by minute, and therefore create metrics by minute. And that's what roll up would be for. You can partition decide how many partitions you want. Maybe you're partitioning by hour. So this means you'll have a segment of data, at least one segment of data per hour for the day. You may do it by day, so you have a segment per day. That depends on the level of messaging that you have, right? What you're targeting is segments of a particular size of about 5 million rows. And if you can align those to, each hour I get about 5 million rows, that is sort of the ideal case, or, each day I get 5 million rows. So you want to aggregate the segments as much as you can without being too large. And 5 million rows is a good setting for that. So anyway, after setting the granularity, you can tune a bunch of parameters of how it runs, how often it ends. It's set up to 1 hour here. I'm not going to go into all the parameters here, but you can tune it and finally publish it. I'm not going to publish it right now because I did that before, and it takes a few minutes. But what a published process looks like is like this, right? This is a running ingestion. So it's that same sequence I just went through. I just had it running from before. And it leaves tasks that are long running, right? This is a supervisor task, which is in charge of creating the individual tasks that read from the partitions. In this case, it's very small, so we have a single task reading from a single partition, but this could be as many tasks as you want across a cluster of ingesters. So anyway, we see it running here, and just to give you the final bit of the demo, if I run the query right here, I'll just point to these counts. This is sorted by count, so we'll get the highest first. There's 1,056 events for the United States, 70,000 for no country. But what I wanted to show you, just so you see that it actually is live, so I'm going to throw another set of events at it through Kafka, and this is just using the console producer in Kafka. By the way, this whole setup is in the tutorials that I'll point you at, that is part of the Apache Druid open source project. So I'll point you at that data so you can do this yourself. So I set another bunch of events. As soon as I requery, we should see more data, right? So this is just to show you that it is fully connected, right? I add more data, and it's the analytics are readily available as the new data is coming in, and it really is that level of real time at any scale. So with that, let me get back to the deck. Where did I leave the deck? It's over here. And I'll point you at a few other things. The website, right? This is if you're interested in more use cases and how other people are using this, both in data science and in just straight OLAP analytics, there's cases for all of those in their powered by page in the druid.apache.org website. There's also the Druid forum. This is druidforum.org, where we have Q&A environment with the whole community chipping in with both questions and answers. It's a very active place and a very friendly place for people to get going and to help each other out in how to implement Apache Druid. There's the website itself where you can download the software. You can look at the documentation with the tutorials, with the tutorial that I just went through. The demo is part of the tutorials, and there's a bunch of other tutorials about how to do other stuff. There's the project itself on GitHub, the Apache Druid project, where we're always looking for more people to be involved, for more forks, for more PRs, to improve documentation, to improve the software itself, to get new requests for functionality and so forth. So we welcome all participation there. Our company's blogs, we have company blogs, engineering blogs from the engineering team as they're adding new functionality to Druid. And the community blog, which is blogs that come from the whole community and that we help curate and publish on our site. This one's one I want to point out specifically because it's free right now. There's Apache Druid Basics and Apache Druid Ingestion and Data Modeling courses. All you need to do is go to learn.imply.io to get more information and to go through the free training courses. They're pretty good. And this is a bunch of ways of communicating with us. Email, the Druid forum, the ones that I mentioned before. And I'd really encourage you to do the learn.imply.io if you're interested in understanding more. So with that, I believe I can open it up for questions for a little bit of time. If you guys have any questions, let me.
Thank you, Sergio. Yes, thank you for your great and fantastic demo. So yes, we have a few questions directed to you.
Let me see.
Yeah.
Is this in the chat?
Yeah.
Oh, there we go. Do you come up with the idea to utilize real-time databases from the very start, or it can be integrated in later stages with too much headache? Well, I guess it depends on what you're doing, right? What your objectives are, right? As a startup, if part of the functionality that you're trying to provide to your end users is this highly interactive experience, you can start batch. We have lots of customers that are using batch, not really real time, not the real time portion, but just the batch portion, because it provides that interactivity, right? Even if it's all on historical data or all up to yesterday and you do batches on a daily basis, it still provides that interactivity, that really quick response time and navigation across dimensions, which is quite useful by itself. So you can start without the real time, provide the functionality maybe on a batch basis, and then plug in the real time to get the same kind of analytics in the most recent data in the now, right? So it really depends on your use case, whether the now, the analytics of what's occurring right now is more important or not. I hope that answers.
Okay, and we have one more question.
Are these dictionaries stored somewhere in the Kafka Zookeeper? They're actually stored in the segment files themselves, right? Well, they're stored in two places, right? As the ingestion is going on, if it's a real-time ingestion, the dictionaries are built in memory and stored in memory as part of the in-memory processing that the indexers do. But as the segments are built, each of the dictionaries for each of the columns within that subset of the time frame that represents that segment of data is all embedded inside each segment file. So each segment file has all the metadata that it needs in terms of what columns are there, what data cardinality exists, and what distinct dictionaries exist for each of the columns. Hope that answers the question.
Yep. Okay, thank you for answering this question, and we will meet soon on the Q&A session as well. Thank you. See you.
Cool.
Sorry. So hi guys, as we are waiting for next speaker, I would like to make announcement next data science event in November. I will be happy to reconnect with you from 22nd to 24 November. And it will be also 3 days Data Science Global Summit. And I hope to see all attendees there. After this event, we will send you a short survey, and I will be happy to hear your feedbacks and your advices, how we could be better for you. I also will be happy to reconnect with our speakers. So let's keep in touch and see you soon at November. Also, I think we have 5 minutes till second session, and we can make small break now. So hope to see everyone here for 5 minutes.
Hi everyone again. Now we are back and we are ready to continue with our next speaker. Please welcome Ankit. How are you going today? We can
Hey
hear you.
everyone.
Ah, yeah.
Yeah.
How are you doing today?
Hi Ivan. Yeah.
Okay, Ankit is the founder of @punk and will share with us the topic Let's Democratize Machine Learning Model Development. And thank you for joining us today. And could you share a couple of words about the experience with the audience?
Yeah. Hi everyone. So I graduated in around 2014, after which I worked as a data scientist in a big data analytics firm in US. So in that role, I had experience developing machine learning models, deploying it. So the entire analytics pipeline. And post which I also became a product manager, handling the various analytical products of the firm. So yeah, that's my data science experience.
Okay, thanks. And we are ready to start. So Ankit, the floor is yours.
Yeah. Hey everyone. So today's talk title is Let's Democratize Machine Learning. So in this talk, we'll see how we can democratize machine learning, both from the perspective of model development and from the perspective of model deployment. So democratizing is nothing but it is about freedom. So the freedom of choice for a developer to use the framework of choice to develop his models, and the basically deployment infrastructure of choice to deploy his models. So we'll talk about choices and how modern technologies are actually helping this process of democratizing the process of machine learning. So let's move on to, so let's start with the first concept, which is ML life cycle. So before we talk about democratization, let's talk about the life cycle. So what is a typical ML life cycle? So a typical ML life cycle starts with identifying a problem, then accessing the relevant data pertaining to that problem, basically whatever data which can help us solve that problem. So it can be either in a CSV file, it can be either a JSON, it can either be a SQL table, a NoSQL database. So wherever the data resides, the next challenging part is actually getting hold of the data and accessing it. After which we do some initial exploration. So you can use so you can use various data exploration techniques like histogram, heat maps, frequency analysis, various techniques to actually explore the data. So it just gives you a lay of the land and identify what kind of data we are dealing with. So once we explore this data, the next part is basically filtering and transforming this data into something useful to build our model. So after we go through this filtering and transformation of data, which might require removal of uh, rows, the observation, the observations which are missing values, removal of columns which are not relevant, feature engineering. So we transform this data to actually make something which can be consumed by our model. So the next stage, which we all are interested in, is actually building the model. But you have to understand that when you are working in an industry, actually more than 65% of the time is spent in in accessing the data, exploring the data, and filtering and transforming it. So after this intensive exploration, filtration, and everything, transformation, we finally get our hands on various machine learning algorithms that we can use to actually build a model. So once we build a model, we validate it through various evaluation methods like k-fold cross validation and basically ROC curves. So we use various evaluation techniques, cluster analysis for k-means modeling. So we use these various techniques to evaluate a model. And once we are satisfied that, okay, this model is giving us good results, we go ahead and export it. So this is the part where we export the models, save it into some form so that we can go ahead and deploy it in our servers, microservices, containers, edge devices. So then we go ahead and deploy these models. Finally, we monitor the results. So once you deploy the model, that's not the end. Now you need to monitor the model. So it's a continuous process. So you generate weekly dashboards, daily dashboards to monitor how your model is performing, whether the performance is degrading or whether it is performing well. Once you monitor the results, it might be that you will figure out, the entire development team will again figure out a new model or make certain modifications which they might want to test it. So then comes the thing called as managing models. So you might do A/B testing for model management, or you can straight away do a version control for model management. So then you will manage the models. And once you are managing this model, you will definitely come across some new challenges and new problems, and this cycle will continue. So this is a typical ML life cycle that we all have seen in lot of places. And in most of the talks that we hear, we always talk about model building, evaluation, and that's it. But once you have developed a great model, it's good. But what's next? So in this talk, we will delve deeper into the second half of the cycle, which is what happens once we build a model and how we can go ahead and export and deploy it. So before we begin with this deployment part, we have to also try to understand how the evolution of machine learning model deployment has happened in the past. So nowadays, so initially it all started with dedicated machines. Firms had dedicated machines where they would go ahead and deploy the model. A new data which that will get stored in the database will usually also reside with the firm, and it might be the same server or a data server, and they will run the machine learning models on that data and actually generate the results. But with the advent of cloud computing, people started deploying their models on the cloud. And basically, it was bringing the analytics closer towards the client, because earlier the data used to come to the firm and then they would have processed it. Now the data will travel to the cloud where the analytics server will reside, and there they will process it. So again, so now the data has to travel less and the model is closer to the client. Then started fog computing and edge computing, where the model is actually deployed on the device which resides with the user. So this is how the analytics is evolving. So so the billions of edge devices that we carry, all of them have machine learning models in them. Your iPhones, your Android phones, basically your Fitbit, Apple Watch, all of these devices have machine learning models embedded inside them so that users can get fast results. And there is also a lot of other factors which it contributes to, which we'll see a bit later. So today, analytics is being used, and machine learning is being used everywhere in all industrial sectors, be it transportation. For example, in transportation, a very good example is the new age automated vehicles. So basically, they have these long range radar sensor lidars, then they have cameras, and all this data is actually processed in the car itself. So the model resides in the car, because you have to be very quick while processing the data and then take quick actions. That's why the model resides in the car. And then and you can see how the total sensor data that is generated is actually 1 gbps. So it's a huge amount of data. So it is very important to deploy models at the edge. And in manufacturing, basically it heavily uses a lot of IoT and a lot of basically machines which are actually which actually have machine learning embedded in them, be it for vision learning and other stuff. So it is estimated that there are around 50 billion connected devices, and a lot of these devices, IoT devices, are being used by the industry. And another popular industry is healthcare, where they have machine learning models deployed at the edge. For example, be it your Fitbit or be it your Apple Watch, they have machine learning models which quickly analyze your heartbeat and actually identify if there is an issue and alert the relevant authorities. So these machine learning models are actually basically deployed on the edge. So coming ahead, so so now the question comes is why? Why are we deploying it on the edge? So the thing is that the Moore's law is coming to an end, and there is a need to actually develop new hardwares specific to certain problems or industrial use cases. For example, and you can see there is an explosion of hardware startups which are building custom chips for specific problems. You can see how the funding of machine learning's hardware companies have exponentially increased in the past few years. And you have a lot of custom chips like microcontrollers, TPUs in mobile phones. So you can see how billions of uh, uh, edge devices are there. So these custom chips are being developed to cater to specific problems, and that's why the machine learning is being moved to the edge. And also some of the other needs are like speed. You get a lot of speed since there is no travel of data from the user to the cloud. uh, so there is and it is on device, so you can process data at the source, and this gives your analysis a lot of speed. Also, it reduces the cost because you are not processing data on the cloud or your own infrastructure. You are saving a lot of cost because that cost is being pushed towards the device. So the user who is maintaining the device is actually buying the device, is paying for the cost of running the models. So you save a lot of cost by pushing your models to the edge. Another problem is connectivity. So a lot of times you might be in regions where you don't have good connectivity. A very good example, as you can see, is this windmill. So this windmill is basically in a remote location where you do not have internet access. So for example, in my past firm, we developed solutions where we actually deployed our predictive maintenance models on the windmill itself. So it will be once any part of the windmill requires some maintenance, it will automatically trigger. And for example, these parts are usually it takes a lot of expense to actually go ahead and replace them. So for example, if some part fails and there is a chance to actually for another part to fail, so the predictive maintenance models will predict that, and it will save company a lot of money, because now they can go ahead and replace both the parts in the same go. And since it is also offline, so it helps to actually deploy the model there itself. And also a very major concern is privacy and security. So nowadays users are concerned about their data storage and data usage. So that's why the models which are deployed as the edge ensure that there is privacy and no data is transferred to and only the basically only the final results are transferred, and no raw data or secure private data is transferred to the firm. So it also helps in privacy and security. So now that we know why, the evolution of edge devices, how machine learning development and deployment is happening. So now comes the great challenge, that how can we democratize model development? So suppose you are working for a firm and you have developed a model. you go ahead and tell them that, okay, please deploy my model. But that is not easy, because firms usually have a production server, and as developers, for example, a data science team of company X might contain people, some people who are good with TensorFlow, some people might be good with Keras, PyTorch, a person might be expert in R, S2O AI, someone might be expert with Java libraries. So based on this skill set, these people might develop model in the framework of their choosing. And once they develop the model, they cannot simply export it and tell that, okay, deploy it on the server, because these production servers are usually handled by the IT team, and there is a clear mandate, as in what are the frameworks that can be deployed, basically mandate, company wide mandate, that okay, these are the frameworks that we have tested for security vulnerability, we can use them. So there is a lot of rules that comes into the picture, and you cannot like build a model in R, export it and say that, okay, go ahead and deploy my model. Also, that model might be a very small part of the entire application, so which might be a monolith, and this model might not the framework that you might use to export the model might not be compatible with the monolith that is already deployed. So this creates a lot of challenge, as in and it curbs the freedom of developers to actually use the framework of their choice. So usually firms tell that, okay, this is the framework that you can use, and this creates a lot of challenge. So that's why it is very important to understand that basically you can see this meme over here. So in lot of talks you will hear that, okay, go ahead and containerize it, and orchestrate. So in lot of conferences you will hear these terms, but the thing is that it's not that easy. Typically for 90% of the firm, it's not that easy, because these skills require these basically deployment infrastructure requires people with skills, which companies might not have access to. So there are multiple ways in which you can deploy a model. Yeah, it can be a part of a monolith server, which is an existing server. You can deploy microservices or containers, or there is and also one more thing which is popular nowadays is serverless, where the deployment infrastructure scales based on the usage of the client. So you can, a lot of deployment options are there, but often this deployment is it is not up to the developer, it is up to the management, and it is up to the firm to actually decide that what is the deployment infrastructure they will going to use. And if, for example, if someone tries out microservices or containers, traditional IT ops people might not be able to support it. So that's why, because not everybody has the basically capability or bandwidth like Netflix, which deploys its entire infrastructure on microservices, and they have special teams which build in testing infrastructure for microservices, and they have invested a lot of time and money to actually develop these processes. So not all firms will be capable of doing that. So that's why the question arises. So what can we do to democratize this choice of using the framework for a developer? So, so this model deployment is actually democratizing it is actually a myth, because a lot of time it is not in your hands. It's in at the hands of the firm. But model development is a possibility. So you can actually go ahead and use the framework of your choice by just having a model interchange format in between. So in this kind of setup, once the analytical models are created by the members of the team, you just go ahead and export it in a format which is an open standard, which actually which has been which can be easily deployed on the server. So you might export a R model into a open standard format, a data model exchange format, which can be easily read by the runtime on the server, and it can be executed. Similarly, Spark MLlib model or TensorFlow model can be exported in such a model format. Basically, you are exporting the model in a format which is compatible with just a single runtime on the server. So basically, so now the developers have the freedom to choose the framework of their choice. All they need to do is export the model in the open standard. So the thing is, so now next comes into the picture is how you can actually do that. How can you save and share the model? So let's begin with the basics. So we all share data. And what is the most popular format of sharing data? It is actually CSV files. So CSV files is are very popular when we want to share data. Then we have XML format, we have JSON, we have YAML. So we have these formats which also allow us to embed hierarchy in the data set. So these data exchange formats help us in actually transferring my data to another person's data without any corruption. So the data which I export can be easily read by someone in a form using in their machine, as it is an open standard. It's an open format which has certain specification that okay, CSV file, each row has to be delimited, and they have to be code characters have to be the, excuse me. So this data exchange format helps us in transferring data. Similarly, for code objects and data structures, for example, code objects can be functions, data structures can be data structures like dictionary, maps. So usually what we do, we use programming languages built-in serialization. For example, in Python, there is Pickle. In Java, there is Java serialization. In Ruby, there is Marshall. In R, there is RDS, RDA. So we can use these formats to actually exchange and serialize data structures and code objects. Now, the advantage is that it supports various data types like you have maps and you have dictionaries and all. But the disadvantage is that it can be malicious as it is not human readable, and also there is a language locking. For example, the pickle file that I create cannot be read by Java or R. It can be only read by a Python interpreter. So you are locked by the language. So with the advent of big data, uh, for data, the standards evolved. They came up with new standards, new serialization formats that could provide efficient cross-language serialization of data using schema, which are efficient, language neutral, platform neutral, highly compressible, like protobuf, arrow, SDF5. So for data, we evolved the standards, but for machine learning, no such thing happened for quite some time. So if, for example, I use scikit-learn, I used to export a pickle file or a joblib file, the save the model as a pickle or joblib file. For Keras, I used to save it as a SDF5. Then for TensorFlow, I used to save the model as a saved model form or a flat buffer file like TFLite. Uh, in similarly for other frameworks, you have other such proprietary standards of serializing the models and saving it. Basically the problem with it is like if the framework is discontinued, so is the problem that arises of actually going back to your model or reading your model or supporting your model. For example, Theano, Cafe2, Keras, these are no longer there. These frameworks are no longer there. They have been discontinued. So it will be very hard to actually support the models that were developed as these frameworks are no longer being developed. So this created a lot of issues because each one was pushing his own. Each company was trying to push or his own format, and this was creating a lot of issues. So then people said that okay, let us develop some standards, and get together, agree upon certain ways in which we can export a model and do that. So the thing about standards is that as you can see with in the XKCD comic, so if there are certain number of competing standards, a person can come in and say that okay, let's create one universal standard. But what happens is actually now this is also competing with the rest, and you have 15 competing standards. So and you will see it in real life in later in this talk how it happens. So so what are some of the modern interchange formats that allows us to for to interoperate the machine learning models? You can see some of the open standards on which people can go ahead and read it, contribute to it is PMML, then PFA, NNEF, Onyx. So these are some of the open standards that anybody can go ahead and contribute to, understand, implement it, and basically add support to it. Then there are some other formats like MLflow and MLlib, which are proprietary, and that's why, and there are no specification. So again, we will not delve into these formats because then there is no openness about these formats, and it's not open source. Specification is not open source, so it is very hard to actually go ahead and add support to such formats. So let's start with the first one, which is PMML. So PMML was introduced in 1998 by Data Mining Group. So it was initially a leading open standard for deploying statistical and data mining models. So what you can do is basically you can use R, scikit-learn, S2AI, XGBoost to actually develop your model. Then there are APIs which or libraries which can help you export these models. So for example, in Python, you have Neoka, then in R, you have PMML library. Then in Java, you have PMML library. So these libraries will help you export these models into a PMML file. And this PMML file can be then read by the runtime on the server, which can be Android, Nime, RapidMiner, SAS, Spark. It can be any basically environment where you can just read the PMML file and go ahead and execute the model and score a new data set on that model. So this model interchange format was in XML. It was shorter, low overhead, and it had low complexity. Then you could reproduce the results completely, and you basically. But the issue with this PMML format was that it could only support standard defined models. So the only standard models were supported, which was quite less as machine learning as a field was evolving rapidly. And also data processing is a very important part. And this data processing was not covered in this PMML specification. So this was a major challenge. So then around 2015, DMG said that, okay, they will improve PMML, and they came up with a new format, which is PFA, which is portable format for analytics. So this format allowed portability across systems with algorithmic flexibility. So you can export models, you can export pre-processing, post-processing, and all the basically these things you can export as functions, which can be composed, chained, or built into complex workflows. Now, something as simple as raw data transformation or as sophisticated as a suite of analytic process or workflow can be described as a JSON or YAML file as per the PFA format, and using the Avro schemas for the data types. So this tried to overcome all the disadvantages of PMML. So basically you can use Titus 2 or Aurelius, which is in R. These were the sample implementations that were done, Python and R. So you could export models as PFA, and then you can go ahead and deploy the models in server using Python, or you can also use JVM to deploy your models and score on new data set. So basically so the current implementation available is very small because a lot of and it did not get a lot of wider acceptance. This was a major issue with PFA that uh, it did not. So the legacy firms which were using PMML stuck with it, and PFA did not allow the new age models like deep learning models. So that's why there was not a wider acceptance of it. As you can see that I've also worked with PFA in the past. You can check out this link to read more about PFA, how it works, what are the function that it supports. And Titus, I actually ported the entire Python to PFA library to Python 3, and it's called Titus 2. So the whole issue with PFA was that companies did not accept it as widely as they did for PMML, because it did not contain fra- uh, support for new age deep learning models. So then came Onyx into the picture. So Onyx is actively, it was launched in 2017, and it is being actively developed by Facebook, Microsoft, and Amazon. So a lot of new age firms which actually deal with deep learning and big data, they decided to come together and work on Onyx. So it was an open neural network exchange format, and it was also incubated under Linux Foundation, so under the AIN data program. So it was incubated there. So it was open source specification. A lot of companies came together and they contributed to it, and they developed the specification further, and it is an ongoing process that is happening. And you can see it supports a lot of modern frameworks. Like you can export models from starting from scikit-learn to actually TensorFlow, libsvm, chain, cat boost. You can see a lot of frameworks are being supported. So these frameworks actually have tools built in or third party libraries available, which can export the models developed in these frameworks into a Onyx format and Onyx file. And this file can be shared, and it can be plugged in into another framework for inferencing, or it can be even plugged into specific hardwares. You can see a lot of hardware companies have also joined this program to actually process these Onyx models and deploy it on their hardware edge devices. So it was an open source specification that provided a common representation of the computational graphs. So neural networks are basically graphs. So and usually these and all the frameworks, they have proprietary graphs. So this under this specification, they came up with a specification and a common representation of these graphs, and it was primarily built to share neural network models. But a project like Onyx ML was also developed later on, which includes additional types and standard operators that are commonly used in classical machine learning algorithms. So you can clearly see that it is a clear cut neo age exchange format, which takes over the legacy PMML format. And how it happens is basically deep learning with neural networks is actually accomplished through computation over data flow graphs. Now if you take tools like cafe2, cntk, theano, tensorflow, they use static graphs, while pytorch and chainer use dynamic graphs. Now since these frameworks are like, they have their own proprietary representation of graphs, what will happen is if you develop a model in TensorFlow and export it, then you will require an TensorFlow installation or runtime installation in your edge device or your deployment device. So this kind of locks your stack. So now for each framework you export, you have to develop, for example, you have to develop n libraries to export the models. You have to also develop n libraries to actually go ahead and import it in various vendor numeric libraries. and this will create n square pairs of like libraries that has to be maintained, which is a lot of work. And also it will lead to a lot of issues since there is no standard, and it is and a lot of these things are kind of proprietary. So with Onyx, there's a format which defines a extensible computational graph model, operator, and standard data types, which provides a common intermediate representation. So now the models can be represented in a common format, which helps developers to actually choose the right framework for their task, whatever framework they are comfortable with, or whatever framework that they know can be easily useful to develop their model. They can go ahead and choose their framework of choice, export the model, and then basically the vendors will actually just develop libraries to support to run Onyx models. And it will be a very simple process, and it will bring down the complexity of development of libraries. And it kind of democratizes AI, as developers can select the framework that works the best for the project at any stage, be it development or deployment. So they can choose the framework of their choice for either development or deployment. So you can see how there's a common format, common layer in between. Frameworks can export Onyx files, and these Onyx files can be deployed on any edge device or server or any deployment server of choice. Similarly, another such framework which came a bit later was NNEF. It came around 2018. It was similar to Onyx, but actually it kind of positioned itself as uh, embedded inferencing input, and Onyx whereas training interchange. But if you go ahead and look into Onyx and NNEF, both of them are basically more or less same. But the issue is that NNEF did not get a wider acceptance because Onyx was supported by some of the bigwigs, and it was open source project. So according to NNEF, they say they have a specification, but Onyx is just a project. But it's not that. Onyx, if you go deeper, Onyx has the entire specification. They have a working committee, and this is also not a point of difference that that it is initiated by Facebook and Microsoft. Onyx is being supported by a lot of companies, and a lot of companies are contributing to its development. So you can see, so this difference between NNEF and Onyx is actually there on the website of NNEF. You can see it is not that good, and it clearly, and the whole reason is it tries to differentiate itself, whereas it is just another competing format, which currently is not doing that well. So that's why Onyx is currently leading when compared to NNEF. So we talked about this Onyx and saw how it is the process of model sharing for deep learning models. But are there any limitations? So often training. So we all know that we all have seen in the past that training and inferencing are done on different environments. You can train on GPU servers and basically deploy a model on a very simple thing as a Raspberry Pi device, edge device, or your even Apple Watch. So the model can be trained using large scale distributed systems, which might take weeks or months to finish, and can be used on lightweight devices such as IoT or mobile phones. But it is desirable to dynamically rewrite the train model. So right now what we do in Onyx is basically we export the model, and then there is a library which has to be written for the particular edge device, which reads the Onyx files and executes it. So this has to be done. It is just kind of serializing the model, but it is more desirable to actually rewrite the model so that it can directly run on the target environment. So there won't be any need for any specific client side libraries, and it can directly run on the target environment. So many deep learning frameworks utilized highly optimized library written for target accelerator, So where the model is rewritten. So they actually rewrite the models by replacing operations in the model with function calls in the library. So on the edge device, suppose there's a library, it will rewrite the model using the functions available in that library. So although this approach has improvement, because now the library of the edge device is being used to actually run the model, but also it has limitations, like the number of models that can be rewritten is small, and also it is limited by the functions provided in the library. Also, user need to install additional packages to make the library work well, and also it lacks the ability to develop code specific to different problems, as the same function, library function, might be used for these models. So till now, the name we were missing in this picture was Google. So to tackle all these problems and drawbacks, Google started developing a compiler system infrastructure that that rewrites a trained model to native code for any target hardware. So this is one of the latest development that is happening. So it was based on the LLVM compiler infrastructure project, and uses many mature optimization techniques developed during the long history of compilers, such as ability to tailor code for specific problems, memory optimizations, and parallelization. So currently, one of the top contenders of Onyx is basically Google, and they have a very well known TensorFlow ecosystem out there, and they have a very good experience of actually deploying TensorFlow flow models across hardwares. So they learn from all these experiences, and they started, and in 2019 they basically presented MLIR, which is a new compiler infrastructure for machine learning. And a bit later, it was actually absorbed into the LLVM project. So now it is part of the open source. So what started as something built inside Google as a TensorFlow project is now a proper open source project under LLVM team. And basically MLIR is, and it's an open standard, anyone can go ahead and contribute. They have a working committee, people from different vendor organizations, partner organizations, they collaborate, they have discussions on how it shall evolve. So this MLIR provides convenient ways to represent complex data structures and operations, which can be translated directly or into LLVM-IR. So LLVM is a very matured infrastructure, compiler infrastructure. So what it does, MLIR basically has all the tools and specifications to export the entire thing into an IR, which can be processed by LLVM which is very mature to support all target hardware and hardwares. So MLIR is basically a representation format and a library of compiler utilities that sits between the model representation and the low-level basically compilers or executor that generate hardware-specific code. So what MLIR does, it takes the export the model exported by the ML frameworks. It imports the graph. It does optimizations to that graph. It rewrites it basically it and then it goes ahead and generates codes as per the target infrastructure, and then that can be easily support that code, that that code can be easily translated into machine code, which can be directly run on the edge devices. So now there is a unified basically infrastructure which does this entire task of ensuring that your model that you're exporting is actually going ahead and running on the target infrastructure without any need of these various interchanges and basically replacement of functions through with library specific functions and all these things, because the LLVM project takes care of that, which is very mature. So MLIR allows high-level optimization and parallelization for the wide range of parallel architectures, including those for GPUs and neural network accelerators. Now, due to this, what happens is basically the TensorFlow machine learning framework, or you can take any other framework, can now have many of its complex data flow graph operations efficiently compiled to native code using MLIR. So it is one of the latest developments, and it is still in progress, and it is definitely an exciting viewpoint of looking at this entire problem of deploying your machine learning models on the edge. So you can learn more about MLIR on mlir.llvm.org. So some of the salient points are like it is blessed in class graph and compiler technology. It is designed for both training and inference. So be it mobile or server. So basically, you have hardware, specific hardware for training. So MLIR also supports that. So you can actually use it for training and also based on the edge device. And you have the ability to scale the deployment, and basically it is independent, framework independent, and the neural and the governance is also neutral. A lot of companies have got together to look into it.
Ankit, sorry for interrupting. Yeah, sorry for interrupting. We have 2 minutes left to summarize.
Yeah, this is the last slide. I'm just getting over it. Yeah. So this is the entire thing that is happening in this in the process of democratizing this model development and deployment. And make sure you look into MLI. It's really interesting project. So this is for today. So if you have any questions, you can connect with me on Twitter and LinkedIn. Also, if you are interested in learning Python, I have a free course available on my website, which is edpunk.com. You can visit my website, and it has a free course on Python, which has 100 lectures, both on dark mode and light mode. So you can go ahead and learn it. So yeah, that's it for the day. Feel free to ask me in the Q&A round, or you can also DM me over Twitter or LinkedIn.
Thank you, Ankit. Thank you for your time, for sharing your experience with us. And now it's time to start our Q&A session. I will let Sergio, and we also are waiting for Kundan, but I do not see him. Okay, maybe we just start, and maybe he will join. So we have a few questions in chat related to Druid.
Okay.
Yep. Can we say that Druid is database that does more and can replace the use of database? I'm kind of confused on how it works.
I would say that the Druid is a database for a specific kind of use case, right? I wouldn't use it as a general purpose database. The use case is really the fast analytic capability, so the fast response times to analytic queries, both in historic and real-time data. If you're looking for a database that does, like, for example, lots of OLTP workloads, this is not the database for that, right? This is an OLAP database. It's meant to ingest once. You could do re-ingestion to do compaction and more and other kinds of aggregates, but it is really an immutable. Once it writes segment data to mutable data, and that's part of what makes it fast at the querying it. Specifically OLAP, fast response times, real-time ingestion, that's the use case. The traditional database workloads of insert, update, delete is not what it's used for and shouldn't be used for. Hope that helps.
Okay, thank you. And one more question. Can you send the Apache Druid course
Absolutely.
like that you showed?
I could put it in the comments here.
Yeah, okay.
Let me do that.
And one question came up. Is there a platform to practice with group? How to get experience on it? Is there a chance for someone who don't have IT background to plan your career on data science? I guess a general question. Here is no mentioned speaker.
Yeah,
Maybe.
basically you can you have Kaggle. Kaggle is a very popular platform to actually go ahead and practice. You can form your teams with people, and you can practice uh, machine learning, data science problems in Kaggle, and you can gain a lot of experience actually, because not only it is Kaggle has competitions, also it also has basically notebooks where where we are basically Kaggle grandmasters. They actually teach how they have gone about solving a particular problem, and you can learn a lot from that. So background is not that problem. If you know mathematics, and you can actually go ahead and actually learn a lot from from Kaggle and other data science platforms. Also, the thing is that I'll suggest you start with instead of directly jumping into learning deep learning and all, start with traditional machine learning. Try to understand how you actually develop a model, how you evaluate those models. It will give you a good idea, because while doing traditional machine learning, you have a lot of statistics that you can try to understand, and it will give you an idea how you can interpret your model. And then once you get a good experience over traditional machine learning, you can transition into deep learning, and you can go ahead and understand various deep learning problems out there and tackle these deep learning problems. Yeah.
Okay, thank you, Ankit. We have one more question. What's the best way to deploy a ML model that completely offline?
Just if you so basically by offline, I'm assuming that you want to deploy it on your S device, usually mobile device. So for a mobile, right now for mobile device, I think the best way is to use TensorFlow export for TF Lite models. So export your TensorFlow models into TF Lite. It is very well supported on mobile devices, both Android and iOS. So if you want to do it for mobile, I'll suggest you go for TF Lite. Yeah.
Okay, thank you. And then another one, recommendation of good machine learning and deep learning courses.
There are a lot of courses. I think it is hard to actually now say that pinpoint that this is a good course. Go ahead and read some reviews, because a lot of courses you might be from a bit earlier and they might not be updated. So find an up-to-date course. That's the most important. Find an up-to-date course. Read some reviews, and definitely you'll find a lot of courses, and that too most of them are free. So yeah.
Sergio, any advice from you?
Well, I'm not a particular expert on machine learning, but what I've learned from quite well is the YouTube channel from Andrew Ng. That's Andrew NG is his last name. If you look him up, he's phenomenal at taking you from the basics to advanced stuff.
Okay, thank you. Is there any book or website on how to learn machine learning format, as the topic seems to be quite broad?
No, actually there is. So these since it was pretty, these concepts have specification. So machine learning formats, you can directly read the specification. It's available on GitHub for all the projects, so you can find the specification. Usually there is no book for these specifications. Once you go book for these formats, because there isn't any book which explains that okay, why you are doing this, why you are using this particular tag, XML tag or something like that. If you go through the specification, they have written those specification in detail so that you can understand it. So you don't actually need any book. Just visit the official specification and go through it. Those specifications are actually explained in detail as to why this particular function is being specified, and why you should go ahead and where it can be used at. So you can go ahead and go to the proper specification. For PMML, there is an official website for PMML. Similarly, for Onyx, Onyx and MLIR, both of them, the specifications reside on GitHub. Those projects of GitHub. So go, and if you, and the people who are working on it are actually, these people are open source folks. So if you have any doubts, you can freely ask them. They will be much happy to actually help you figure it out, why a particular thing is being done, or why you are, if you have any query, they will go ahead and answer it. So don't feel shy, just go ahead and ask if you have any doubts when you read the specifications.
Okay, thank you. And one more, can Docker be used to deploy a model to multiple platforms, Windows, Linux?
Yes, it
and
can
Mac?
be used. Yeah.
Okay.
That was the whole purpose of inventing it.
Okay, thanks. And one general question for each speaker, like, what is the best advice to student in university who is interested in data science? Who can start first?
For students in data science, well, my son is actually starting a course in data science, so I'll be able to tell you more about that in about 4 years. But I'm like I said, I am no expert in data science. I'm more of an expert in data analytics and data processing and data engineering. If anything I can say, it's don't ignore that side of it, right? Also learn about data engineering, about the data pipelines, because they're going to help you in building out the infrastructure to drive machine learning models.
Yeah,
Okay,
actually,
thank
I'd
you.
like to add to it. Actually, that is the truth. Like more than 65-70% of the time is actually spent on data engineering and actually accessing and transforming the data. So if you want to do data science, you have to spend a lot of time with the data itself and processing it. So my suggestion is basically, so to start with data, first of all, take a problem, like set up your weekly goal that, okay, this week I'll select a problem, but make it like you select a problem which is generic. It's not taken from some forum or somewhere where they have the data, they have the problem, they have the data set, everything. Try to think some problem of your own, try to observe something around you, try to come up with a problem, then start finding the data set, because then you will learn, okay, then you will learn the various sources of data, various sources, open data sets, open databases which are available from where you can access data. So kind of make it like a hunting thing, where you start with the problem, you don't know the solution, you don't know how you will proceed. Start with just the problem and go through the cycle. Try to acquire the data from various sites, or you can use web scraping. You will learn those things like web scraping, then APIs, load data through APIs. So take it as a journey. After you acquire data, now figure out how you will transform it. You can use pandas, you can use other toolkits, whichever you are comfortable with. Try to learn new toolkits through which you can transform the data, explore it further. So yeah, that is the good way to start. Start with a problem, something like I want to figure out how the air quality is being impacted in my area due to industries in my region. So then you will try to figure out the number of new companies, new manufacturing units that have popped up in your region, the geolocation data sets of these industries, then how air quality measurements across these regions are being impacted over the time. So then you will try to figure out what are the data that I need, and then try to churn it and build something out of it. And yeah, machine learning will come, but first you have to start with the data part. Yeah.
Okay, thank you, Ankit. It's all questions that we have. Thank you, Ankit. Thank you, Sergio, for joining our Q&A session. Also, thank you all other speakers that share their thoughts and experience with us. Also, thank you, attendee who have attended this block. My shift is over, and before we have a break, I want to introduce you to Lilia. She is going to moderate the event for the next few hours.
Yeah.
Hi, Lilia.
So thank you, Ivan, for your help. Thank you a lot, our speakers. It was great to see you and hear you today. Now we will have small breaks because our next session, it will be workshop. So let's keep in touch and hope to see you soon for 10 minutes. Thank you. So, hi everyone, one more time. I'm happy to present to you our next speaker, Batuhan Ayhan, who will perform with the workshop today. And it will be the last session, and I hope that you will be satisfied and Batuhan could help you to understand more fine-tuning models in Huggingface. Batuhan, the floor is yours.
Okay. Hello, everyone. I can share my screen, actually. Okay, thank you, Lilia. Hello, everyone. Today I'm going to talk about sentiment analysis using Huggingface. But before that, let me introduce to you myself. I'm Batuhan Ayhan. I am from Turkey. I am studying at Hacettepe University, computer science. Right now, I'm at Houston, Texas. I have an internship here, research internship at University of Houston. Right now, I'm working on computer vision, but in the past 2 years, I worked on natural language processing and transformer models. And Huggingface was a big helper for me back then. And right now, I'm a Huggingface student ambassador. I'm preparing tutorials, workshops for beginners and intermediate levels. So today we're going to talk about sentiment analysis, but what will we do? Here's our agenda. First, we are going to define a problem. Then I'm going to talk about pre-processing techniques like word-to-vec, bag of words, and lastly, the state-of-the-art transformers. Then I'm going to show you how you can train and fine-tune your own models using Huggingface. So the problems is something like this. There's a dataset called IMDb dataset. It has two labels like positive labels and negative labels. So you can hear it in the up. I love this movie. I've seen it many times, and it's still awesome. So it's a positive sentence, and we got sentences like this movie is bad. I don't like it at all. It's terrible. So we're gonna try to predict whether a sentence is positive or negative by learning from this kind of sentences. So before going into details, I'm going to talk about what is different in natural language processing than other areas. For example, in tabular data, we got numerical features, categorical features, and somehow we use their numerical features to give a machine learning model. Or in computer vision, we use pixel values from images to give the CNN or something else. For speech, we have like frequencies and samplings and all that, and they're all numerical. Even if it's something not numerical in tabular data, we use vectorizing them, one-hot encoding and all that stuff to get a numerical feature. But in natural language processing, we can't. We must do that. As a pre-processing step to get a vector or something numerical to give a machine learning model, because we can't give, as you can see here, I like this article. We can't give a free text area to machine learning model. We need to convert it to some space and use that vectors, use that numerical features to do something with them. Here we are trying to classify them. Here's the thing. So one of the basic methods is that a bag of words. It's not used right now, but I want you to know that as a history of NLP, what people did in the past. So I like this article. So here is our vocabulary. I like this article, medium data. So this is all the words we can embed in our space. It can be like, here's just 6, but it can be like 10,000 or something like that. So I like this article. We can embed this sentence like this. If you see a word in our vocabulary, and if you see that in the sentence, you put a 1. So I, 1, like, yes, it's in this, yes, article, yes, medium, no, it doesn't appear that, so 0. Data doesn't appear in the first sentence, so 0. So here's the 1, 1, 1, 1, 0, 0. It's our first embedding for this article, for this sentence. For first sentence, my embedding is here. And for the second sentence, I, yes, like, yes, medium, yes. As you can see, the other ones are 0. So I embed this second sentence like 110010. So this is my embedding. It's a pretty basic embedding, but it doesn't contain any information about semantics. I mean, it doesn't contain any information about the sequence. For example, let's look at the third sentence. I like data and data I like. These are two different sentences and pretty similar to each other. However, their embeddings are exactly the same, because bag of words is not looking for sequence and or any other things. It just looks whether it is in the sentence or not. So it's a pretty basic thing, actually. So after that, people try to use more advanced things like word embeddings. Maybe you heard of word2vec, fast text, and all that. These are the word embeddings, and this word embeddings trying to map the words to a feature space, a lower feature space, because in here you can see if we got 10,000 words, we got like 10,000 spaces, and it's so big to compute all that, and it's not feasible. But here people try to do something like, okay, we got let's say 100 features, feature space. We are trying to learn not like this discrete variables, but like continuous things. For example, in here we got 300 feature space here, so we are trying to learn what is that. Instead of giving something like this, we are trying to learn which word embeds to which feature. So in order to learn that, we use word2vec. For example, word2vec is an example of this. So you can think of these columns as the features they represent. For example, man is gender -1, age 0.02, something like this. So but when you look at woman, gender is 1. As you can see, every column represents a feature, actually. I mean, we can think of that. It may not be so clear as this for us, but the technique learns that these are related. So here you can see that man, woman, and king, queen. So they are semantically close to each other. So when in the word2vec, we see that if we subtract queen's vector from king, and if we subtract woman's vector from man, we get similar results. So it shows that word2vec is a good way to represent words. So, but in order to use these embeddings, we use sequential systems like LSTMs and RNNs or something else. But today I'm going to talk about transformers, and in the transformers we are basically doing a parallel computation, so we can't use this word embeddings. So what transformers do is it uses a positional encoding. What's a positional encoding? I'm going to talk about that, but before that, let me show you the transformer architecture. So instead of giving words, you can think of them like words here, but we are going to talk about it a bit later in the workshop. So let's say word 1, word 2, word 3, mask, and word 5. So I'm sorry. In the words, we can't give sequentially. We need to give them parallelly. So what transformer uses is it uses a positional encoding. It says that, okay, this, for example, let's take it as a sentence. I am a robot. So its index is 0, 1, 2, 3. But instead of giving these indexes as positions, we can give them as positions, but it's not feasible because the input sequences may vary, and it can go something like 40, 50 index, and it's not feasible to use them as a position. So instead of doing this, the transformer, the writers of the transformer paper propose something like this. So they use sine and cosine based formulation. I'm sorry, but we can't talk about this in detail because we got limited time, but you can see how they are formulated this. They use something like, for example, for the first sequence word, they always use 0, 1, 0, 1. And the second one, 0.84, 0.54. And it goes like this for based on the index. they use this formulation to get the positional encodings. So what do they do with this positional encodings? First, we got a word embedding vector, like you see here. And after that, a positional encoding is applied here. After the positional encoding, it goes into the transformer. After that, you see input embedding comes here. For example, for the word I, a feature vector comes, then the positional encoding added to that. And upon that, there's a mechanism called attention mechanism. I'm going to talk about that in a bit right now. And then feed-forward neural network and all that network. So it tries to learn. So it first it learns embedding, then it learns how these words relate to each other, how what's the differences, what is referring to what, and then we try to classify the thing we want. So here's the attention mechanism. You can think attention mechanism like convolutional filters. Actually, they look alike. So when you see a bird comes here, the animal didn't cross the street because it was close. So the it refers to animal right here. So you can see that with this color. The color indicates that they're strongly correlated. For example, for orange here, the animal correlates with it. And for the other filter, you can think of filter, we call it head in attention. That's why it's called multi-head attention. You can think of it like it has multiple filters, and all the filters are learning different things. For example, it is correlated with tired here. So attention mechanism learns here which words correlate each other and all that to give us an insight about our data and the task what I'm trying to predict. So here is my slides. Right now I'm gonna show a code, but before that, if you have any questions, I can take it or I can take it after the code session as well. So let me quickly share my screen. Okay, can you see it? Okay, I think it's right now. So I'm gonna walk you through this notebook. It's similar to Huggingface tutorial notebooks, but I added some nice things to show you. So let me walk you through this. So first of all, we need to install the transformers. This is Huggingface library and datasets. When it's loading, let me show you. First, we need to import the IMDb dataset. It's already in the Huggingface datasets library, so we can just load it from datasets, import load set, IMDb, load dataset, IMDb. You can put something else here if it's in the Huggingface, and load another dataset from the Huggingface. Show that to you as well. So I need to stop my screen share and restart it. Okay, here's the one. So Hugging Face has a lot of data sets, as you can see, like 6,000 and a half. So you can use any of these data sets with just this command, load dataset, and you can load, whatever it is, the thing you are looking for. So let's look into IMDb dataset. So when we import these datasets, we see something like train, test, and unsupervised. We are going to use train and test datasets, and it has something like 25,000. So, and we got 50,000 for unsupervised. Unsupervised means they have no labels. So we are not going to use that, but if you want, you can use them for something else. So let's see what this has. So it's a dictionary. So it returns a dictionary to me. First, I look at what's inside the IMDb's test dictionary. I see that there's a lot of things which includes dictionaries again. So I take only the first one. Its label is 0, and it says a text something like, "I love sci-fi and I am willing to put it with a lot. Are usually underfunded, underappreciated, and misunderstood. I try to like this, I really did, but it is too good to watch." So it goes something like this, and it has a label here. So let me see another thing. Maybe we can see a shorter one. Yeah, you can see there is like 25,000 sentences like this with labels. So what we are going to do is we are going to use pre-trained transformer models, because transformer models are actually very big for training from scratch. They need a lot of data. So instead of doing this, we use Huggingface library for pre-trained big transformer models. Then we use them as a feature extractor, then fine-tune on our small data sets like here. It's a very small data set for not small, but we can say medium, but definitely not enough for training a transformer from scratch, big data. So we use here birth-based Ankit. You can see, actually you can see here, there's like more than 50,000 models here. So birth-based Ankit. So Hugging Face allows me to do this. I can use any model here with just 2 lines of code. I'm sorry. Here, with just 2 lines of code, I can import them. So it's a very good practice to use Hugging Face for fine-tuning big NLP models. So we import something called tokenizer. It's not a model yet, but this model's tokenizer. So what's a tokenizer? We talked about the word embeddings and all that, and transformers, like I said, actually they don't have word embeddings, but they have tokenized embeddings. So let me show it to you. So we got a sentence like this. "Welcome to the tokenizers library. This is a tutorial for students." I added that part, for example, and tokenizer, let me run it for you. So first, every for Bird I'm talking about, for this model, it starts with CLS token. So it means that I am starting to give you my input. It means that then welcome to the, it's an unknown token. It's for this character. So it's a Unicode character, but my model doesn't know every Unicode character. So it puts an unknown token for unknown characters. And as you can see, it says tokenizers, but it doesn't take tokenizers as a word embedding. It splits them into tokens. Token, you can see double dash here. So it means that they are separated from a word, tokenizers, and S. So it basically works like this. It tries to match with the longest sequence of tokens. For example, it started with T. So it looks for, if I have a token with TO, then it looks TO key, TO key E, TO key E, and then it looks like, do I have a token like this? Sorry. So if it doesn't have a token like this with I at the end, it takes this token and starts looking from here. Do I have a token like I? Do I Z, E, R, S? So it doesn't have this token, so it just uses this token and splits the rest of it. So, and at the end of that, we got a separated token. So basically what this do is, transformers have fixed sized inputs. For example, it can have at maximum, let's say something like 100 tokens. So we need to pad them because it's a parallel architecture, as I showed. So we need to use an empty embeddings to just put them so they can not give any errors because they are empty. So we just use this separator token, which this is something like saying the tokens before separator are important and other ones don't. It's just to teach you model that. So and now we need to truncation, open truncation. It's just basically those, if a sequence is just too long, we can't compute them because we don't have enough tokens in our architectures. It just cuts them. Truncation means that. So we need to map this function to do that. And then after truncation, we may have some, as I said, two little sentences with less words. For example, my name is Batuhan. We need to fill this up here. We need to fill with random embeddings and padding embeddings after the separator token to give that to model, as I said. So we are going to do that right here. And I'm going to say return tensors TF. It shows that Huggingface in the backend, it has, you can use TensorFlow, you can use PyTorch. So sometimes you need to tell them explicitly, I'm going to use TensorFlow because Huggingface in the first days of Huggingface, they only have PyTorch. So sometimes you need to say explicitly, like I am going to use TensorFlow and like that. So for the training, it's done. For the testing, it's done. Now it's running for the supervised dataset. Like here. So, okay, let's pad them using this. By the way, some of you may ask, we can do the padding right here using padding, but we choose not to because in the new updates, they say that using this data collator with padding is faster than using here in the documents. Huggingface say that, so I started to use this data collator with padding instead of just tokenizing my padding my inputs with my tokenizer here. So we have a batch size 4. You may increase that if you have a big GPU, but I'm just going to leave that for now. And we need to, we are going to use TensorFlow for training this. So we need to create a train set and validation set. So what I'm going to do is, I'm just going to take this tokenized IMDb's train set and use the TensorFlow's function, Huggingface function to TF dataset. And it's basically shuffles the data sets. It uses this batch size. It uses this data collator padding. And I'm going to use this columns. So what's actually is input IDs is just, I'm sorry, we got a, not okay, we are going to use that in a minute. So input ID is just things here. Yes. Actually, let me show you what is the real output. As you can see, we got a bunch of numbers. These are the input IDs to these tokenizers. So what they're basically do is they represent the tokens, which tokens, their input IDs. So we got attention mask. Attention mask is the thing I talked about again. After the separator token, we got unrelated, some random tokens. We don't want them to affect our input, so we just mask them. Attention mask is for that, and label is just our labels. So we do that again for same thing for the validation set. And let me run this again. So right now, our data is written. What we need to do is now trying to create our model and start training for it. And from transformers, import create optimizer. First, I need to, of course, create an optimizer. And I'm going to use TensorFlow. That's why I'm going to import that. Number of epochs is 5. Actually, I'm not going to run training because I'm just going to show you the result. But you can, play with these parameters and see for yourself because it takes a long time if you don't have a good GPU, and it takes a lot of time. So we can't do that in a limited time here. So I'm just going to show you how can you train, and then I'm going to show you the results of that. So batches per epoch. Batches means, if you don't know what a batch size is, it's the things we parallel in compute and take one gradient at a time. So instead of going with saying that, okay, you got a sentence like this, I like this movie, you don't update your parameters immediately. You just do that for four sentences. Then you get a result for averaging 4 of them. Then you update once. So it increases the time for an epoch and total train steps, and it's the number of epochs times batches per epoch. So we are creating an optimizer, and we are setting the learning rate low. It's because there are actually two reasons why we choose learning rates to be low in training transformers. First, it is as you some may already know, it's using low learning rates is a good practice in fine tuning, because we already have so much layers with good weights, learned good weights, and we just need to change our last layers to fine tune. So we don't want to just relearn that all things. So that's the reason one, and this reason two is transformers really work well with low learning rates. And we got 0 non-warm-up steps for learning rates, non-train steps. Then our optimizer is ready. Now we are going to pull a pre-trained model, like I said, from here, bird-based uncased. So you can see it has PyTorch, TensorFlow, JAX, Rust. So you can use it with anything you like if that supports it. So we are going to use that model, and we only have 2 labels, as I showed you in the beginning, like positive sentences and negative sentences. So I use TF auto model for sequence classification. So if you write this, it just creates the backbone of the network for you. It's actually the power of Huggingface comes from here. You can do with just like 5 lines of code, you can pretty much train any state-of-the-art NLP model or something like that. So it's very easy to use. You can use other people models like that if they share. So it's very good framework to create baselines, play with the models, and share your models if you want. So it's going to take a while to download. And then we are in TensorFlow, so we need to compile our model before training. Then we will start the training. But like I said, I'm not going to start training right now because, as I said, it takes a lot of time. So it just gives an warning. It's nothing. It just says that you need to fine-tune this model to use that. Then model.fit xtrain. So let me just start it for you, but as I said, I'm not going to finish that because it takes a lot of time. But you can try for yourself. I'm going to share this notebook with you, so you'll have a good sense of what you can do. So as you can see, it says 50 minutes, so we are just going to stop that. And I'm going to show you this model. So this is a model I found before preparing this workshop. And let me search it for you. So I just come here and say, okay, IMDb dataset bird. Sorry, let's see bird first, then IMDb bird, something like this. I searched for this, then I found this bird-based uncased IMDb. someone named Text Attack just published this, and I found it, and I just, like I said, put this here, like dataset. It's pretty much the dataset and the tokenizer. Here you see how we can use this token model, and tokenizer is right up here. Get the tokenizer and dataset. They pretty much look the same. You just give the name of the think of it's like a repository, a GitHub repository. You just give the name of it, and it's automatically pulls it for you. So we are gonna use this model right now, and this model only supports PyTorch and JAX, as you can see. So we say from PT true to explicitly saying that I'm going to use the PyTorch version, and I need this tokenizer. Sometimes tokenizer may not be compatible with each other because they are different models, because they different people train them, so they may change a few things in the tokenizer. So make sure you are using the right tokenizer for your model. So let's download this too. And after that, there's a magical function here, pipeline. It's you just give it a model and tokenizer, and when you give it a simple text, it gives you the answer right away. So let me run it for you. Then it will create a pipeline. Then I really hate this game. For example, let's first let me remind you, this dataset is trained on movie dataset. So when I run this classifier, I got label 0. Label 0 means negative, by the way. I really like this movie. You got label 1, as you can see. So I really love this game. It still gives me the label 1 because it learned the features of the what is good and what is negative and what is positive. So we can use this model to sentiment analysis things in here. So let me show you around a bit in Huggingface too. So what you can do with it and all that. So when we come here, we got models, datasets, and spaces. I'm just going to talk about these two today. So when we come here, I showed you here like more than 50,000 models are here. So we can filter them with different things. It's Huggingface started with natural language processing, but it's so big right now. It supports computer vision, audio, multimodal, and tabular, and they started reinforcement learning too. So it's pretty big thing right now. Actually, Huggingface, they are almost support anything state of the art. So you can, let's say, text classification. We are doing text classification. So as you can see, you can filter these models to see what you are looking for, or you can use languages, as you can see. For example, let's look for Turkish, for example. Yes, this one. So we got these models for Turkish. So if you are looking for French, you can just look for French and use anything you want from this for your task. As you can see, you can use question answering models, summarization models, text-to-text generation models, zero-shot classification models. We got almost anything you need. So let me show you the datasets. We got datasets, and again, we got different tasks. We can use multi-label classification, topic classification, or sentiment scoring, as you can, sentiment analysis. You can use these kinds of datasets to train your own models. Maybe then you can share it with people here. Then we can use your model to do what we want. So and you can use different things to, it supports PyTorch, TensorFlow, JAX. It supports much of that. Most models most models support PyTorch, TensorFlow, and JAX, but sometimes some of them don't, because when people train this model, they don't upload weights for TensorFlow or JAX. They just upload for PyTorch. That's why you download PyTorch version. But it's very easy to convert between PyTorch and TensorFlow, because you can convert in the Huggingface. For example, you see we download the PyTorch version because it didn't have any TensorFlow version. Let me show you again. This one. So it only has PyTorch and JAX version. So, but you can download this model in PyTorch version here. Then using Huggingface, you can convert this model to TensorFlow. It's actually pretty easy. And then you can upload it for in your own repository and share it with the people, so they can use whatever version they like. So actually, it's all I'm going to talk about. It's been like 25 minutes, so we got, I think, 5 minutes for questions. So are there any questions?
So, yeah, we have some questions. First one is, what is the percentage of validation set?
Yeah, here we just use 50-50 because we got 25K for training, 25K for testing. That's why, but usually the percentage is something like, with this size of the data set, something like 8 to 20.
Okay, thank you. And second one, why S is separated from Ether?
Actually, it's the thing in the transformer tokenizers, they look for the longest sequence. So it means that Ethers is not a token, but Ether is a token. So it takes the longest one and separates S from Ether.
Okay, thank you a lot. Here's some questions on Turkish, but unfortunately I cannot read it. Probably after session I will send it on.
Yeah, okay.
I will share it with you. Actually, that's all. I think we will have more questions after recording will be available on our platform and YouTube also. And I will share with you. You can also reach out Batuhan on LinkedIn and another social network.
Let me send you the links, actually. If you want.
It will be great. Thank you. And yeah, actually, that's all for today. Thank you a lot, Batuhan. It was nice to see you and hear you today. Your workshop was very interesting for me, actually, and I think for our attendees also.
Thank you.
I will waiting for your feedback and for feedback from our attendees, and we'll be happy to reconnect with you in November. So that's all for today, and I want to say the end of the first day of our summit, and I'm looking forward to see you tomorrow. And probably Nick, would you like to add something?
Yeah, thank you everyone for watching, and thank you once again. Thank you, Batuhan, for giving this workshop live. So yeah, I'm glad. Like, I'm sure more people will watch, because like it's always like this. People get a little bit tired by the end of every live stream. So, but we will get more people watching this, definitely. Yeah, thank you once again. Yeah, bye. See you on our later events, definitely. Yeah, take care.
See you.
Yeah, so that's it for today's live stream. We have tomorrow our prod track. We have on Thursday we have bootcamp, and like some of you who are still in the chat, you should be able to switch from first day to second on top of the chat, or you can just join the same link tomorrow, and you'll see the prod track there, because we gave you the ticket, and everybody will be waiting for you tomorrow. We have a much more like by now tomorrow we'll be still going, and we'll have more talks left. So yeah, thank you everybody, and we'll see you tomorrow. Take care.
Thank you. Bye bye.